Hey, it's me, Brian, your host for today. So what we're going to cover, ratios, rates, and proportions, word problems. Let's hit it.
Hey everybody, welcome to Ratios and Proportions Word Problems on the T6 math course with me, Brian. So let's jump right into it and get it started for today. Our goal is that we will be able to solve word problems involving ratios and proportions. When we talk about ratios, ratio compares the sizes of two or more values. Now, ratios are different than fractions because ratios allow three different ways that we can write them. So we have part to part to whole, or whole over part. Now, the only thing that fractions have in common with ratios is this one. Part over whole is what you're used to seeing for fractions, but ratios allow us to compare different parts. As you see, A and C are different than how we would write fractions out. So ratios are different. When we have a proportion, that's two or more equivalent ratios. So if we had 2/3 is also equal to 4/6 is also equal to 6/9. This would be considered a proportion because it's two or more ratios that are worth the same amount. Ratios can be written in three different ways. You may see it as in option A, where we call it A. All three of these are called A to B. So we have part to part with the colon. It might be written out A to B, or it may be written as A over B. So you may just see these three different forms, but all of them can be written as ratios. When we have proportions, they're treated the same way as equivalent fractions. So what you do to one part of the ratio, you must do to the other part. So if we look in this row here, we know 5 became 30, and we're looking for what did 4 turn into. I know that 5 times 6 is 30. So if I multiplied 4 times 6, this question mark should be worth 24. Because in fractions, we multiply the numerator and denominator by the same number to create equivalent fractions. We do the same thing with ratios. If we multiply the top and the bottom part, or each part of the ratio, by the same number, we get equivalent ratios. 3, if a clear relationship is present, use those to fill in missing pieces of a proportion. So I know that 15 divided by 5 is 3, and I know I can also do 20 divided by 5, which would give me 4. So instead of having this question mark here, our final answer would just be, let's erase this and move it over, 4. Boom. You can also use what we call cross multiplication. So we use opposite corners to multiply together. So we get x times 15, which would be 15x, equals 3 times 20 is equal to 60. We would divide both sides by 15 to solve for x, and we get x equals 4. Key point number 5, make sure to include units at the end of the problems. So just means whatever you found. So for example, if we took the last one and we ended up with x equals 4, say the problem was talking about puppies, x equals 4 puppies. It's really good just to write that on your paper so that you know, if it's a multi-step problem, what you just found, so you know what to do next with the information you just solved for. Now, why do we do this? So oftentimes we have to adjust a given recipe or an amount to suit the needs we have specifically. So by setting up ratios and proportions, we can ensure the amounts that we need are correct. This can be used in adjusting medications, especially when you have to adjust them based on height, weight, or even making any other adjustments, especially including baking recipes depending on the servings you're making. So we talked about the two biggest ways that you see them, but ratios and proportions honestly are everywhere. So let's go. With our sample questions, again, we've come to these. So 3 options: do these on your own, do these with me, or a mix of both. So let's look at sample question number 1. We have 4/5 is equal to 6 over x. Now, in this case, there is no clear relationship between the two. So I can't look for what our multiplier would have been, or 4 times what equals 6. It's just not as clear. So instead, we're going to cross multiply. Now, I like to include the x first because I like the x on the left side. Personal preference, just of teaching and algebra, usually the x is on the left side. So I know 4x is equal to, I do 5 times 6 is equal to 30, and then I solve from here. In order to solve for x, I'm going to divide both sides by 4. 4 divided by 4 is just x. 30 divided by 4 is going to be 7.5. There are no units here, so it's just 7.5. So I know that 4 over 5 is equal to 6 over 7.5. So if you wanted to see the finished proportion, but it did not ask us for that, it just asked us for the x value. Sample question number 2. Again, we're going to solve for x. We have 15 over 35 is equal to x over 21. Now, as I look here, I also don't see a very strong relationship between 35 and 21. So I'm going to cross multiply. So I'm going to do 35 times x because I like the x value on the left. And that's going to be equal to 15 times 21, which is equal to 315. And if we divide both sides then by 35, we get x is equal to 9. So we get 9 would be where the x value would be. Question number 3. A batch of 24 cookies requires 1.5 cups of sugar. How many cups of sugar are needed to bake 84 cookies? Okay, so when we set this up, we look for what we absolutely know. A batch of 24 cookies require 1.5 cups of sugar. So I'm going to set this up. I have 24 cookies and 1.5 cups of sugar. Now, it's good to put some labels here so that this way you know what you're talking about on the top and what you're talking about on the bottom, and you don't have to keep looking. So it says how many cups of sugar are needed for 84 cookies. Because the question is asking for how many cups of sugar, I know I'm missing that part, and this says 84. So I'm actually going to cross multiply and solve. So 24 times x, 24x is equal to, we do 1.5 times 84, which gives us 126. And we know this from here. We're going to divide both sides by 24. And we get x is equal to 5.25 cups of sugar. So we get that as our final answer. All right, sample question number 4. The ratio of in-state versus out-of-state students at a university is 5:3. If the university has 4,568 students, how many students are from out of state? Okay, so we look at in-state versus out-of-state. What I see this as, it says 5:3. Now, I have to think, in this ratio, are the 5 and the 3, is one of them, or both of them parts? Is one of them the whole? So if I thought about it like this, I have 5 to 3, which means I have a total of 8 parts. So if I'm looking for out of state, and I know that 3 out of 8 are out of state, that's my ratio. Now, how did I know to use the 8 parts and not the 5 or the 3? Because when I looked right here, it said the university has 4,568 students. And that was total students, combined to in-state and out-of-state. It didn't say I had this many in-state or this many out-of-state, which I could have used the ratio provided should it have said in-state or out-of-state. Since it didn't and just said total students, I needed the total number of pieces, which was 5 plus 3, which gave us 8. So now I can set up my proportion. I have 3 over 8. So remember, this is out of state to total is equal to, so the 4,568 goes down here because that matches the total number of students, and the x goes above because that goes with the out of state. So I still cross multiply. 8 times x, 8x. 3 times 468, 4,568, excuse me. Whew, I could feel that I said that one insane. So equals 13,704. Divide both sides by 8, and we get x is equal to 1,713. So what it means is out of state students are equal to 1,713. Sample question number 5. Austin reads 35 pages a night before bed. If it takes him 8 days to read his entire book, how many pages are there in his book? So the first thing we're going to do is look for a completed ratio. So if I look at the first sentence, I see that it says he reads 35 pages a night before bed. So how I notice that, it says 35 pages per one night. So that is my ratio that is completed. So now we look for what's missing. If it takes him 8 days to read his entire book, how many pages are there in his book? So I see 8 days and how many pages. So one thing I know that's missing is going to be the number of pages, because that's what the question was asking for. And we know that it takes him 8 days to read his book. Now, if we look, you may notice that there's a difference that I have night here and 8 days. Because he only reads once a day, it just so happens to be at night, it's okay that these two units are a little different. If it made you feel better, we can actually change it to 8 nights. And that's totally fine if you needed to see that. But either way, it still matches. So then we can cross multiply to solve. So we have x times 1 is equal to x, because we don't have to write the 1 in front. And then we have 35 times 8. When we multiply 35 times 8, we do get 280. 280 what? Those are 280 pages. So there are 280 pages in the entire book. Sample question 6. The ratio of students that passed a science class versus failed that same class is 10 to 2. What percent of the students failed the course? Okay, so if we looked at, it says the ratio is 10 to 2. And that is students who passed versus failed. So if we looked at passed, failed, and I'm thinking of like some sort of bar model to see this, I know that this would be 10 parts to 2 parts for failed, which means there's a total of 12 parts. And I'm going to hold on to that for just a second to see if I can use that. So ratio, we have this here, and it's drawn out. It says, what percent of the students failed the course? Now, percent is out of 100. So percent is part over whole, because whole is equal to 100%. So that means that's how I actually need to think about the part that I'm working with. So I know that I'm dealing with students who failed, and the students who failed had 2 parts. And I'm trying to find out if percent, which is out of 100%. So my whole is actually going to be 12 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There were 12 parts in this whole thing, and we're missing the percent, which is the x up top. So same cross multiply and solve. 12 times x, 12x. 2 times 100, 200. Divide by 12, divide by 12. and we get x equals 16.67%. It was really this. It kept going on forever. So generally, we look at the second place value. The 6 tells us to become a 7, and we keep it here. So question didn't ask for it, but know that that's generally how we write this here. Sample question number 7. Dr. Sullivan can handle 1 patient every 20 minutes. How many patients can Dr. Sullivan see in 3.5 hours? Okay, so let's look. We look for a ratio to start. That says 1 patient every 20 minutes. So we know 1 patient in 20 minutes. And it says how many patients, which means whatever's next, I'm missing the number of patients. That's what the question's asking for. And it says 3.5 hours. Do you see any issues with the way that we set this up? Well, the left side says minutes, and the right side says hours. So we have 2 different measurements. So what we're going to do, and I usually think it's best to put everything into the smallest units possible. So let's change everything into minutes. So if I took 3.5 hours and I multiply that by 60 minutes in an hour, that's going to give us 210 minutes. So instead of 3.5 hours, we're going to change that to 210 minutes. Now I have minutes to minutes. I have everything I need. I have the right units. So now I can cross multiply. 20 times x, 20x. 1 times 210, 210. Divide both sides by 20. And x is going to be equal to 10.5. But what we have to think about in this problem is it says how many patients? Can you see 0.5 patients? No, that means that the doctor would not have finished with that patient. So we're going to say x equals 10 patients. These are the tricky ones. So make sure when you get a decimal answer, you have to look. It said patients. We can't have 0.5 of a patient, so we have to go down. All right, sample question number 8. The Frohl family is going on a road trip. They travel the first 350 miles going 60 miles per hour. They stop for 20 minutes at a rest stop before completing the final 220 miles going 80 miles per hour. How long did the road trip take? Okay, so let's look. Frohl family is going on a road trip. Wonderful, not going to help us. They travel the first 350 miles going 60 miles per hour. Now we're dealing with time. So we're going to look at part 1. Okay, so let's just give ourselves some space. So I have 60 miles over 1 hour. And I'm looking for how long it takes to go 350 miles in how many hours. Now, I have to also think for a second. Let's do hours first, but know that later on we do have to add in the 20 minutes. So let's see. Okay. So if I cross multiply, 60 times x is 60x is equal to 1 times 350. So I see 350 divided by 60 is going to give me 5.83, and that's going to continue on forever, so let's just do 5.83. So if I divided, let's actually write out what happened. Divided by 60, x equals 5.83. But it's 5.83 what? Hours. So it's going to be 5.83 hours. So step 2, we know we're going to add 20 minutes to a rest stop before completing the final. So, but this is in hours. And this is 20 minutes. So I know something is going to be a little funky. So we're going to hold off on that for a second. Let's look at part 2. And I'm going to still give us some space. They stop for they final 220 miles going 80 miles per hour. So in this case, we have 80 miles per 1 hour is equal to 220 miles in how much time? So same as step 1, but just different numbers. 80 times x, 80x is equal to 1 times 220. Divide both sides by 80, and we get 220 divided by 80, which is 2.75 hours. Now, what I'm going to show you is this next little piece. So we're going to see. So in step 3, let's combine these two parts 1 and 2. So we have 5.83 plus 2.75. And know that if you had multiple choice, your answer may be off by only the tiniest little bit because you did have to round off the number that repeated on forever. So if I get 5.83 plus 2.75, that's 8, 15. So we get 8.58. Now, some of you, I know this, are going to immediately tell me that is 58 minutes. That is wrong. What we have right now is 8 hours, and you have 0.58 of an hour. So, what you really have to do is you take 60 minutes times 0.58 and that gives us 34.8 minutes. So if I erased all of this, and you can go back to it if you need it, but we're doing this just so we have some extra space. Where we are at right now is we had 8 hours and 34.8 minutes. Knowing how to find the minutes is going to be the most important part, because a lot of us, I've gotten this a lot of times, is that we would say, well, it said 0.58, so that's 58 minutes. 0.58 is out of 100, because that's 58 hundredths. But minutes are out of 60 minutes, so it's not even the same base, so we cannot just assume that it's 58 minutes. So we then have to add in the 20 minutes from the rest stop. Oh my gosh, that ES at the end. Whew. So that gives us 54.8, 8 hours, 54.8 minutes would be our final answer. The time ones are difficult. Please make sure that you know when something is not out of base 10. All right, it is your turn to go practice this, to go try it out. And best of luck with this. Can't wait to see you soon. Hey everybody, Brian here at Nurse Hub. It is so wonderful to have you here with us. So today we're going to be covering writing expressions and equations. Hey everybody, welcome to Writing Expressions and Equations on the T6 math course with me, Brian. Let's get right into our lesson for today. Our goal for this lesson is that we will be able to write algebraic equations and expressions from different scenarios. First key vocabulary word is the word expression. So this is a number sentence that is left open, so it has no equal sign. And they can have many answers depending on the situation. So, for example, we have 5x plus 2. It doesn't give us a lot of information, so we're able to say, what happens if x is equal to 3? You could then put 3 in, which equals 15 plus 2, which equals 17. You could also put in 100 because it doesn't give you any other information. Then this is just the equation. So there are infinite amount of answers when we have an expression. Next, we have an equation. So this is a number sentence that is set equal to something else, and it may or may not have many answers. Sometimes an equation may have answers. There are times like when you have absolute value where you have two or more. But if we look here, in this case, x, it would be worth one value. So we would be able to solve for the x value. We'd get 3x, as this cancels out, equals 15. Divide by 3, divide by 3. X is equal to 5. So in this case, x is worth one value. When we do these scenarios and you're trying to write an expression or an equation when you're given some sort of description, it's just to read the whole scenario first. Try to understand exactly what's happening before you decide to break it down. And then you're going to start left to right and read the situation and write down what is happening piece by piece. So if it says 4 more than, okay, it says 4 more than, and I want 4 more than something. Okay, that's plus. Then moving on to whatever the next piece was. Now I just made up that scenario, so if you didn't see it, that's why. Just pulling things that I know are going to come up later. Then figure out what you don't know. That's the variable. So if we're writing an equation or expression, there's always something that we don't know. So in this case, it says 4 times a number. If it says a number, do I know what number that is? No. So I'm going to choose a variable. I'm most likely going to choose x, just it's the one that's most commonly used. And it says 4 times that number. So I want 4 times a number. That's multiplication. So it would be 4x. Pay attention to operational words. And when I say operations, I mean addition, subtraction, multiplication, or division. So things like more than, times, in addition to, multiplied by, less than, split into so many pieces. So these words are going to give you the clues as to what is happening between the numbers and the variables that may show up. With subtraction and division, order matters. So one of the things to pay attention to is when you see something that says, if we have 8 less than 12. And I want to use 2 numbers here because I want you to think, what is 8 less than 12? We know that it has to equal 4. This is the weirdest way to put subtraction. And the biggest thing that when you read it, you have to take a second and say, like, I need to figure out this order. You have 2 options. Is it 12 minus 8 or 8 minus 12? Which one of those would have gotten you to 4? Well, it's actually 12 minus 8. When you say 8 less than a number, it's really saying take away 8 from the number that comes next. So it does matter, the order does matter, because 12 minus 8 is 4, but 8 minus 12 is negative 4. 2 different numbers. So really pay attention to the order when subtraction comes around. And division too. But division doesn't have as confusing of wording as subtraction. Draw or model the scenario if needed. So if you need to say 4 times a number, say that's up there again. We decided this number was x, and I know I have x. 4 times, okay, this must be then 4x. Something that if it gets confusing, one of the strategies is you can try to write out a picture or visual to help you. Now, why do we do this? So real world scenarios, unfortunately, are not given to us in the form of an equation or even an expression. We have to be able to interpret different scenarios and situations and determine how best to solve them. This will often involve mathematical expressions or equations. Knowing how to set up, use, and check your expressions and equations is going to be a huge benefit. That's also something that's really going to help you solve word problems. Being able to build your own expressions or equations, understand how to read something, and make an equation or expression out of it is going to help with all word problems that pop up. All right, it is time for our sample questions. So as always, you can do them on your own, with me, or anything in between. So let's take our sample question number 1, and it says 7 more than 3 times a number. So I see 7 more than. And if I want more than something, I know I'm going to add onto it. So I'm going to do 7 plus. And then I look at the second piece. 3 times a number. A number is x. And I notice that times means multiplication. So I'm multiplying this x by 3. So I have 7 more than 3 times a number. So my final answer is 7 plus 3x. Notice, we're not solving for x. We're just writing an equation that we would be able to solve for x. Or an expression in this case. Sample question number 2. The sum of 2 numbers is 56. So let's look. I know the word sum means addition problem. Because sum is the definition is the answer to an addition problem. Of 2 numbers, do I know what those are? No. So I know one of them could be x, but some of you may say, well, should I write the other one as x? If they were both x, it would have said the exact same number. But it just says 2 numbers, so they could be different. So I'm going to give the other number a y value. We also see the word is. This is one of those really good indicators that this is going to be an equation because then it's an equal sign. Is, almost always in these situations, is going to be an equal sign if it's just by itself. And then we see 56, so I'm going to put 56. So my final answer would be x plus y equals 56. Sample question number 3. 9 less than half of a number. So let's take the first part. I want 9 less than something. So that means whatever's happening, I want to take away 9 from it. So I'm actually going to move this over here because I know subtraction order matters. So I want to make sure that I put whatever's happening next in front so that I could subtract 9. And this is half of a number. So we have a few options. I know that if I want to find half of something, I can divide it by 2, or I can multiply it by 1/2. Either are going to get you the same idea. So what I'm going to write is 1/2 of a number, which is x, because I don't know what the number is. So I have 1/2 of x minus 9. So that becomes our final answer when we put everything together. Sample question number 4. And there's a lot of numbers here, so let's hang tight. 5 more than 4 times a number is 3 less than 5 times a number. Here's the first thing I'm going to pull out. I know after I read this that there's going to be 2 sides to this equation. So I'm going to deal with this side and this side because the is letting me know that there is a balance. So those 2 are not going to end up on the same side. I first see 5 more than. Okay, so I want 5 more than something. That's 5 plus. 4 times a number. We don't know what the number is, so that's x. And it's being multiplied by 4 because it says the word times. So it's 5 plus 4x. Now this whole side is done. Next, it says 3 less than. I know that means I'm taking away 3 from something. That whatever amount I have, I want to take away 3. So I'm going to move that to over here. Then it says 5 times a number. I don't know what the number is, but it's x. I see times again, so I know it's multiplication. Then I've done everything here. So my final answer is 5 plus 4x is equal to 5x minus 3. If you've already done the algebra videos, there is nothing to do with simplification or moving anything around. That's not what it's asking us to do. It just wanted a setup. So don't do more work than you have to. All right, sample question number 5. Gina's subscription service charges her a $10 activation fee and $14 per month. How much has she spent after a certain number of months? Okay, so let's go through. Gina's subscription service charges her a $10 activation fee. So when you think about an activation fee, do you pay it more than once? Or is it just a one-time fee? That activation fee is one time, and we know that that amount is going to get added onto her bill. So we're going to add on that $10 activation fee. And we know that she pays $14 per month. What's the relationship between per month and the number of months? So the price per month and the number of months. So if I think for a second, 1 month is $14. 2 months would be $28. 3 would be $42. 4 would be $56. This is a multiplication relationship because 14 times 1 is 14. 14 times 2 is 28. Times 3 is 42. So I know it's 14 times something. But what I pull next from this problem is it says a certain number of months. So if it's price times the month and we don't know the number of months, that's X. But instead of writing it as 14 times X, we write them next to each other. So it's $10 plus 14X. I want you to also know that if you wrote this, that's totally fine. If you wrote 10 plus 14X, also totally fine. And remember, we cannot combine the 14X and the 10 because they both do not have an X. So this is the best way that we can write this. Sample question number 6. Sean walked a certain amount of miles on Monday. On Tuesday, he walked 3 more miles than he did on Monday. On Wednesday, Sean walked 2 miles less than he did on Monday. Write an expression for how many miles Sean walked all together. All right. First thing I'm going to do, there's a lot of descriptions here. And when that happens, I'm going to write out something for each day of the week. So we're talking about Monday, Tuesday, and Wednesday. Now, Monday, it says Sean walked a certain amount of miles on Monday. Do we know the number of miles? Well, it said certain amount, but it sure didn't tell us. So I'm going to put X for this. I'm also going to double check to see if I'm right by reading the next description. It says, on Tuesday, he walked 3 more miles than he did on Monday. It's actually comparing Tuesday to Monday. So because Tuesday is going to be in terms of Monday, Monday can keep the X. Totally fine. And it said 3 more miles than he did on Monday. So if Monday was X and he did 3 more, then Tuesday is X plus 3. On Wednesday, Sean walked 2 miles less than he did on Monday. So it's whatever he did on Monday, which is the X, and 2 miles less. So we're taking away 2 miles from whatever he did on Monday. And we want to write an expression for how many miles Sean walked all together. When we think about the miles all together, I think of adding what he did Monday plus Tuesday plus Wednesday. That tells us the miles all together. So if Monday's X, and we're adding Tuesday, which is X plus 3, and we're adding Wednesday, which is X minus 2, we can simplify this. So if I look at my X values, I see that I have X plus X, actually makes be sure you get the sign in front, plus X plus X. So this tells me that I have 3 X's. I also see that I have plus 3 minus 2. So 3 minus 2 is 1, is a positive 1. So I'm left with plus 1. So my final answer for this expression is 3x plus 1. Now, some of you may say, why couldn't I do x plus 3 plus x minus 2? If you were able to simplify by combining like terms, great, then do it. The one before, when we had an equal sign, it wasn't asking us to solve it, just to set it up, and that was the original setup. Here, we can combine because everything's on the same side, so we can do that here. Louise has an allowance of $25. She spends X dollars on candy, $3 more on pizza than candy, and half the amount she spent on candy on soda. If Louise spent all of her money, write an equation for the situation above. So let's look. I know Louise has an allowance of $25. So what I get from this is that the total of her amount is $25. So what I'm already thinking is whatever we're doing is going to equal 25. I also remember that because I know that she spent all of her money. And I know we jumped down, but that's why we read the whole problem first, is that sometimes things later on, by reading the whole problem, influence how we start. So I know she spends all of her money, and it's $25. So whatever it is equal to 25. I also know that I'm going to put candy, pizza, and soda, because these are the three things that she's buying, and I want to be able to keep track of all three of them. So this is done. She spends X dollars on candy. Okay, so that's going to get the X. $3 more on pizza than candy. So that's whatever the price of candy was, plus $3 more. And half the amount she spent on candy on soda. So I'm going to put half of the amount. So that's 1/2 times X for soda. You could have also put X over 2, but you'll see why that I may have done it this way. If Louise spent all of her money, write an equation for the situation. Okay, so I know what's going to happen is when she goes up to the cash register, they're going to take the candy, add the price of the pizza, and add the cost of the soda. So I'm going to have X plus 3 plus 1/2 X as my situation. Now, one thing, if it's easier to notice, this is 1X. This is also 1X. So if we start to think about our combinations, we have 1X plus 1X plus 1/2 X. So I have 1 plus 1 plus 1/2. So I'm going to write this as 2 1/2 X. The plus 3 is by itself. There's no other whole numbers, equals 25. Now, if this is not an option, say there is a multiple choice question like this, and there's no answer choice that looks like 2.5 X plus 3. What you could also do is change this into an improper fraction. Sometimes that may show up instead. So 2 times 2 is 4, plus 1 is 5. So you may also see 5/2 X plus 3 equals 25. If it's a fill in the blank, it'll be very specific about how to enter in your answers. So you should be absolutely golden here. But either one of these answers, 2.5 X plus 3 equals 25, or 5/2 X plus 3 equals 25 are the correct answer. All right, we've come to the end of our lesson on writing expressions and equations. Congratulations. So go practice, and I can't wait to work with you soon. Hey y'all, welcome to our math course here at Nurse Hub, and today we're going to be covering writing inequalities. Hey everybody, welcome to Writing Inequalities on the TEAS with me, Brian. All right, let's get our lesson underway. Our goal for this lesson is that we will be able to write inequalities from different scenarios. So we're going to be given some sort of description, and we have to create an inequality to match the description above. Key vocabulary 1. When we talk about an inequality, that is a number sentence that uses a symbol other than an equal sign to describe a situation. So notice we have our 5 symbols: less than, greater than, less than or equal to, greater than or equal to, and not equal to. Because the word itself, inequality, in means not, and we see the word equal. So an inequality means something that is not equal. As a word of advice, remember the larger end of any of these inequalities faces the larger number. So if you ever get confused about which symbol to use, know that the open mouth should always face the larger number. What we're going to do is we always are going to read the full scenario. So don't write anything until you read all of it. This helps you just let the information soak into your brain for a second so that you know what's going to happen before you start writing anything down. Then we're going to go from left to right, and we're going to break down the description into smaller pieces. We're going to go through this. We're going to see what it looks like, but don't try to do everything at once. Take the information that you see, write something down, and then go from there. Figure out what's missing, what you don't know. So that's the variable. For example, it says 4 less than a number. I don't know what that number is, so I'm going to assign that the variable. And then I want to find something that is 4 less than that. So if I think, how do I find 4 less of a number? So for example, what if the number was 10 and I wanted to find 4 less than that? In my mind, I know that's 6. Because sometimes we have to use real world examples or numbers that we know to help us figure out what to do. So I know that this is really going to say 4 less than number, which must mean it's x minus 4. So this would be my expression from that description. So pay attention to operational words. So you may see words that mean addition, subtraction, multiplication, division. So 3 times as many. It is divided by. Equal groups mean division, subtraction, less than, subtracted from, taken away from. Addition would be added onto, more than. Just different words that let you know what is happening inside your inequality. The word is usually going to indicate an inequality needs to be written down. So, for example, it says 4 less than number is less than. So what that means is when you see is less than, that's letting you know where your balance of the inequality is. So we know that this is where the less than symbol is. So then if we focus on everything to the right, we just see 7. Then if we focus on everything to the left, 4 less than a number, which we did before, which was x minus 4, we've now created our inequality, which is x minus 4 is less than 7. By breaking that down into smaller pieces, we were able to create our inequality. 6, try out a number to see if your inequality works. This is also going to work to see if you have the correct signs. So, for example, if we know that x minus 4 is less than 7, what if we tried a number? X is 0. So if I did x is 0, 0 minus 4 is less than 7, negative 4 less than 7. Okay, it does work. So it worked to let us know what was going to happen here. All right, why? Again, real world scenarios are not going to give us the forms of the equalities or inequalities. We really have to figure those out on our own. So we have to be able to interpret different scenarios and situations to determine how to solve them. So it's going to be important for setup for not only just equalities, but inequalities as well. And we have to be able to know how to check our answers when we do these. It is time for sample questions. So you do get your options. You can either do all the questions with me on your own or a mix of both. Totally up to you, but I suggest trying all of those at some point. All right, sample question number 1. It says 4 more than a number is greater than 7. So I'm looking for my sign right here, is greater than. So I know that my left side is going to be greater than. Notice that my side to the right just has 7. So there's nothing to change. Then I'm going to look at 4 more than a number. I see 4 more than a number. That's going to give me a plus sign. A number, that's going to give me x. I don't know what that number is. And 4 more than, I know that this has to have a 4 here. So I know that 4 plus x is greater than 7. Now, one thing to know, when you have addition or multiplication, the order doesn't matter. You could have 4 plus x or x plus 4 is greater than 7. Either one of those is still going to be the exact same amount. If you don't believe me, absolutely try it out with a number, but know that for addition or multiplication, you don't have to worry as much about the order. If it is subtraction or if it's division, then the order absolutely matters. So pay more attention when you come across those problems. All right, simple question number 2. 6 more than 4 times a number is at most 40. Is at most. So I know that it can't be more than 40, but it can be at most 40. So at most actually includes that number. So what I have to the left has to be less than or equal to our 40 over here, because it cannot be more than 40, but it could be 40. So next I'm going to start to break down what our pieces are. It says a number, and I know that's x. It also says 4 times a number. That means multiplication. So that must mean 4 and x are being multiplied together. Then I see over here 6 more than. I know more than means addition, and it's 6 more than. So I've broken my expression down into my inequality down into pieces. So my final would be 6 plus 4x is less than or equal to 40. Sample question number 3. 9 less than 2/3 of a number is at least 14. Is at least. That means at the lowest number, it's 14. So my answers are 14 or higher. When I think about that, I know that then it has to be greater than or equal to 14, because at least means the minimum, the smallest, and we want a number larger. So let's look at, first of all, 2/3 of a number. So I know this is going to be x. And I want 2/3 of. Now that reminds me of multiplying by fractions when we see that word of when we have fractions. So I know that this is going to be 2/3 times x. Now here is where we start to make sure we have to be a little more cautious. 9 less than. So I know that subtraction has to be involved. So if I want 9 less than something, is it going to be 9 minus 2/3 x? Or is it going to be 2/3 x minus 9? Which one of these says it's 9 less than 2/3 of a number? This one is 2/3 x less than 9. So that doesn't work. So we know that we need to subtract 9 from the 2/3. I don't want us to get confused by looking at the wrong part. So we know that our final answer is going to be 2/3 x minus 9 is greater than or equal to 14. Notice that when you see something that says like 9 less than, if it's in the beginning, that's letting you know that that's the subtraction part that should come second. Sample question number 4. 5 times a number is less than 7 more than 4 times a number. So I know that this says is less than. Great, so that says less than. Now we can look at this one. Both sides have a larger description. So this is 5 times a number. So I know that's x, and 5 times means multiplication. So I'm going to write 5x. I then see 7 more than. So I know that's addition, 7 plus. And for addition, I know the order doesn't matter. So I'm going to do 7 plus. Then I see 4 times a number. So this number is x, and I want 4 times x. So 5x is less than 7 plus 4x. All right, let's break it down into some word problems of how we may see this. Slices of pizza cost $3.25 each, and sodas cost $1.75 each. Cheryl has $25 to spend. Write an equality to find combinations for how many pieces of pizza and sodas Cheryl can buy. So let's think about what's happening in this problem. So I'm going to do everything that has to do with the pizza. I know each one is $3.25. And I know the sodas cost $1.75 each. So that's a soda. And red for pizza, I know that did not get lost on me. I immediately thought of sauce. And she has $25 to spend. Now, here's where we can start to build. We know that she has $25. Can she spend more than $25? No, that's all she has. Can she spend $25? That's another question to ask. Yes, if she has 25, she can spend all 25. So we know that her amount must be less than or equal to $25. Now we look at how do we find the total cost of pizza. I know that if the first slice costs $3.25, the second one also costs $3.25, the third, the fourth. So I'm actually using 325 multiple times. So that means it's a multiplication relationship. So I'm going to say $3.25 times the number of slices of pizza. Do we know the number of slices? No, because we're finding combinations. So I'm going to put a variable P for pizza. I also know then $1.75 times the number of cans of soda will tell us the total cost of soda. So I'm going to use S because I don't know the number of cans of soda. Now I have to think, if I find the total amount I spent on pizza and the total amount I've spent on soda, how would I find the total cost? They would be added together. So my inequality would be $3.25 times P plus 175S is less than or equal to $25. A little tricky, but we break things down into those pieces and it really helps out. Sample question number 6. Mrs. Smith owns her own store. She purchased a box of candles for $200. She makes $12.99 for each candle sold. Write an inequality to show how many candles Mrs. Smith must sell in order to earn a profit. So Mrs. Smith owns her own store. Cool. Thank you. Doesn't help. She purchased a box of candles for $200. So that's the cost of the candles. And I'm going to get rid of that. And she sells, or actually she makes, because this is pure profit, we can assume she sells it for higher. She makes $12.99 per candle. We're going to write an inequality, so that lets us know the symbols that we're looking for, to show how many candles Mrs. Smith must sell in order to earn a profit. Now, when we earn a profit, we want to make more than what we spent. So she spent $200. We're looking for an amount that is larger than $200. That's how we make a profit. So it could even be $200.01, but it has to be larger than $200. So I've used this part of my inequality. Now we look, she makes $12.99 per candle. And we are looking for how many candles. Do we know how many candles she sold? No. So how many candles means that's the X. Now what's the relationship between the candles sold and how much she makes per candle? That's going to be multiplication. So it would be $12.99 times X must be greater than 200. So we can combine that. How'd you do? Well, you've come to the end of our writing inequalities lesson. I hope this was helpful. So really understand to break down any of your descriptions into smaller pieces, manageable chunks, find where the two sides are, especially when you see something like is less than. That lets you know everything to the left is on one side, everything to the right is on another. Also make sure that order matters when you are dealing with division and subtraction. It's your turn now to go forth, try these out, and we cannot wait to see you again. Hey y'all, Ryan here for another one of our math lessons here at Nurse Hub. And today, we're going to be covering simplifying expressions. Hey everybody, welcome to the Simplifying Expressions lesson on the TEAS Math with me, Brian. So let's jump right into today's lesson. All right, our goals for this lesson is that we will be able to simplify algebraic expressions. So let's see what that actually means. All right, so let's look at our first key word, which is to simplify, and that's to make an expression, equation, or inequality easier to solve by combining things that are alike. So for example, we see 2x plus 4 plus 3x plus 5. I actually see a combination of x's, 2x plus 3x, which really means we have 5x, and we also have plus 4 plus 5. So 4 plus 5 is going to be a plus 9. So 2x plus 4 plus 3x plus 5 is going to be the same thing as 5x plus 9. How do we know that this is simplified? Well, we only have one of each term. So we only have one term that has an x and one term that does not. When we talk about expressions, that is a number sentence that does not contain an equal sign. So it can have multiple answers depending on the value of the variable. So if we had 3x plus 6, we could say, what if x was equal to 1? That would be 3 times 1 plus 6, and in this case would be 3 plus 6, which equals 9. But what if we said x was equal to 5? So we could say 3 times 5 plus 6, which is 15 plus 6, which equals 21. Notice how the problem did not tell us what x was equal to, so therefore we really have an infinite amount of options here. When we say the word like terms, that's parts of a number sentence that have the same units. So for example, both of these have x's. So 2x plus 4x, and both x's are to the same power, so we can combine them. So 2x plus 4x is 6x. For 3y plus 8y, they both have y to the first power, so they can be combined. So this would be 11y. Notice that we have 5x squared plus 2x squared. They both have an x squared. That's why we can combine them. They share the same x power. So therefore we have 7x squared. And 8 plus 13, that's going to give us 21. Now, this is the most simplified of the expression. Biggest mistake that people come across is thinking that they can add 6x plus 7x squared. But the problem is 6x is only to the first power, and 7x is squared. They do not share the same power. They are not the same variable. So therefore, it does not work. We cannot combine them. A variable is that letter or symbol representing an unknown value. So in this case, the variables are x and y. If you have two separate variables, almost always it means that these would be two separate values. If they were the same value, it would have been the same variable. So we can assume that x and y are different values. 1. So our first key point, let's circle, box, or draw something around like terms. Biggest thing to remember is include the sign in front of each term. So for example, if we're looking at x's, I see x, I have x, and I'm going to circle plus 3x. I don't see any more x's, so I can do x plus 3x is going to be 4x. Where did we get that extra 1 from? Because x is really 1x. I then have plus 4, plus 7, plus 8. So if I did 4 plus 7 is 11, plus 8 is 19, I get 4 plus 19. And then I have my final part right here, which is plus 2y plus 2y. Now you may see this shuffled around because generally we order these expressions or equations by powers, variables, and then at the end we usually have our whole number. So in this case, we would just shuffle around to 4x plus 2y plus 19. So you may see it like this. All right, key point number 2, the sign in front of the number must be included with the number behind the sign. And let's talk about why that has to be. So if we look, let's look at the x's first. We have 4x minus 3x. If we skip that minus 3x and thought it was positive, we'd end up with 7x. When in reality, we need 4x minus 3x, which is just 1x. If we looked at the whole numbers, that's plus 2 minus 8 plus 7. So 2 minus 8 is negative 6, plus 7 gives us 1. So we really have x plus 1. Key point number 3, if no sign is in front of a number, it is positive. So specifically this 3x, because it's in the front, we normally don't put a plus sign in the front to start an expression or an equation. It is assumed that the 3x would be positive. Key point number 4, distribute any number that you need to. So for example, 4 is being multiplied by the entire situation inside the parentheses. So we have to multiply 4 times 2x and 4 times positive 8. How do I know it's positive 8? Because this is plus 8. So 4 times 2x is going to be 8x. 4 times positive 8 is going to be 32. Same thing with the other one. We have 3 times 2x, which is going to give us 6x. Then we also have 3 times a, be careful here, this is minus 6 or a negative 6. So it's going to be 6x minus 18. So really be careful when you are distributing those numbers. It will change the direction that you go in. Key point number 5, move all variables to the same side. So for example, we have x's on both sides, 8x on the left, 4x on the right. We are going to move these to the same side in order to solve. So we're going to subtract 4x minus 4x. These x's cancel out. So I have 4x on this side plus 12 equals 28. And then I could subtract 12 from both sides. 4x is equal to 16. And from here, I could then divide both by 4. So let's move this up so we can show you. Divide by 4, x is equal to 4. Again, we're just simplifying here, but if you move variables all to one side, you are going to make it much easier for yourself to solve. Key point number 6, be very careful with your signs, especially if you have a negative sign in front of a parenthesis. So for example, if we had x minus 2 times x minus 4, notice this negative 2 is going to get multiplied by this x. So we would have x, and negative 2 times x is minus 2x. And it's also going to be multiplied by a negative 4. So negative 2 times negative 4 is going to be a positive 8. So therefore, really pay attention to what happens with your negative signs. Why do we do this? Simplifying equations is going to allow you to solve and to have fewer terms to deal with when you're solving for a variable. It's going to put into equation into the least amount of terms without changing the value of the equation or expression. So knowing what can be and cannot be combined is going to allow you, or any solver, to find answers and create setups more accurately. So if we did 5x plus 4x, some of us may get confused about how do we know what we can add and what happens. So I want you to think, this term here says we have 5 times x, which really means it's repeated addition. So x plus x plus x plus x plus x. And 4x means that we have 4 of these x's. So x plus x plus x plus x. And it says that these are being added together. So if you look, this is really just an entire row of x's being added together. How many x's do we have being added together? We have 9x. And that's why we can add 5 plus 4. It is time for our sample questions, so let's jump right in. Again, you can do these with me, you can try them on your own, or you can do a mix of both. Sample question number 1, we have 4x plus 3x plus 9 plus 7x plus 8. So let's deal with our x term first. So I'm going to look at 4x plus 3x plus 7x. So 4x plus 3x is 7x, plus 7x is 14x. So we do have our 14x. Then I check, I have plus 9 plus 8. So that's going to give me plus 17. This is going to be simplest form because we only have one of each kind of term. Sample question number 2. 4x minus 8 plus 14 minus 3x. So let's do what we are great at. So let's look at the x's. I have 4x and a minus 3x, including the sign in front. 4x minus 3x is just going to be x. Next, I have minus 8 plus 14. So a negative 8 plus 14 leaves me with a positive 6. So my simplest form is x plus 6. Sample question number 3, we want to simplify 5 times x plus 2 minus 3 times x plus 6. All right, so let's do one thing at a time. So we're going to multiply 5 times x, which gives us 5x. And we're going to multiply 5 times 2, a positive 2, which is plus 10. Biggest mistake that people make is not multiplying the coefficient in front by both terms. Make sure you multiplied 5 by the x and by the positive 2. Now we take the negative 3 and multiply it by the x. So you might say, why is it negative? Because when you subtract a number, it's the same thing as adding a negative number. Check out our positive and negative video if you need more help in that area. So here we have negative 3 times x, which is minus 3x. And we also have the negative 3x times a positive 6. So negative 3 times positive 6 is going to be a negative 18. From here, we're going to combine our like terms. So I'm going to use different shapes for this one since we have a lot of colors. So I'm going to say 5x is a circle minus 3x. That's going to give me a net of 2x. And my whole numbers, I have plus 10 minus 18. So 10 minus 18 is going to leave us with a minus 8. All right, sample question number 4. We have 10x minus 4 minus 2 times 2x minus 4. Okay, first thing we're going to tackle is that parenthesis. Making sure that we know that this is a negative 2 times 2x, and then a negative 2 times a negative 4. So I'm going to write down what we already have. We have 10x minus 4. Now we have negative 2 times 2x. That's going to be minus 4x. Then we have negative 2 times a negative 4. Remember, two negatives multiplied together get you a positive, so that is plus 8. From here, we combine our like terms. So we have 10x minus 4x is going to give us 6x. Then we have minus 4 plus 8 leaves us with a net of positive 4. So our final answer is going to be 6x plus 4. Sample question number 5. We have x squared plus 3x plus 5 plus 8x plus 3x squared minus 6x. We have introduced a new term. So we're going to start with our variable that is the highest power, which is x squared. So I have x squared plus 3x squared. I don't see any other x squareds. That's going to be 4x squared. I could not combine the x's with this because they're not to the same power as x squared. So next I have plus 3x plus 8x minus 6x. So 3x plus 8x is 11x minus 6x is a positive 5x. And we have our straggler at the end, which is just plus 5. So this here is our simplest form for this expression. All right, final sample question of this lesson. Let's see what we can do. Okay, we see our parentheses, and what we're going to do is we're going to take the number outside and multiply it by each piece inside. So 3 times 2x squared is going to be 6x squared, plus 3 times 8x is going to be 24x. Remember, this is a minus 4. So minus 4 times x squared is going to be minus 4x squared. Minus 4 times a positive 4x is going to be minus 16x. And a negative 4 times a negative 3 is going to give us a positive 12. From here, we can combine our like terms. So I have 6x squared minus 4x squared. That's going to give me 2x squared. I'm going to show you again, in case you don't have different colors, how also you can box things around. So I have plus 24x, I'm going to use a different shape, minus 16x. So I can see my rectangles. 24 minus 16 is going to leave me with a positive 8x. And if we wanted to do a triangle here, for our whole number, we have plus 12. I know I use different methods, but we may not have different colors. We may not have those options. So giving you just a different way to help you sort. This is the most simplified version, and we are good to go. All right, it is your turn to go practice simplifying expressions, to go find this. I know you can do it, and I cannot wait to work with you again. Good luck. Hey y'all, Brian here. So wonderful to have you back for another lesson. And today we're going to be focusing on solving inequalities. Hey everybody, welcome to Solving Inequalities on the TEAS Math with me, Brian. So let's get it started and get our lesson on the road. So our goal for today's lesson is we will be able to solve inequalities. That's our big goal. So what is an inequality? Well, it's a number sentence that uses a symbol other than an equal sign to describe a situation. So if you remember prefixes, in means not, and we have equal here. So it's something that shows that something is not equal. So we do not use an equal sign. But instead, we have the four options that we're going to see below. We see less than, greater than, less than or equal to, greater than or equal to. If it helps you to remember, one thing I always taught my students is that the mouth, the large mouth, goes to the larger number. So in case you weren't sure, say, for example, you had this, you know that the mouth goes to the larger number, the opening, just like we used to call the alligator mouth. But if you weren't sure how to read this, you know 5 is less than 8. So if you read it left to right, you know 5 is less than 8. So you would say that this is the less than symbol. So these are the four that we're going to be focused on. All right, so first key point, just like in algebra, your goal is going to isolate the variable. We solve just like we solve an equation. So I'm still going to bring my line down. I still want to solve for x. How do I do that? I'm going to have to add 4 to both sides. Minus 4 plus 4 cancel out. So I have x is greater than 10. And that would be my final answer. So we solve it just like normal. Nothing crazy yet. If possible, combine any like terms before moving things around. If you combine like terms in the beginning, you're not going to have to shuffle around 8,000 different things. So if we look at the left side, I'm going to bring my line down. And I'm going to combine my like terms. I have 14x minus 2x. That's going to be 12x. Next, I have plus 6 minus 8. So that gives me a total of minus 2. So 12x minus 2 is less than 10. From here, I can solve it. So I can add 2 to both sides, plus 2. Cancels out. We get 12x is less than 12. Divide by 12, divide by 12, and we get x is less than 1. 3, if you aren't sure what to do, we generally use reverse order of operations. So if you remember the order of operations, please excuse my dear Aunt Sally, where multiplication and division are grouped together and addition or subtraction based on which one comes first. We generally work the opposite way to solve our problem. So for example, if we just did a quick one of 3x minus 2 equals 7. We would first start by adding the terms that are farther away from the x. So we end up adding 2 to both sides. Notice how that deals with step 1 of subtraction or addition coming first. We then have 3x equals 9. Notice that we do have multiplication or division, so we will have to divide, and x would be equal to 3. I know we did inequalities. We have equal signs here. We're really just trying to focus on the part that says when we solve these, we're usually using reverse order of operations. Key point number 4. If there is no coefficient in front of a parentheses, imagine a 1 is there. Now, a coefficient is just a number that goes in front of a variable, or in this case would be something in front of a parenthesis. If you see right here, there's no number in front of the parenthesis, but we can pretend that it's a 1. So that when we distribute from here, this is going to be the reason why we do this. Because you would have negative 1 times x, which is negative x. So you'd have 3 minus x. And you'd also have that negative 1 multiplied by a positive 6, which would give you negative 6. So 3 minus x minus 6. From here, you would combine like terms, but the purpose of this key point is to show you what happens with parentheses. This is the highest amount that people get wrong on these. I know there was a long pause just finding the right words to tell you, but this is what people get wrong the most, is distributing negatives in front of a parenthesis. Make sure that negative goes to both of the terms inside the parentheses. 5. If there is a minus sign in front of the parentheses, the negative sign gets distributed to all numbers inside. So let's show you again. The 6x, nothing happens to it. We bring it down. But what we do next is that this negative 4 gets multiplied by 3x. So negative 4 times 3x is minus 12x. We do the same thing. We take that negative 4 and we multiply it by the next term, which is minus 6, or negative 6. Negative 4 times negative 6 is a positive 24. Notice how the signs were very important. It did not stay negative. It did not become negative, but those two negatives turned into a positive. Very important to work through. 6, make sure what you do to one side, you need to do to the other. So keep everything balanced. So if you're going to add 6 to the left side to get rid of it, you have to add 6 to the other side as well. These 6's cancel out, and you have 3x is greater than 18. We can solve it from here, but remember, you have to keep everything balanced. So what you do to the left side, you have to do to the right side, and vice versa. 7, keep track of your work step by step. So a lot of us like to jump or keep things in our head. When we keep things in our head, it is more difficult to keep track of what's happening and very easy to make a minor mistake. So what we say is keep track. So we show that we actually add 6 to both sides. We cancel it out, and we write what we have next. 3x is greater than 18. I then show that I'm dividing both sides by 3. I cancel those out, so I get x is greater than 6. This is a guaranteed fail-safe formula to make sure that you see the work that you just did. And for heaven forbid something that you get wrong, you can easily go back and see what happened. All right, number 8. After you solve, try putting your answer back into the problem. This is really going to see if your answer makes sense. So if I put this in, it says x is greater than 6. So what that means is let's try a number that's greater than 6. So let's say that x is equal to 7. Why 7? Because 7 is greater than 6, and this problem here told me that x should be larger than 6. So if I put that back in, I do 3 times 7 minus 6 is greater than 12. I know 3 times 7 is 21 minus 6 is greater than 12. 21 minus 6 is 15. Is 15 greater than 12? Yes, so it works. Our answer makes sense. Number 9, if you multiply or divide by a negative number, the inequality sign is reversed. Now, here is something I want to show you. So let's take this to the side. I'm going to show you what I'm talking about here. So in order to solve for x, we are going to have to divide both sides by negative 3. So our negative 3's cancel out, and we have x. Our sign flips, x is greater than -4. Now, here is how you can check. You may end up forgetting, and this is why we practice putting in numbers to make sense. If you're looking for a number that's greater than -4, let's try -3 for x is greater than -4. But what we also can do is, what if we accidentally kept it the opposite way? And we said x is less than -4. Let's actually check to see which one makes sense and which one works in this problem. So if I have -3 times -3 is less than 12, -3 times -3 is 9, 9 is less than 12, yes, this works. So this is the equation that's correct. But what if we tried -5? What if we did -3 times -5 is less than 12? That says that 15 is less than 12. Is that right? No. So this one is not correct. So really make sure that if you do that, to flip it over. Now, say that last key point was really confusing. If you want to avoid having to flip a sign, try to keep your variable positive. So, for example, if we draw our line down, if I subtracted 3x from both sides, I'd end up with a -2x. Oof. Then I'd end up having to do something by a negative. And I may have forgotten the rule, so I'm going to try to avoid that. But if I actually subtract x from both sides, what I notice is these x's cancel out. And now I have -8 is less than 3x minus x is 2x plus 12. And my sign stayed the same. I didn't divide by a negative. I subtract 12. I also meant to say we did not multiply or divide by a negative, so nothing flipped. These 12s cancel out. I get -20 is less than 2x. Notice here, I'm now going to divide by a +2. So what I see is that I get -10 is less than x. But if I wanted the x on this side, because that's how most answer choices are, notice how the large opening is facing the x, so we make sure that happens as well. So it also means x is greater than -10. So if you decide to keep your x's positive, you'll end up having to flip the sign anyway, but you won't have to remember a rule. All you're doing is reversing the order, looking at it backwards. Now, why do we need to know this? There are situations involving algebraic inequalities that are not beautifully wrapped up into one step and may require many different steps to solve. So there may be different formulas that we need to be able to solve to ensure we're following the safest of measurements, but we also use this for things like budgeting, medication minimums or limits, and other safety reasons or precautions. So we've come to our sample questions, and at this time you can choose to work through these with me. You can hit pause, try them on your own, or do a little mix of both. Whatever is up to you, it is your choice. All right, sample question number 1. We are going to solve 5x plus 7 is less than 22. All right, so I'm going to draw my line down, and our goal is to get x by itself. But the first thing we have to do is to get rid of this adding 7. So instead of adding 7, we're going to do the inverse or the opposite, subtracting 7. Why do we do this? Because plus 7 minus 7, that cancels out. So we're left with 5x is less than 22 minus 7 is 15. To solve, we now divide by 5. We do the opposite. So if x is being multiplied by 5, we do the opposite, which is divide. These cancel out to become 1x is less than 15 divided by 5 is 3. So x is less than 3. Now I'm going to show you, for just this example, putting a number back in to make sure that it works. X is less than 3, so what if we tried, let's try something easy, 0. 0 is less than 3. So if I did 5 times 0 plus 7 is less than 22. 5 times 0 is 0. So I have 7 is less than 22. Is that correct? Yep. So x is less than 3. All right, let's look at sample question number 2, which is 3x minus 4 plus 6x minus 9 is greater than 50. So the first thing we're always going to do is draw our line down because that lets us know what we're keeping balanced, the left side to the right side. The next, we're going to combine like terms, making sure you include the sign in front of the term. So this is a positive 3x. How do we know it's positive? There is no negative sign in front, and if the positive first term is there, there is no plus sign in front. And we have a plus 6x. So this gives us 9x. Next, we have minus 4 minus 9. Put those together, that is minus 13. So 9x minus 13 is greater than 50. Now we're going to work our way closer to the x since that's our goal, is to isolate the variable. I'm going to add 13 to both sides. How do I know if I did the right thing? Well, minus 13 plus 13 is 0. We want something to cancel out each time. So we're left with 9x is greater than 63. Now we're going to divide both sides by 9. And we have x is greater than 7. If you chose a number greater than 7, you could try to put it back in to make sure that your answer makes sense. All right, sample question number 3. 5x plus 6 is greater than 3x plus 18. Now remember, our goal is again to isolate the variable, but we have variables on both sides. So I'm going to ask myself, should I move 3x to the left or should I move 5x to the right? Well, I'm going to subtract 3x from both sides as my first step because that means that my variables will be positive. So 5x minus 3x is 2x. 2x plus 6 is greater than 18. So now I really want all of my whole numbers on one side and my variable on the other side. So I'm going to subtract 6 from both sides because plus 6 minus 6 cancels, and we get 2x is greater than 12. Now to solve, I'm going to divide both of these by 2. These cancel out to 1x, so x is greater than 6. If you want it, go and check. See, choose a number greater than 6, see if it works. That's the best thing you can ever do. Sample question number 4. 6x minus 18 is less than or equal to 10x plus 12. All right, so I have a thought here. Am I going to subtract 6x from both sides or subtract 10x from both sides? I personally like to keep my variables positive, so I'm going to subtract 6x from both sides. 6x minus 6x is 0x, so that's negative 18 is less than or equal to 4x plus 12. Here, what I'm going to then do is I'm going to subtract 12 from both sides. So I get negative 30. If I put those together, is less than or equal to 4x. I'm now going to divide both of these by 4. And if I put that into my calculator, I will get x, my symbol, and I will get negative 7.5. Now here is where we have to be careful. We generally see in our answer choices that x comes first. So x, we see that the larger mouth is pointed to the x, so I'm going to make sure that still happens. Keep my symbol, negative 7.5. Sample question number 5. Uniform shirts cost $28 each with a $38 shipping charge. If a company has budgeted $400 to spend on uniform shirts, write and solve an inequality for how many shirts the company can buy. All right, so we know that uniform shirts cost $28 each. And there's a shipping charge of $38. So I know that that shipping charge happens only once, right? Because when you order a whole bunch, there's only one shipping charge that you get. And a company has budgeted $400. So let's think about what's happening. We're then looking for how many shirts that there are. So we don't know how many shirts that we have. But if I buy one shirt that would be $28. 2 shirts, $56, and so on and so forth. So the relationship between the cost of each shirt and the total number of shirts is going to be multiplication. So it's going to be $28 times the number of shirts, or how many shirts. So X means the number of shirts that were bought. We know that we're going to then add on that shipping cost, because that's part of the total cost. So right here represents the total cost. And the budget is 400. So we know something is going to equal 400 or be close to 400, because those are the two sides that should be balanced. But is it going to be greater than or less than if there's a budget? If we have a budget, it should either be less than 400 because we only have 400 to spend, or equal to 400. In this case, you could spend $400. Nowhere in there said you had to have any change left. So here, we can now solve. So let's get rid of this to add some space. So the first thing we're going to do is subtract 38 from both sides. And we get 28x is less than or equal to 400 minus 38, which is 362. Now I'm going to divide by 28. And that says x is less than or equal to 12.928. Now, in this problem, we're talking about shirts. Can we have 0.928 shirts? No, you can only buy a whole shirt. So our adjusted answer is x is going to be less than or equal to 12. You don't have enough money to buy that 13th shirt, and no company is going to sell you 0.928 of a shirt. So you can only buy up to 12 shirts. Sample question number 6. Jim's Gym, well, that's fun to say. Jim's Gym charges $40 to sign up and $15 a month for membership. Simmy's Gym charges $75 to sign up and $10 a month. After how many months is Simmy's Gym cheaper than Jim's Gym? Jim's Gym is just too much to say sometimes. All right, so let's look at the equation for Jim's Gym. So I'm going to circle this one in yellow. Now, one thing to notice is, does something get repeated, or is something a one-time charge? All right, so I know that if it's $40 to sign up, that's going to be a one-time charge. And that would be added on to $15 a month. So month 1 is 15, month 2 is 15, month 3 is 15, month 4 is 15. But I don't know the number of months. But I know that $15 would be multiplied by the number of months. So x is the number of months. Now, we know that Simmy's Gym, and let's do this in blue. I never know what to do when they're on two separate lines, so we're just going to go two bubbles. Simmy's Gym is $75 to sign up, so that's a one-time charge, plus $10 a month. So that would be 10x. If we have $15 a month before was 15x, then $10 a month is 10x. And we want Simmy's Gym to be cheaper than Jim's Gym. So cheaper I know means less than. So I'm going to have the smaller amount facing Simmy's Gym and the larger opening to Jim's Gym. From here, I can solve. So we're going to treat this just like a regular problem. I'm going to subtract 10x from both sides to keep our variable positive. So we have 40 plus 5x is greater than 75. Subtract 40 from both sides. I get 5x is greater than 35. Divide by 5. Divide by 5. We have x is greater than 7. What does this actually mean? That means that After 7th month, so after the 7th month payment, that next payment is when Simi's gym is going to be cheaper than Jim's gym. If you're budgeting, if you're looking for cheaper options, this is a great way to actually check to compare prices of different organizations for you. So it is something that is beneficial long term. All right, we've come to the end of our lesson of solving inequalities. It is your time to go practice, try these out, see what you can do, and I can't wait to work with you in our next lesson. See you later. How's it going, y'all? I'm Brian here for another math lesson where today we're going to be covering interpreting graphs. So let's get visual. Welcome to Interpreting Graphs on the TEAS 6 math course with me, Brian. So let's get right into it. All right, our goal for this lesson is that we will be able to interpret information from different types of graphs. As you got from the title, we're really just going to be looking at graphs and figuring out what do we get from this, what can we figure out, and how do we answer questions based on the data in front of us. So key vocabulary 1, we have the x-axis, and that's the horizontal line in the graph. And this is usually the independent variable. So this is our x value, or x-axis, because it is our horizontal line. So for number 2, we have the y-axis, which is the vertical line of the graph. Usually is the dependent variable. In this case, the y-axis is here, where the number of hours of TV watched would depend on the day of the week. So key vocabulary word number 3, we do have a pie chart, and that's a circular graph, usually showing information out of 100%. So we can see that this question was about favorite animals, and we have the different animals and the percent of total responses here. 4, we have a bar graph, and that represents data amounts using bars. That's why it's called a bar graph. So we can see here that Jay has 1 pet, Ollie has 2, Shay has 5, and Sam has 3. A double bar graph is a bar graph that displays 2 sets of data at the same time. So if we looked for money made for company A, company B, I know this is a great drawing, so I'm so glad that you're here for this. If we look in 2000, company A made 3 million, company B made 5. So it's comparing the 2 companies each year. We also have a scatter plot, so that's known as a dot plot. So it uses dots to represent different values. So instead of looking for trends, say a bar graph would only be suited if we talked to 4 people about their favorite pets or their heights. So it's usually scatter plots are correlations between 2 different values, or most likely both of them are going to have numbers. So a line graph also is going to show the change over time by connecting different points of information. So we can see over here, we do have the date. So that is a record of time, and we'd be tracking the temperature over that time. Key point, so take the time to understand what the graph is showing and how the information is actually displayed. So look at the x-axis. So is it counting by numbers? Is it words? What is the y-axis showing you? Is it numbers? Is it words? How is this graph set up? What's the title of the graph? So what is the graph actually showing you? What are the numbers? So is it counting by 2s, 4s, 1s? You should get an idea of what it's counting by, so this way you can interpret the information, and any labels. So what does the y-axis show? What does the x-axis show? What is this graph all about? So understanding what the graph is about will help you interpret the graph even better. Number 2, so what is the question asking about? Is it asking you to find a percent, a specific amount, to look for a trend? Are you comparing different amounts? If you can figure out what the question's asking, it's going to help you make a plan to then say, okay, here's how I'm going to tackle this. Here's where I'm going to start. 3, if it asks which statement is true, try out each option to make sure you've picked the right one. So pay extra attention if you see the word not in the question. So if it says, which one of these is not true, that you're actually looking for the one that is wrong, not the one that is right. They've also started to change for T7 that they offer multiple answer options. So choose as many of the following are correct. So it's a great habit to get into to check every single answer choice. Why do we do this? So oftentimes really important information is displayed to us through graphs, charts, and other visual means. We must be able to read, interpret, and determine information from graphs that may be used to determine best course of action for patients or other important scenarios. So we've come to our sample questions, and as always, you can either do them with me, do them on your own, or anything in between. All right, so sample question number 1, which of the following combinations has the largest area on the pie chart? So look at the pie chart, it says money spent. I see each color represents something different, and I see the percentages inside of each color. So I've gotten a good handle of what's happening. So let's look. We have utilities, transportation, and groceries. So I see utilities is that yellow color, so I'm going to put that's 8% plus. Transportation is gray, another 8%. Plus, groceries is green, so that's 13. So I have 8 plus 8 is 16, plus 13 is 29%. So I don't know yet because I haven't figured out any of the other ones. So I see B is rent. So that's housing. So that's going to be blue, that's 48. Plus education is that pink, so it's 5%. And that's going to give me 53%. So obviously, A is not the right answer. C, we have dining. So that's red, that's 20. Groceries is 13, plus utilities, which is 8, plus transportation, which is also 8. So 20 plus 13 is 33, plus 8 is 41, plus 8 equals 49%. So not going to be C either because B was 53. So groceries is 13 plus utilities, which is 8, equals 21%. So our correct answer is going to be B, rent and education. Sample question number 2. Below is a store's yearly sales breakdown. Which time is the most profitable for this store? So we're looking for most profitable. So this is going to be the most money made. So if we're looking, what I notice is that 30% is the largest percentage that is on here. So that coordinates with red, which is then a holiday morning, would be the most profitable time for the store. Sample question number 3. Based on the graph below, which is the slowest day for travelers? So we're looking for slowest. So I know if it's the slowest day, it has the least amount of travelers. So if I'm going to look, which of these has the least amount of travelers? Well, I'm between, it looks like Thursday. So I'm going to check and draw a line across. So even though Tuesday's close, Thursday squeaks out by just a little bit lower. So we get Thursday would be the best. All right, which of the following statements about the graph is true? And we look at our graph, and we're also going to look at A, B, C, and D and see if there's any indication of what we have to do. So I know that this is percentage of theme park guest ages. So 0 to 10, 15%, or of the guests there were between 0 and 10. Okay, got it. So it's showing me percentages. It says more than half of the guests are 30 or younger. So for A, and we can take this to the side, 30 or younger, so that's 10 for 21 to 30, plus 20, that's 11 to 20, plus 15. That's going to give me 45%. Is that more than half? No, that's actually less than half. So I'm going to try B, where it says 1/5 of all guests are between 11 and 20. So that says 20%. And this is giving me 1/5, so a fraction. So that's 20 out of 100. Now let me simplify this to see if it becomes 1/5. I know 20 goes into both numbers. So 20 divided by 20 is 1. 100 divided by 20 is 5. Actually, 1/5 could work. So I'm going to circle this and just come back to it. Let's look at C. It says there are more people 20 or younger then 41 or older. So 20 or younger, so that's 20 or younger, that's 20 plus 35, or 20 plus 15 equals 35. Then 41 or older, pretending that, so 41 or older, so that's 20 or older plus 10 equals 30. All right, this one's also correct. So this could be a multiple answer question. And it says twice as many people are 31 to 40 than 0 to 10. So let's look at 31 to 40. Let's go back to D. We can use yellow again. That's 25. And 0 to 10 is 15. Well, 15 times 2 is equal to 30, not 25. So it's not going to be D. So in this case, we did have two answer choices. This would be a select all option. So we have B and C. This is why we check all of our answer options. Sample question number 5. Which company has the greatest profit over the course of 2019 to 2020? So if we look, we see amount of profit per company over the last 2 years. We see company A, company B, company C. So we have 5 companies, and the blue is 2019, the green is 2020. So it's not comparing 2 companies over 5 years. It's actually comparing 5 companies over 2 years. So if we're looking at profit, I know that company A would be 14 because that's 12 plus 2. Company B would be 15 because that's 7 plus 8. Company C would be 14, 9 plus 5. Company D would be 16, 7 plus 9. And company E would be 13. So if we look at which company had the greatest profit, that is company D. But we had to figure out the amounts of each in order to determine which one was the most. Sample question number 6. What percent of companies made a profit greater than $5 million in 2019? So we look at 2019, and we're looking for a percent of companies. So first, let's find the number of companies we have. So if we do our line at 5, which is about here, in 2019, I noticed that 2 of my companies did not make it, right? They did not make more than 5 million. So that means that 3 out of 5 companies made a profit greater than 5 million. So, and I know percentages are out of 100. So I'm going to create equivalent fractions. You could have also put an X up here, and you could solve cross multiplication. In fact, let's actually do that. So 5 times X gives me 5X. 3 times 100 is equal to 300. Excuse the squeezing over here. Divide by 5, divide by 5. X is equal to 60. 60 what? 60%. So 60% of companies made a profit greater than $5 million in 2019. Sample question number 7. Which of the following statements about the data is true? So let's see, it's a lemonade sale by temperature. So on the left-hand side, we have sales. So I'm looking at that's probably amount of money. And then we have temperature on the bottom. Okay. So it says, as temperature increases, sales decrease. So we can actually use an example. So let's look at this dot here for A. That is at 40. The temperature is 40, and the profit was 100. So temperature increase. Let's choose another one. Let's say we have temperature was 50, and that's about 350. So let's look here, or 325. So B, we have 50, and we get 325. So as temperature increased from 40 to 50, did our sales decrease? No. So that's not right. I'm actually going to, I don't know what I just did there. Okay, let's erase that. Sorry. All right, so now we can look at B. There is a positive correlation between sales and temperature. So that means as sales go up, temperature also goes up. So if we look, do you notice that as we see 40 to 100, 53, 25, 80, we can choose one of our values. 80 is about 400. 90, I see a value that's almost at 500. So I notice that as temperature is increasing, so do sales. When we say positive correlation, if I drew a line here, it looks like the dots that as one is going up, the other is going up. So as temperature goes up, do sales go up. So the red line is actually showing a positive correlation. So I'm going to circle this one just in case. Sales of $350 correspond to 45 degrees. So if I look at 45 degrees, so let's look, that's here. Well, I see sales of $350 would be about here. I would say that's wrong because at 45 degrees, nothing is at $350. So that doesn't work. Boop, gotta go. So we have A and C are gone. D, as temperatures near 90 degrees, sales are usually close to 200. So if I have 90, let's look straight up from 90. Anywhere close, I have 500, 500, 425. No, that's way higher than 200. So my only answer choice is B. There's a positive correlation between sales and temperature. Simple question number 8. Which of the following statements about the data is true? So let's see what we have. We have price on the left-hand side and units sold on the bottom. Okay, so I'm looking at its price per unit sold. All right. Then we say as price increases, the number of units sold decreases. So let's see. When the price was, and let's actually look. I'm going to put U for units sold. So we're looking at answer choice A and the price. So let's look for a low price so that can help us. So I'm going to say when the price was 5, the units sold were, let's actually use this one right here. That's a little over 450. So let's say 460 units were sold. Let's look when the price was higher. So let's say the price is about 27 and there was about 50 units sold. So when the price increased from 5 to 27, did the number of units sold decrease? Actually, it did. So I'm going to hold on to A real quick. If we look at B, it says the most units are sold when the price is $30. I don't even see any units sold when the price is 30. So that's wrong. There is a negative correlation between price and units sold. So what that means is that as one goes up, the other one goes down. So what I notice as price, so this is answer choice C, as price goes down, units sold go up. So there is a negative correlation between these two. Then it says, let's check C. When the product is priced at $25, it sells more than 200 units. Okay, so anything over 25 is just this. We see one dot, which is actually only at 50 units. So this is not correct either. So B and C are not correct. So this must have been a select multiple option. So we have A and C. Again, that's why we do check all of our answer choices. So sample question number 9, how many days was the temperature less than 85 degrees? So we're going to look then at 85. And it wasn't that it's at 85, it's less than 85. So we're going to look for any dots that are less than 85. So we know on the 10th, it was 75, the 12th, the 14th, the 15th, the 17th, the 19th. So we have 1, 2, 3, 4, 5, 6. So 6 days. And we've come to our final sample question here. So below shows the distance Melissa was from her home after a certain number of minutes walking. Using this information, at which interval of time did Melissa take a break from walking? So here's what we see. We see the number of minutes that she's walking and the distance she is from home. So if we track this, what we see is in the first 10 minutes, to 20 minutes, to 30 minutes, to 40, to 50, it is increasing. The distance from her home is increasing, which must mean that if the distance is increasing, we know that she's walking away. I notice here that the distance from home did not change for 10 minutes. So she's still 4 kilometers away for 10 minutes. And I can see from minute 60 on, the distance is getting closer to home. So she must be walking home. Because if the distance is getting closer and she's moving closer, then she must be getting closer to home. So she's moving. She's not going to take a break if she's getting closer to home. So the only spot where the distance stayed the exact same is minute 50 to 60. So it's like she's standing still. If you look 60 to 70, it was going downhill. Or not downhill, but the distance was getting closer, so she must have been moving. Minute 0 to 10, she's leaving the house because the distance is increasing. And 90 to 100, still decreasing distance. If we see here, the distance stayed the exact same, which means she's not getting closer to home or farther away, so she must be standing still. All right, we've come to the end of our interpreting graphs lesson. Congratulations, I know you killed it. So go practice, and I can't wait to see you next time.
Everybody, Brian here. So wonderful to have you. Hope everything's going well. And what we're going to cover today is working on creating graphs. You ready?
Hey everybody, welcome to Creating Graphs on the T6 math course with me, Brian. So let's jump right into our graphing lesson. Our goal is that we will be able to create graphs and determine which graph is best based on different scenarios. So key vocabulary, we'll see the word x-axis. This is the horizontal line in the graph. So usually this is the independent variable. So in this case, it is the days of the week is our x-axis. The y-axis is the vertical line of the graph, and this is usually the dependent variable. So y is the vertical line, which in this case would be hours of TV watched. When we have a pie chart, that is a circular graph usually showing information out of 100%. So if people were asked their favorite animal, it shows you the percentages of those who chose specific animals. Bar graph is just a graph that represents data amounts using bars. So if we look at number of pets children have, we have 4 children in the bottom and the number of pets that each of them have. So we could see Jay has 1, Ollie has 2, Shay has 5, Sam has 3. If we have a double bar graph, that is a bar graph that displays 2 sets of data at the same time. So if we can look, the amount of money made in millions, we have company A, which is the peach color, and company B, which is yellow. So if we look in 2000, company A made 3 million, company B made 5 million. So it shows or compares 2 different sets of information at the same time. If we have a scatter plot, it's also known as a dot plot, which uses dots to represent different values. So these could represent a bunch of different ideas. We also have a line graph. So that shows change over time by connecting different points of information. And this is important about line graphs is that in order to use one, it has to show change over time. So for example, if we were looking at temperatures, we're looking at the change of temperature over dates or times, days. So key points, determine the best graph to use given the information provided. So for example, like we just talked about line graphs, is it showing change over time? Is it double bar graph when we're comparing 2 sets of information at the same time? Is it going to be a pie chart because someone was asked what their favorites was, or there was certain information that we got that's out of 100%? Up to you to choose which ones are there, but there is going to be the best choice given different scenarios. So this might be a really great slide for you to take a screenshot of, to write down for each, but this shows you the different types of graphs that we're working with and when they are used. So pie charts show amount out of a percentage, a bar graph would show a single amount, a double bar graph compares 2 sets of data, A scatter plot, dots to show singular amounts, and a line graph would be change over time. So why do we do these? Knowing how to best display information so users can easily understand the data found will not leave anything that you create up for interpretation. So data and correctly displaying information could be essential for healthcare working, knowing how to help patients notice trends and determine next course of action. Knowing what kind of graph to use and how to show it will make it clear for those looking at the graph for the first time. So we are going to get into our sample questions for this lesson. As always, you can do them with me, on your own, or a mix of both. So sample question number 1. A university would like to see how many students have been accepted every year for the last 10 years. Which graph would best be used to show the information above? So I know we don't have the multiple choice here to refer to it, so let's look at the situation. What our graph is going to show is how many students have been accepted every year for the last 10 years. So when I think about this graph, I see the years on the bottom, and I see the number of students. What I notice is down here, years is time. And I'm going to think about how many students are accepted every year. Most of the time, it's not the exact same number. So I might see year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Showing change over time is a line graph. So a line graph would be the best way to show the number of students accepted over time. Sample question number 2. The transportation department wants to keep track of how long it takes different drivers to go the same distance on the highway. Which graph would be best used to show the information above? So what we're looking for is we're showing different drivers, but they're going the same distance, so the distance isn't part of it, and we're looking how long it takes. So what we're saying is this a change over time? No, because we're looking at, say, we have Sal takes 4 hours, and Mark takes 8 hours, and John takes 4.5 hours. What kind of graph would allow me to show someone's name and then how far they traveled? So what I think about it as, I see the person and the time. So I would say John, I could see, okay, that's 4.5. Mark, that's 8. Sal, that's 4. So for this one, how that information's organized would best be suited as a bar graph. Sample question number 3. Gerald's store made twice as much as Steve's in 2017. After that, Gerald made less each year, while Steve's store made more each year thereafter. Which graph below best describes the information above? All right, so let's take a look at what should we look at first. We know Gerald's store made twice as much as Steve's in 2017. So that should be able to help us figure out which graphs to look at or not. So we know Gerald is in yellow and Steve is in peach. So Gerald's store made twice as much as Steve's in 2017. Well, in this one, in A, Gerald actually made half of Steve's. That's not right. Let's look at B. Gerald made 1, Steve made 3. Gerald, that's not twice as much as Steve. Gerald still made less. In C, Gerald made 4, while Steve made 2. Well, Gerald made twice as much as Steve, so C still works. And let's look at D. Gerald made 4, Steve made 3. 3 isn't half of 4, so it's not going to be D. That one piece of information allowed us to figure out the correct answer was C. And we can check. So after that, Gerald made less each year. Okay, Gerald went from 4 to 2 to 1. That checks out. And Steve's store made more each year. So Steve starts at 2, then 3, then 4. So C does follow all of that information. Sample question number 4, and this becomes our final question for creating graphs. The price of gas in the United States drops during the winter months, but is more expensive in the summer. Which graph below best describes the information above? So let's look at our winter months for each. So that means we're looking at December, January, and February, where it should be the lowest price of gas. So it should be at the smallest. So if I look for January, February, and December on each of these graphs, is it lower than our summer months? And when we look about summer months, technically June, July, August. So if I look, whatever the winter is should be larger or smaller than the summer. So if we look at, let me choose a color that works. Let's do, okay. So if we look at A, I see in December, January it was $4. And in the summer months, it was 1, 2, 3. Was gas more expensive in the summer or the winter? In this one, it was the winter. So A is not right. In B, I see January was 2, February was 4, and December was 3. But if I look at the summer months, that's 4, 3, and 3. Was it less expensive in the summer months? More expensive in the summer months than the winter months? No, because February was $4. That's just as much as it was in June. So we wouldn't be able to say that. So B is not right. Let's look at C. Okay, January is 1, February is a little bit more than that, and December is a little less than 2, so we're halfway between. Where our summer months are 4, just about 5, and 5. C, I'm going to hold on to is our summer months are more expensive than the winter. Let's check D. January is 4, February is $3, December is also $4, and the summer, it's $4, $3, and $2. My cheapest month right here is August out of all of them, which is the summer months. So D doesn't work, which means C is our only choice. All right, we've come to the end of our creating graphs lesson. I hope this was helpful in having you interpret graphs, what types of graphs you're going to use, and you've learned something. So can't wait to work with you soon, and I'll see you later.
Hey y'all, Brian here, and I don't mean to make you angry, but today we're going to be going over the finding the mean. Hey everybody, welcome to Finding Mean on the TEAS with me, Brian, and let's jump right into today's lesson. Our goal for this lesson is we will be able to find the mean or average of a set of numbers. First vocabulary word, when we talk about mean, it means the average of a set of numbers. So what that means, and I know we hear the word mean a lot, if all numbers had the exact same amount, what would they have? So if we evened out all of these numbers so that they were all equal, what would that be? You'll hear the word mean, but know that mean and average are going to be the exact same thing. They are two words that describe the same concept, but the official term is mean. So key points, there are two steps to finding the mean. Step 1 is you're going to add up all the numbers in the set. So in this case, we have 18, 27, and 45. So we would take those three numbers, 18, 27, 45, and we would add them together. 8 plus 7 is 15, plus 5 is 20, drop the 0, carry the 2. 2 plus 1 is 3, plus 2 is 5, plus 4 is 9. So the total would be 90. So that's just step 1. Step 2. So this is key point number 3, but it's step 2 to find the mean. We're going to divide the sum of all the numbers in the set by the amount of numbers in the set. So the total was 90, and that's going to go inside. When we look, we have 1, 2, 3 numbers in the set. So we're going to divide by 3. Now we just do our long division. 9 divided by 3 is 3. 3 times 3 is 9. Subtract, we get 0. Bring down the 0. 0 divided by 3 is 0. 0 times 3 is 0. Subtract, again, we get 0. So the mean, in this case, is 30, which says that if all 3 of those numbers had the same amount, it would be 30. Key point number 4. The mean should be larger than the smallest number and smaller than the largest number. So that means that the mean should be between 4 and 116. This is just a really good way that in case you accidentally did your addition wrong or your division wrong and you got a number that is outside of these values, so meaning less than 4 or greater than 116, it's just a really good indicator of maybe you made a mistake. Why do we do this? So fluctuations or differences in data occur all the time, especially if we're tracking prices, blood pressure, heart rate, or other vitals. So knowing what the average means and how to find it is better going to help us interpret and understand whatever sets of data are put in front of us. So I told you before, it's like the same thing of evening out. So if we had all different numbers like we have in the graph above, what we're really doing is thinking about it like icing on a cake, where we just want to smooth it all out. So instead of having 6 different layers, we're really just trying to make it so that we have all of these the same size. That's what lets us find the average, and that's what the average means. All right, we are going to do some sample questions, so feel free to either do these on your own and then check in, do these with us, or a mix of both. All right, sample question number 1. What is the mean of the following numbers? We have 45, 68, 91, 34, and 55. So we're going to first look at our step 1. So step 1 is to add up all of our numbers. So we are just going to rewrite these numbers: 45, 68, 91, 34, 55. Now I'm going to show you this first set as if we do not have a calculator. But if you do not get a calculator on your exam, I want you to know that you can still add and do the long division fully by hand. 5 plus 8 is 13, plus 1 is 14, plus 4 is 18, so this should be 23. Drop the 2, drop the 3, carry the 2. 2 plus 4 is 6, plus 6 is 12, plus 9 is 21. Plus 3 is 24, plus 5 is 29. So we get 293. Now that we've added, we look at step 2, which is going to be to divide. Now we set up our division problem. We take our total, and our total was 293, and we divide it by the number of numbers we have. So we had 5 numbers. So in this case, we're going to divide by 5. 2 divided by 5 is 0. 29 divided by 5 is 5. 5 times 5 is 25. Bring down our 4. So we subtract, we got 4, we brought down our 3. 43 divided by 5 is 8. 8 times 5 is 40. It did not tell us to round to the nearest place value, so it does want us to keep going. Always check your answer choices. Decimal point, add that in. Bring a 0. 0. 30 divided by 5 is 6. 6 times 5 is 30, and it works out for us. So we get 58.6 as our average, or the mean. Sample question number 2, find the mean of the following numbers. So we have our decimals here, and here's what we want to check. We have 1, 2, 3, 4, 5, 6, 7 numbers. So I want to make sure that I have 7 numbers. So again, we do our step 1, which is to add. So if we take our numbers, 5.6, 8.4, 3.2, 9.8, 12.5, making sure you're lining up decimal points if you're doing this by hand. And we can add these together. When we add all of these together, we do get 56.5. So that brings us then to step 2. And that's going to be to divide. So if we set up our division problem, we have to know what we're dividing. We have 56.5. And we have how many numbers? In this case, we have 7 numbers. So we're going to divide by 7. So if I look, 56 divided by 7 is going to be 8. 8 times 7 is 56. Subtract, we get 0, decimal point. Actually, we don't need that there, so let's erase that. Let's not get confused. Okay, good. Bring down the 5. That's 0. 0 times 7 is 0. You get 5 is 7. 7 times 7 is 49. Subtract, we get 1. We get 1 again here, so we get 1 here. And this will keep going. So what we could do is we look at our answer choices, but I'm going to stop always at the third place after the decimal. And we would say that our average is 8.071. Sample question number 3. On his last 5 assessments, Paul scored an 87, 92, 93, 78, and an 85. What is Paul's current assessment average? All right, so we're looking for the average. So instead of using the word mean, this problem did say average. So step 1 is to add. So we're going to take the 5 assessment scores. It says 5, so we should check that we have 5. 87, 92, 93, 78, 85. And we're going to add these together. So 7 plus 2 is 9, 12, 20, 25. Drop the 5, carry the 2. That's 10, 19, 28, 35, 43. So we have 435 as the total, which now we can do step 2 is to divide. So we're going to take our total and put it inside. So we have 435. And we have the number of numbers, which is 5. So we're going to divide by 5. So 5 does not go into 4, but goes into 43 8 times. 8 times 5 is 40. Subtract, we get 3. Bring down the 5. 35 divided by 5 is 7. 7 times 5 is 35. Subtract, we get 0. Awesome. So in this case, Paul's current assessment average is an 87. Sample question number 4. The following shows the daily amount made at Mara's Mini Mart. What is the average daily amount of money made? And we're going to round to the nearest dollar, knowing that that's what it says. So if we look, we're going to do step 1 is to add. So we could line up these numbers, or we can add it from here. So if we have 6 plus 7 is 13, plus 4 is 17, plus 9 is 26, plus 5 is 31. So I know it's going to end in a 1. 31, that's 3. 3 plus 5 is 8, plus 8 is 16. Plus 2 is 18, plus 8 is 26, plus 1 is 27. So we get 27, carry the 2. 4 plus 6 is 10, plus 2 is 12, plus 3 is 15, plus 4 is 19, plus 7 is 26. So over the course of those 5 days, the total amount was 2,671. So I'm just going to move this up. And now we know step 2 is to divide. So I'm going to set up my division problem. 2,671 divided by 5. So it does not go into 2. It goes into 26 5 times. 5 times 5 is 25. Subtract, we get 1. Bring down our 7. 17 divided by 5 is 3. 3 times 5 is 15. Subtract, we get 2. Bring down a 1. 21 divided by 5 is 4. 4 times 5 is 20. So let's actually just move everything up just a little bit so we have enough space. There we go. Gives us 20. We get 1. Now we have our decimal point, add a 0. 10 divided by 5 is 2. 2 times 5 is 10. Subtract, we get nothing left. Now, here's what it said though, the nearest dollar.
So we have 534.2. Dollar is the ones place. I look next door, I see a 2. The 2 tells the 4 to stay the same. So we get $534 is the average. Sample question number 5. Sandra needs an 85 average to pass her science class. She has taken 4 out of 5 assessments and has scored an 82, 71, 95, and an 87. What must she score in her last assessment to meet her 85 average? Okay, so what we need is that Sandra needs an 85 average to pass her science class. So I have to think, what does that mean and how do I set everything up? I know this is an average problem. So I know step 1 is to add, and step 2 is to divide. So I know that I have this here, and if she has an 85 average, where do you end up solving the average? Where did that pop up every single time that we did a problem? 85 was the answer, or should have been the answer to the division problem, because the average pops up when it's the answer to a division problem. She has taken 4 out of 5 assessments. So we know 4 out of 5. So that means that there's a total of 5 numbers that were added together. So that must be here. I also must have 1, 2, 3, 4, 5 numbers being added together. Now, we know that the assessments so far have been 82, 71, 95, and an 87. But we don't know the 5th assessment because Sandra hasn't taken that yet. So I'm going to put in X. And we need to know what must that score be in order to meet her 85 average. So in this problem, we can figure out 2 things right now. We can figure out how much we have so far. So let's do that. I know 2 plus 1 is 3, plus 5 is 8, plus 7 is 15. So I'm going to drop the 5, carry the 1. So 1 plus 8 is 9, plus 7 is 16, plus 9 is 25, plus 8 is 33. So we know that so far, she has 335 points. But I'm missing that 5th assessment. What I also notice is that over here, this really said something divided by 5 is equal to 85. How do I work backwards to find the missing amount? I can reverse this. I can do 85 times 5. Will tell us what the missing total should have been underneath so that when we divided by 5, we got 85. So 85 times 5 is equal to 425. So that must mean that the missing total of everything should have been 425. So that means if we had 335 plus that missing amount, that should equal 425. So how do we find the X amount? We're going to take the total needed, which was 425, subtract the total amount of points we have right now, or Sandra has right now, and see what's left. So 5 minus 5 is 0. 12 minus 3 is going to give us 9. 3 minus 3 is 0 as well. So we found out that in order for Sandra to get an 85 average, she must score a 90 on this next assessment. Tricky one, but definitely I know you can get it. All right, we've come to the end of Finding Mean as part of our lesson here at Nurse Hub. Go forth, go try all these out on your own, and I can't wait to see you soon. Good luck. Hey everybody, Brian here at Nurse Hub. So wonderful to have you for another one of our great math lessons. So our lesson today is going to be on using tables to find the mean. Hey Hey everybody, welcome to Using Tables to Find Mean on the TEAS with me, your host today, Brian. So let's jump right into our lesson. Our goal for this lesson is that we will be able to find mean using tables. Key vocabulary, the word mean, that means the average amount of a set of numbers. So if you are not sure about how to find the mean, please go back to watching the Finding Mean video. From here, we are going to take the knowledge of how to find the mean and apply it to tables. When we have a table, it's numbers and items that are going to be organized in columns and rows. So understanding what the table is showing you, how to interpret it, how to use it is going to be important. In this case, we see the title at the top is month versus sales. So we see in January, the sales were $6,125. We have February, March, April, and May. So we have 5 different months with their total sales being shown here. When we have something called a frequency table, that is going to show the number of times that something occurs. And what's most confusing is that it usually means that there's numbers in both columns. So in this case, we see student ages and frequency of 8. What that means is that in this column here, we have 8 students whose age is 10. So if we actually did that, we'd have 10, 10, 10, 10, 10, 10. I hope this is 8. 1, 2, 3, 4. Yep, we have 8 here. For students that are 11, it means we have 13 students that are 11. We have 11 students who are 12 years old. We have 9 students who are 13. And then 2 students who are 14. So it's not that we're writing out these numbers. The frequency table shows how often these numbers show up. And we'll go more into that later. When we deal with tables, you always need the total and the amount of numbers to find the average. So for example, in this case, we would be able to do 2 things. One, we'd be able to add all 5 of these numbers together. And when we found our total, we know that we would be dividing by 5. So the total goes inside. And why are we dividing by 5? Because there was 1, 2, 3, 4, 5 months involved in this problem that we were adding together. You're going to calculate the sum of all included numbers. So that would be still step 1. So if we added these together, we get, our answer would be 29,337. So that would be the total of all 5 of these months. Now we're going to divide the sum by the amount of numbers included. So our number from before was 29,337, and we divided it by 5 because there are 5 numbers. So 2 is not divisible by 5, so we put a 0. Wow, thank you for dealing with me with those words that refuse to come out. 29 divided by 5 is 5. 5 times 5 is 25. Subtract, we get 4, bring down a 3. 43 divided by 5 is 8. 8 times 5 is 40. Drop that, we get 3, bring down the 3. 33 divided by 5 is 6. 5 times 6 is 30. Subtract, we get 3. 37. 37 divided by 5 is 7. 7 times 5 is 35. We get 2. I'm going to add a decimal point. Add a 0. Decimal point above. 0. 20 divided by 5 is 4. And that will cancel out. Now, this is money. We only have one number after the decimal right now, so we have to add a second. So our answer would be $5,867.40. One of the most important things is really double check to make sure you've included every number. The last problem only had 5 numbers in it, so that's not as confusing to make sure you have all 5. But especially with frequency tables, it is very easy to not count all of your numbers or to use all of your numbers. So be careful. When we deal with tables, remember your mean should always be between the largest and smallest amounts. This is going to be a great indicator that if you've made a mistake. It doesn't have to be directly in between. So for example, if our lowest number was 12 and our highest number is 37, the average should be somewhere in between those two numbers. Average can move based on what numbers you have, but it should never be smaller than the smallest or larger than the largest. When we deal with frequency tables, again, these are going to show how often numbers occur. So in this case, it's saying how many students are aged 10. 8 students are 10 years old. How many students are 11? 13 students are 11. How many students are 12? 11 students are 12. How many students are 13? 9 students are 13. How many students are 14? 2 students are 14. All right, when we have frequency tables, we can write out each number involved. There's going to be a lot of repeated numbers. Remember, when we look at the students' ages, these are the only ages that are involved. 10, 11, 12, 13, or 14. The frequency tells us how often those numbers show up. So for example, we have the student age of 10, 8 times. So I'm going to write down 10, 8 times. The students that are 11, that shows up 13 times. So I'm going to write down 11, 13 times. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. I'm going to write out the number 12, 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. The number 13 is going to come out 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we get the number 14 2 times. So that's actually how many numbers are involved in this frequency table. So really understand what frequency tables are showing you. Then you can add up all of the numbers. So one easy trick to do this is actually to multiply each of these rows together, then add them. Because if you have 10 8 times, that's equal to 80. You have 11 13 times, so that's 143. You have 12 11 times, so that's 132. You have 13 9 times, that's 117, and 14 2 times, that's 28. So from here, you'd be able to add up your total. So if we did 80 plus 143 plus 132 plus 117 plus 28, that equals 500. So our total is going to be 500. All right, so now that we have 500, we know that that's our total. We have to figure out the amount of numbers that we have. And the amount of numbers that we have is actually going to come from this column. If we actually add all of these together. So if we do 8 plus 13 plus 11 plus 9 plus 2, that's going to give us 43. So 43 students were actually asked. From here, then you'd be able to find the average. Which in this case, if we did 500 divided by 43, we would get something like 11.6279. And it keeps going. Pay attention to what the question asks. If it asks you rounding to the nearest year, it would be 12 years old. Or if it said round to the nearest tenth of a year, just pay attention to what the question asks of you. Back to this real quick. When I first made this video, I actually ended up writing 13 times. Why? Because I saw the number 13, I got a little too excited to write them down, and I forgot to really interpret the graph. Know that it happens to anyone who's working through this. Double check. Also, make sure to double check to make sure that you've interpreted the graph correctly and your answers make sense. This is really important to make sure that you just looked at the chart, you used it correctly. In fact, on that last problem, I actually ended up writing the age of 11. I wrote the number 13 times. I looked at it quickly, tried to get it done, didn't pay attention, and almost got the entire answer wrong. So really make sure that you pay attention because it can happen if you don't really focus on what's in front of you. Frequency tables, again, your mean should still always be between the largest and smaller numbers. Before our highest age was 14, our lowest age was 10, and our average was about 11.6. So it wasn't directly in the middle, because that doesn't always have to happen, but it was between 10 and 14. Why do we do this? So fluctuations in data are going to occur all the time. So from prices, blood pressure, heart rates, or other vitals. It's really important for us to be able to understand the information that's in front of us, how to use it, what to find, what it means, just so that we can make the best decisions. We've come to our sample questions. So as always, you can either do these with me, try these on your own, or any mix of in between. How many students are in the average 5th grade class? So if we see here, we have our classes, 5A, B, C, D, and E, and we have our number of students. So if we're looking for how many students, we know that this is where our focus is. So we look at our step 1, which we know by now is to add. So if we did 18 plus 22 plus 16 plus 20 plus 25, we get to our total is 101. So if we're going to then take our step 2, we're going to divide 101 by 5. 5 does not go into 1, so we put up a 0. 5 goes into 10 twice. 5 times 2 is 10. 10 minus 10 is 0. Bring down the 1. 1 divided by 5 is 0. 5 times 0 is 0. We subtract, we're going to get 1. We can finish it out, so let's add a decimal point 0. Bring it down, that's 0. 10 divided by 5 is 2. Times 5 is 10. We get 0. But we have to always ask, does this make sense for the problem to have 20.2 students? Can you have 0.2 of a student? This may not be an option. So our best answer choice would be 20, not 20 and 2/10, because we could not have 2/10 of a student. What is the average number of siblings that people have? Okay, so step 1 is to add. Now, it is very confusing to write out all of these numbers. So instead, what we're going to do is we're going to use the shortcut. That means if we multiplied the number of siblings by the frequency they show up, we're going to get the total for each column. So instead of having to write 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, we could do that, but it gets really tedious to write all this stuff out, and we may not have the time or space to do so. So instead, we multiply. So we know that 0 times 5 is going to be 0. 1 times 7 is 7. 2 times 9 is 18. 3 times 6 is also 18. 4 times 3 is 12. Much easier to add this set of numbers together. So 8 plus 2 is 10, 18, 25. 2 plus 1 is 3, 4, 5. So we get 55. So the total number of siblings is 55. Which then takes us to step 2. We're going to divide. So we're going to take our total, 55, and we're going to divide it by the total number of people that were asked this question, which is these numbers put together. That's how many people responded. So if 5 people responded 0, plus the 7 people who said 1, plus the 9 people that said 2, plus the 6 people that said 3, plus the 3 people that said 4, that means that 30 people were asked how many siblings they had. So we can do the division. 30 goes into 55 once, minus 30, we get 25.0. Add a decimal point, 250 divided by 30 is going to be 8. 8 times 30 is 240. 10. We don't have to keep going because this might give you some idea. Siblings can't be split into decimal pieces, so that's not really going to work for us. So you may see on yours 1.8 because sometimes math allows that idea of 1.8, but if it's a fill-in, you can't have 0.8 of a sibling. So you might see either 1 or 2. In this case, let's stick with 1.8 or one sibling because we haven't quite crossed over to 2 just yet. What is the average amount of time studied for exams? We know we're finding average, so we know that step 1 is going to be add. We notice that this is a frequency table. Also helps us to see the word frequency. So when we look at this, we know that we have 2 sets of numbers, and you have to figure out which number is being repeated. Well, this one means that 10 people said 1 hour. So you don't have 10 once, you have 1 10 times. If it helps you to write these out for all of them, by all means do that. But it does get more confusing. It's easier to miss numbers. So let's actually instead use our shortcut and multiply the number of hours studied by each person. So 1 times 10 is 10. 2 times 11 is 22. 3 times 7 is 21. 4 times 6 is 24. 5 times 3 is 15. So now I can add these together to get the total number of hours studied. And that gives us 92. So we get a total of 92, and what that means is there's 92 hours studied, which takes us to step 2, which is to divide. So we're going to divide 92 by the number of people that were asked. So we have 10 people that were asked, plus another 11, plus another 7, plus another 6, plus another 3. So that's going to give us 37. So we have 92 divided by 37. This time I am going to put it into my calculator. And that's going to equal 2.486. Now, we could use this to round off. So that 8 would tell the 4 to become a 5. So we could say 2.5 hours. I know the estimation seems a little off. You may be asking, why are you rounding this one? Why are you estimating this one? I just want to show you different ways that you might be asked to estimate, because you're most likely given multiple choice questions, and those multiple choice answers will tell you how to round or show you where you should be rounding to. If it's a fill-in, it should almost always tell you exactly what to round to, because there would be too many options otherwise. All right, what is the average cost of renting a car for 5 days? So let's actually take a second to interpret this question. So here's what I see. I see that this is car rental prices. I see that I have 4 types of car rentals. And this breaks it down into day 1 and each additional day. And we're looking for the average cost of 5 days. So let's actually go one by one. Let's look at the compact. So I know the first day is going to be 45, and each additional day is going to be 15. So if I want that for 5 days, my first day is 45, and the other remaining 4 days are 15. So that's 45 plus those 15s is going to give me a total of $105 for the compact car. If we look at the full size, it says the first day is 65 and each additional day is 20. So the first day is 65, so the 4 remaining days are 20. So that's going to cost me $145 for the full. If we look at the SUV, we know the first day is 95, and each additional day is going to be 30. Put those together, and the SUV is going to equal $215 for 5 days. And then we finally have the luxury, which is $125 for the first day and $50 for each additional day. So that's going to equal $325. So we found the total cost over here of these 4 cars, or these 4 types of rentals. So we've done a really good step 1 because we know that in order to find the average, we do need to find the total cost. So let's take this to a slide. All right, so we know that the compact, again, if I just write this real quick, is 105, 145, 215, and 325. If we take our step 1 and we add those 4 numbers together, that's 5. So if we did this, actually, let me write it here for us. 105, 145, 215, 325. That gives me 20. 2 plus 4 is 6, 7, 8, 9. That's 3 plus 2 is 5, 6, 7. So it gives us 790. So if we look for step 2 and we divide, that's going to give us 790 divided by 4. Now, one thing I want to remember is that this is money. And remember, whatever the answer is, money has 2 decimal places after the decimal. So 4 goes into 7 once. That's 4. Subtract, we get 3. 39. 4 goes into 39. 9 times. 9 times 4 is 36. We get 3. Bring down the 0. 30. That gives us 7. 7 times 4 is 28. Subtract, we get 2. Decimal point 0. Decimal point above. 20 goes divided by 4 is 5. 5 times 4 is 20. We lose it. Okay, good. So let's look at before the decimal. We have 791. So $197. And we have our 5 goes here. We need to add our 0 to show that it's money. So we get $197.50. All right, it is your turn. So go try these out. Go work through these problems. It is your turn. You absolutely have this. And I can't wait to work with you soon. Welcome to another lesson here with me, Brian, and today we're going to be covering finding median, mode, and range. So let's jump right in. Hey everybody, welcome to Finding Median, Mode, and Range on the TEAS math course with me, Brian. All right, let's get it started. Our goal for this lesson is that we will be able to find the median, mode, and range from a set of data. Now, what do these mean? The median is the number in the middle when all the numbers in the set are lined up from least to greatest. The median stands for and lets people know that 50% of the numbers in the set or that are involved are larger than the median and 50% of the numbers are smaller than the median. So it gives you a good indicator of where the middle line would be. One way to remember median is also if you think about the yellow line in the middle of the road, that is also called the median. Median does stand for middle. Mode is the number that appears most in a set of numbers. So there may be one mode, no mode, or more than one mode. So if there was 3 numbers that showed up 5 times, those all 3 could be the mode. Now, when we think of mode, one way to remember it is the word most, mode, most, so that this way you can tell the difference between all of the 4 ones that we're using. Range is the difference between the highest and lowest numbers in a data set. So if the lowest number, say, was 37 and our highest number was 89, to find the range, we would do 89 minus 37, which would give us 52. All right, key point number 1 with median. When you do this, you're going to have to line up your set of numbers from least to greatest. Double check to make sure you've included all the numbers. So if you just circled this and said 28, that's not going to be correct because these numbers are not in numerical order. So one thing we do is we have to first line them up. So 13, and I like to cross them out as I use them so that I don't get confused. That's 17, 21, 28, 47. As you can see here, 21 is our median, not 28. When we line them up, 21 was in the middle. It means that 50% of numbers are larger than 21 and 50% of numbers are smaller than 21, which in this case does work. All right, you are going to work your way to the middle. The number in the middle is your median. So I just showed you before what it looks like, but when you have larger numbers, one thing is you start from the left and you cross out, you'd go to the right and match. Left, right, until you either have one number left or two numbers left. If it's one number left, immediately that is your median. And we're going to discuss what happens if you have two numbers in the middle. So if you have an odd amount of numbers, your median is always going to be a part of the set that you had. So for example, if we had 3, 7, 14, 18, 97, we have 5 numbers here. So there's always going to be one number exactly in the middle. If you have an even amount of numbers, there are going to be 2 numbers in the middle. So if we looked here, that's 13, 47, 17, 28. We have 2 numbers in the middle. Now to find the median, you're going to add the 2 numbers in the middle and divide by 2. So you actually find the average of those 2 numbers. So if we did this, we would do 21 plus 25 gives us 46. And if we did 46 divided by 2, because we added 2 numbers together, that would give us 23. So our median in this case would be 23. Now, if you did put 23, which would be about right here, it does show that 50% of your numbers are less than 23 and 50% of your numbers are greater than 23. For the mode, when the numbers are lined up least to greatest, the mode is the number that appears most frequently. In this case, the only number that's repeated is going to be 28. So here the mode would be 28. For the mode, if 2 numbers show up the most, the same number of times, then both of them are going to be the mode. If no numbers show up the most, there is no mode. So for example, if we had 3, 11, 15, 28, 36, none of these numbers get repeated, there is no mode. So, and then the final one, if one number shows up the most number of times, that number is the mode. But if we looked at 1A real quick, let me just show you. So if we had 3, 3, 11, 15, 28, 28, 36, if you see 3 showed up twice and 28 showed up twice, these would both be the mode. And the range, we subtract the smallest number from the largest. So in this case, we see our largest number is 47. Take away our smallest number, which is 13. And that gives us 34. So our range here would be 34. Now, why do we do this? Median, mode, and range all give us different information about a set of numbers or data. It allows us to look for trends, the size differences of a sample, and the kinds of numbers that may have shown up in a sample without having to look at all the numbers. So being able to find the median, mode, and range on your own is going to help you interpret information you're given for the median, mode, and range. All right, it is time for sample questions. So let's jump in. Let's try them out. You can do them with me, on your own, or a mix of both. Sample question number 1. What is the median of the following numbers? So the first thing we're going to do, I know median, that's middle, line them up. So I'm going to use just a different color so we can easily see the difference. So I see 17 is the lowest. And I also like to space out my numbers in case I'm wrong about something or I missed something. I then look again, 22 is next. Then 23. I don't see anything else in the 20s. I see 1 in the 30s. That's 34. Then I see 48. Then I see 78. Oh, look what I noticed. I missed 65. That's why I crossed these out. So I'm actually going to erase this, put 65 in, then continue with 78, 80, 92. I wanted to leave that mistake in there so that you could see that it's easy to make these mistakes, but that's why we cross out. That's why we double check. I also look, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. I have them all. Now I notice that I have an odd amount of numbers, which tells me I should have one number in the middle. So cross out, cross out. And our median is going to be 48. Sample question number 2. What is the median of the following numbers? Again, we're doing median, so we're going to have to line up our decimals from least to greatest. So let's again do a different color, and hopefully I don't get this wrong. I think 2.1 is the smallest. Then I see 2.8. Then I get 4. Then 4.3. 5.5. 6.2. 9.7, and 9.8. So I have my numbers. I'm going to just do a quick check. I have 1, 2, 3, 4, 5, 6, 7, 8 numbers, and 1, 2, 3, 4, 5, 6, 7, 8 numbers lined up. 8 also tells me that I'm going to have 2 numbers in the middle. So we'll have to do something a little special. So 2.1, we cross out till we get to the middle. And I notice I have 2 numbers here, which means I first have to add them together. So 4.3 plus 5.5 gives me 9.8. And then I divide by 2. 9.8 divided by 2, that's 4. 8, 1, 9, 18, 0. So my median in this case is 4.9. 17. The following are students' assessment scores. Find the median, mode, and range of the following numbers. Now, all of these are going to start the same way. Let's line up our numbers from least to greatest. So I'm going to start with 65. Let's see. And if I'm wrong, we can always change. Okay, I'm going to look for anything else in the 60s. That's 68. Nothing left in the 60s, so let's move on to the 70s. 75. I see 78. I see another 78. I see an 80. I see an 88. I see a 90 and a 92. So now I can find my median. So let's check. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. That means 1 number is in the middle. So I'm just going to do X's on top since I have to still use some of this info. So I know my median is going to be 78. Now I look for my mode. Is there a number that shows up more than any other number? Yes, that's also 78. And I'm going to look for my range. Remember, it's my highest number, 92, minus my smallest number, 65. So if I subtract, I get 27, so my range is 27. I found my median, my mode, and my range. Let's look at sample question number 4. The following are the prices of different air conditioners. Find the median, mode, and range of the following numbers. So because we're looking again for the 3 that we need, so median, mode, and we have range, the first thing that we have to do is put our numbers in size order. So I'm going to take, that's 150, cross it out. Then I see 220 seems the lowest next. Yep. So I'm going to say 220. Then I see 225. See another 225. Good indicator to pay attention that you saw the same number twice. 286. 375. Another 375. And a 410. So 1, 2, 3, 4, 5, 6, 7, 8 numbers. Also a good indicator that I will have something in the middle. I'll have 2 numbers in the middle. Totally good to know. So for our median, I'm just going to X these out till I get to the middle. And I see this here. So when I'm finding the median, and I have 2 numbers, remember our step 1 is to add. So we have 225 plus 286. That's 1, that's 10, 11. We get 511. And I would divide 511 divided by 2. So that's 2, 5, 5. And we add a decimal point, 0. So our median is 255.5. Our mode, I see that if we're looking at the mode, I see 225 is used twice and 375 is used twice. So it actually is both of those, 225 and 375. Now for the range, we're going to take our highest number, 410, minus 150. Subtract. We get 260. Therefore, we've found all 3 that we need. All right, sample question number 5. The temperatures for the next week are as follows. 68, 72, 74, 68, 70, 75, 82. Which of the following statements is true about the above information? I see the mode is greater than the median. The mode is less than the median in range. So I'm even looking at these answer choices, and it's telling me that I need to find all 3 of these. So I know I need to find my median, my mode, and my range. Now, 2 of these we can do very quickly. So let's look. So first, let's order these up from least to greatest. So I'm just going to do this up here. I see the smallest number is 68. Then I see another 68. Then I see a 70, a 72, a 74, a 75, and then finally an 82. So I'm going to look for mode. Do you see a number that appears the most? Yeah, 68 is the only number that appears more than once. So then I'm also going to look for the range. So if I know that my highest number is 82, and my smallest number is 68, that is a range of 14. This might also give you some insight to go look at some of your answer choices. So it says that the mode is equal to the range. Well, the mode is 68, the range was 14. So that's not going to work. The mode is less than the median, but greater than the range. Well, I need to find the median. And A, B, and D all say the word median in it, so we need to actually figure out the median first. All right, so if we look at our numbers here, if I crossed off going at the end, and I can cross them off now since I used it for the others, I see that my median is going to be 72. 1, 2, 3, 4, 5, 6, 7. There was an odd number of numbers, so that means there was one number in the middle, so our median is 72. So let's look at our answer choices now that we have our options, our median, mode, and range. The mode is greater than the median. Okay, that's not true. The mode is less than the median and range. Well, the mode's actually greater than the range, so it's not B. And D says the mode is less than the median. Okay, 68 is less than 72, but greater than the range. 68 is greater than 14. So our correct answer choice is D. Hope you got it. All right, another lesson is in the books. You should be really proud of yourselves. Keep working, and I can't wait to see you soon.
Hey everybody, Brian here. Again, so good to see you. So either welcome or welcome back. And we are going to be covering statistics word problems.
Hey everybody, welcome to Statistics Word Problems on the TEAS 6 math course with me, Brian, and let's get right into it. All right, our goal for today is that we will be able to solve word problems involving mean, median, mode, and range. All right, so our first vocabulary word is going to be the word mean. So remember, that means the average of a set of numbers. So it's the same thing as saying, if all the numbers have the same amount, what would it be? Remember, it's evening out so that each amount that you have, they all would be the exact same. We also have the median, so that's the number that's in the middle after all the numbers are lined up from least to greatest. Remember, you have to line up your numbers from least to greatest before you find the median. Otherwise, you're just choosing a random number based on the lineup you have and is not actually in the middle. So what does it show? The median shows that by being in the middle, it shows 50% of numbers are larger than that, and 50% of your numbers are smaller than that value. So it lets you really know what that middle number means. 3, we have the mode, and that's the number that appears the most in a set of numbers. And remember, there can be one mode, no mode, or more than one mode. We also then have range, and that's the difference between the highest and the lowest in a set of data. So if we just said, say we had quickly 3 numbers, 45, 72, 98, and we wanted to find the range. Well, our highest number is 98, our lowest number is 45, so we subtract it, and our range would be 53. So when we are doing word problems, I know word problems are something that makes everyone concerned, everyone worried, but we always read the full question. Read the whole thing, fully understand what's being asked. 2, what measures are you asked to find? So focus on that. Does it say the average? Because then you're finding the mean. Do the answer choices say mean, median, mode, or range? Which ones does it focus on so you know exactly what you have to do and you don't do things that you don't have to work on? So this way you don't waste any extra time. 3, take time to organize your information. Organizing it from least to greatest, making sure you've included all of the numbers. Fill in numbers along the process. So what do you need to do? What are you working through? Really organize your numbers before you tackle anything. Then solve for each piece that you need. So remember, some of your answer choices may say things like, the mean is larger than the median and the mode. That means you need to find the mean, median, and the mode. Take the time to do those first, then look at your answer choices to match. So why do we need to know this? So interpreting a set of information lets us know what the information means, what implication it has, and potentially what needs to happen moving forward. So being able to use these 4 different statistical elements will help you look at, interpret, and work with different information, including things like patients' medical charts, clinical studies, and whatever work that you see in a nursing textbook. So before we even get to our sample questions, one of the things that we get asked the most is like, how do I remember all 4 of these? So we think about mean. Mean, remember, is just the average. So if it helps you think of it as average, that's a good way to think about that as well, but not necessarily tells you how to do it, but what you're looking for. Median, if you look at a road, I always think about it as if you're driving down the street and you have that yellow line in the middle, that's known as the median. And the median is always in the middle of the street. So it's a good way of thinking that is the middle of the road. That is the number you're looking for that's in the middle. Mode, I always think of most because that's the number that is going to show up the most. And finally, we have range. So when you think of range, I kind of think of how far you can stretch. So I'm seeing how far those numbers stretch from the least to the greatest. All right, we are going to jump into our sample questions, and you have your 3 options. You can try them with me, you can try them on your own, or you can do a mix of both. All right, question number 1. Ernesto scored the following on his assessments. What is his assessment average? 87, 92, 98, 88, 80, 72. All right, so what we first see is we see average. So now that we know that we're going to find the average, and the only thing we have to find is the average, we actually don't have to line up these numbers from least to greatest. If it said anything about median, mode, range, then absolutely we do. So we know that the first thing that we're going to do is our step 1 is we're going to add our numbers together. So I'm just going to take a second, make sure we line up our numbers. Now, I'm going to show you this first one as if you did not have a calculator. If you do, that's awesome. So let's go through it. 7 plus 2 is 9, plus 8 is 17, plus 8 is 25, plus 2 is 27. So we drop the 7, carry the 2. 2 plus 8 is 10, 19, 28, 36, 44, 51. So we get 517 is our step 1 total, which then leads us to step 2, which is to divide. So if we look, we do get 517, and we are going to divide this by 6. Now, why do we divide by 6? Because we have 1, 2, 3, 4, 5, 6 numbers. So if we do 517 divided by 6, 5 divided by 6 is 0, so we go to 51. 51 divided by 6 is going to be 8. 8 times 6 is 48. Subtract, we get 3. Drop the 7. 37 divided by 6 is 6. 6 times 6 is 36. Subtract, we get 1. We're going to go one place after the decimal. 0. Let's bring that down. 10 divided by 6 is 1. 6 times 1 is 6.
Subtract 10 minus 6, and we get
4. And we're going to stop just here. Now, if you put this into your calculator, it will continue going with 6s. That's fine. There's actually no multiple choice answers here. Generally, you would keep it to one place after the decimal, but know that if you do have an answer choice option, see what it says. If there are multiple numbers after the decimal, then you keep going. If it's a fill-in, like a fill-in-the-blank question, it will tell you exactly how many spaces to go and where to round off to. So really just pay attention to what the directions are. Since we don't have specifics here, we don't need to do anything like that. All right, we are going to look at sample question number 2. The prices of cereal in a grocery store are $4.59, $3.72, $3.19, $3.58, $3.99, $4.50, and $2.65. Which of the following will most accurately describe the prices of the cereal? Is it the mean, the median, the mode, or the range? So we're looking for most accurate description of the prices. So if we look at the middle price, so we know median is the middle, the mean is the average, the mode is which one shows up the most, and the range is the highest minus the lowest. If I really want great information about the prices of the cereal, I'm most likely going to wonder if all of the cereals cost the same amount, what would that evened out amount be? That would give me a good idea of the prices that I could expect from the cereal aisle if I was going in there, right? Because if I got the median, that just tells me the middle, but I could have a cereal that's $7,000 and have no idea because the median only tells you 50% of the cereals are more expensive or less than expensive than this. The mode, we could have 8 cereals that are 99 cents because they're store brand, and that's not really going to tell us the normal price of cereals. And the range, the highest minus the lowest, just tells us the difference between those two, but tells us nothing about the middle. So in this case, the average is the evened out amount of all of the cereals is going to be our best option to let us know that this is the most accurate description. Remember, it also said accurately describes. All of these are going to give us information about the prices, but it's which one is going to be the most accurate about the prices. All right, sample question number 3. Which sentence below accurately describes the daily high temperatures over the last week? So it says, here are the temperatures: 71, 68, 55, 68, 77, 78, 73. And we have A, the mode and median are the same. B, the median is greater than the mode. C, the range is greater than the median. Or D, the median is less than the mode. Okay, so I'm just going to take this one to the side. Okay, so we have this here. We have our numbers. And we're figuring out which one of these answer choices accurately describes this. But I'm going to pay attention to what I see here. I see mode. I see median. Median and mode again. I see range. I see median again. I see median and mode. So actually, this has nothing to do with mean. So I don't need to worry about the mean, but I do want to find the median, the mode, and I do want to find the range. So first thing we have to do is line up our numbers least to greatest. So I'm going to look. So I'm going to put 55, cross it out. What do I see next? Okay, I see 68, 68. Then I see 71, 73, 77, and I see 78. So I'm going to do a quick check. That's 1, 2, 3, 4, 5, 6, 7 numbers. And I have 1, 2, 3, 4, 5. Good. 7 numbers here. Perfect. So median, I'm going to go last. So lowest to highest, lowest, highest, lowest to highest. And I see 71 is in the middle. So my median is 71. I'm going to look for the number that is the most. I see 68. And there's no other numbers that are repeated, so it's just 68. And when I look at the range, that is, I'm going to take this just to the side. I don't like to do subtraction horizontally. So 78 minus 55, that's 3, that's 23. Okay, so let's look at the answers here. So mode and median are the same. Well, no, because the mode is 68, the median is 71. So it's not A. The median is greater than the mode. Okay, well, that one works. So I'm going to just put an arrow towards it just so I can check the others. The range is greater than the median. Range is 23 and the median is 71. No. The median is less than the mode. No, the median is 71 and the mode is 68. All right, so now that we checked all answers, there was only one that was right. So I'm going to circle this one here. Now, there might be ones where it says choose more than one. That is a great habit to make sure you check all 4 answers, just so that you know which answers are right or wrong, and you've read the directions to see if there are more than one option. So I would highly suggest making sure you check all 4. It's the best way to see if you make a mistake, because the one that you chose, you might have read it wrong and moved on very quickly. So sometimes checking the other ones, even though we saw B second, we had to check the other 2 to rule them out so we knew that we were right. All right, sample question number 4. Which description best describes the information above? And we have, I see months of the year and snowfall amounts. Okay, so it says the median is greater than the mean. The mode is larger than the median, but not the mean. The mode is greater than the mean and the median. The range is smaller than the mean. All right, so what I see is I see median. I see mean. I see mode. And I see range. So let's look at our options here. All right, so as we look here, I know it's a little bit smaller, but we have the information from before and we have our information here. If we look, we do actually have to find the mean, and we do need to find the median, the mode, and the range. Now, why did I separate these like this? Because the mean is just going to require a little bit more space since we do have 2 steps, and the median, mode, and range require less math, but we do have to organize the numbers. The mean also doesn't require us to organize the numbers, so I kind of think about them as 2 different things. So let's actually start with the easier ones to do, which is the median, mode, and the range. So I'm going to order my numbers from least to greatest. So I'm going to put 1.8. Check mark since I used it. 1.8 again. Now, if you want to separate these with semicolons just so you can see them, up to you. But if it's your own paper, as long as you know the difference between the numbers, that is okay with me. All right, 5 numbers. We have our 5 set up here. We can go from the outsides to the insides. All right, so our median is 4.2. Our mode, which number shows up the most, is 1.8. And our range will be our highest number, 6.3 minus 1.8. Subtract. And we get 4. Let's have that color match. 4.5. Remember, these are all inches for snowfall amount. So If we look, the only one that does not involve the mean so far is C. So if we looked at C, it says the mode is greater than the mean. Actually, mean is involved in all of them, but it says the mode is greater than the mean and the median, and the mode is not greater than the median. So I automatically know that C is out. So now I can focus on the mean. So we know step 1, we're going to add our numbers together. So 1.8, 4.2, 6.3, 1.8, 4.4. Okay, let's add them together. 10, 13, 21, 25. Make sure I have my decimal point. 2 plus 1 is 3. Plus 4 is 7. 6 is 13. 14. I have a total of 18.5 inches. And then we're going to divide. So I'm going to set my division problem. 18.5 divided by 1, 2, 3, 4, 5 numbers. So I divide by 5. Sorry if that was a little sloppy. I was just trying to write those numbers quickly so we could have it. We have 5 does not go into 1 but goes into 18 3 times. 3 times 5 is 15. Subtract, we get 3. Get the 5. Bring up our decimal point. 35 divided by 5 is 7. 7 times 5 is 35. So we subtract, we get 0. So our mean is going to be 3.7. So then we can look at our answer choices. It says the median is greater than the mean. That actually is true. Check mark. The mode is larger than the median, but not the mean. Well, it's not larger than the median. So mode, no. Sorry, that's B. The range is smaller than the mean. The range is actually larger than the mean. So that's not true. So that means the only option for us in this case is going to be, and let's get the green out since that's the right answer, is going to be option A. All right, sample question number 5. Krista's goal is to spend an average of 45 minutes a week working out. So far, she has worked out for 35, 50, 45, 32, 43, and 60 minutes. How many minutes should she work out the last day of the week to meet her goal? Okay, so there's no option here, so I can't really get clues from answer choices. But here's a few things that I see. So I know that Krista's goal is to spend an average of 45 minutes a week working out. So I'm going to look at the 2 steps because I see the word average here. So I know to find the step 1 of the average, we add. And for step 2, we divide. Notice that this problem told us the average already. It wants us to have an average of 45. It's not asking us to find the average. So I know that when we divide, we actually do that and solve for the average. So the average is 45. And I also know that it means a week. So in that week, how many days are in a week? 7. So how many numbers would have been added together? I should have 7 numbers here, which means I divided by 7. Okay, so I think, what can I find right now? If I know the answer to this division problem, and I know what I divided by, I'm actually missing what's inside. So think about it like this. This inside is the total minutes that were worked out. So if we took that red number and we divided it by 7, it actually would equal 45. So how do we find the red number? If we flip it and do the answer times 7, and we use the fact family, that's going to give us the red number. So if we did 45 times 7, we get 315, which tells us that in order to have an average of 45 minutes a day,
Krista has to work out 315 minutes that week. Where does that total go? That means when all 7 of these numbers were added together, she should get a total of 315. What are her numbers so far? Well, what we can get from this is that her numbers are as follows: 35, 50, 45, 32, 43, and 60. But it says how many minutes should she work out the last day? So we know that one of those numbers is missing. So we have 35, 50, 45, 32, 43, 60, and this unknown number that I'll put in as X. We don't know what that 7th number is, but what we can figure out is how much these 6 numbers are. So if I added 35 plus 50 plus 45 plus 32 plus 43 plus 60, that tells me I have a total of 265 minutes. But I want to get to 315 minutes. How do I do that? What I can actually then do is, and I'm going to just erase a little bit of space over here, and maybe move this over just a little bit. There we go. Thank you for dealing with that. We can actually take 315 minus 265, and that's going to give us 50 minutes. So if Krista wants to have an average of 45 minutes a week working out, she must work out 50 minutes the last day. All right, everybody, it is your turn to go practice these, to try these on your own. I know you got it. I know you can do this. And I cannot wait to work with you soon. Good luck. Hey y'all, Brian here at Nurse Hub. So wonderful to have you for another lesson. So what we're going to cover today is area and perimeter of circles. And just like the Black Eyed Peas would say, let's get it started. Hey everybody, welcome to area and perimeter of circles on the TEAS with me, Brian. So let's jump right in. One thing you might have noticed is that you see the word perimeter here. For those of you that do know circles, we are going to call it perimeter in the title because we will find out the official word for what we call it real soon. Our goal for this lesson is we are going to be able to find the area and perimeter, which we will refer to as the circumference of circles. All right, so first vocabulary word you're going to see is radius. This is the distance from the center point to the outside of the circle. So you see your circle here. Our radius is from the center to any point outside. The diameter is the distance from one point on a circle to another, but it has to go through the center point. If it doesn't go through the center point, it is not the diameter. Notice that this diameter goes through the center and touches 2 outside points, and it is a straight line. Circumference, that's going to be the distance around the outside of the circle. So notice those arrows are showing you that it is the distance around the outside of the circle. It's just another word for perimeter that we use when we talk about circles. When we talk about pi, a lot of people know that pi is equal to 3.14. That's great, but what we don't remember is why is it 3.14? What does that mean? Pi is actually the number of times that the diameter of any circle fits around the outside of the circle. I guarantee that if you went around your house right now, traced out a few circles, took a piece of string and went through from one end to the other and found the diameter and saw how many times the diameter went around that circle, no matter the size of any circle, the diameter will always fit around the outside of that circle 3.1415, whatever the rest of them are, every time. That's what pi stands for. Pi means how many times the diameter fits around the outside of any circle. So first key point, the diameter is equal to 2 radii. So what you'll see something is like 2r
equals d. So that just means 2 radii is equal to the diameter. You may also see the diameter, if it was divided by 2, is also equal to the radius. Do you need to memorize these formulas? No. But if you can remember that a radius is half of the diameter is twice as large as the radius, then it's easier for you to use these interchangeably. Key point number 2. If you were given a description and no picture, draw it out. So for example, find the area of a circle with a diameter of 10 centimeters. So we know that we're going to be drawing circles, so draw out your circle. It does not hurt you to draw out your circle, label the center point. Oh, my diameter is 10 centimeters. Great. Now I can find my area. Now I can continue working through. Use your drawing skills to help you figure it out. Again, remember, for any circle, the diameter fits around the outside of the circle 3.14 times. If we took the diameter, we made it into something that was a little bit more flexible, like a string, it would fit around 3.1415 continue on forever times. That's what that means. If you look this up on the internet, there's plenty of videos that show you exactly why this works and how it works. I highly suggest looking some of those up. For me personally, I didn't remember any of the formulas until I actually understood where the formulas came from, and then it clicked, and I've never forgotten them because I picture this every single time. Pi can be written as 3.14 or 22/7. This is going to help you in solving equations. Really just pay attention to what is there. If 22/7 is easier because you have fractional numbers in it, use 22/7. If it says use 3.14, use 3.14. Always check your answer choices. Some answer choices may leave the pi symbol in there. That means you don't have to multiply by 3.14. Just check your answer choices and see if it works. And if it is something like a fill in the blank question and there are no answer choices, pay attention to what it asks you to use. It may say use 3.14 or 22/7. If we're going to find the circumference, what we're really going to do is there's these two ones here that you could use. So pi d, which is pi, the number of times the diameter fits around the outside of the circle, times what the diameter actually is. So in this case, it would be 3.14, let's use that, times 12 would help us find the circumference, or 2 pi r, because if you notice, the pi is the same, and the diameter is actually equal to 2 radii. So in some problems, like you see here, you're actually only given a radius, so that means that you could do 2 times 6 times 3.14. Notice that in this case, it is 3.14 times 12, the exact same for both. All right, so you end up with the same answer, but depending on what you're given in the problem, you may have to find the radius or you may have to find the diameter. The area, so to find the area of the circle is actually pi r squared, which really means pi times r times r. There are some really amazing videos out there that show you why it's pi r squared. I don't have the ability to draw that out for you in this moment because it is really cool. It's something I used to do with my students when I taught. I have never forgotten pi r squared once I've seen why it works. So if you're very visual, I highly suggest going to YouTube, looking up why is the area of a circle pi r squared. Really cool videos. Why? Because circles themselves use different formulas and ideas to find the perimeter and area. It's important to understand the reasoning behind circle formulas to more accurately describe situations involving area and perimeter. Since circles are one of the most basic shapes, it is important to know how to use these formulas. It's also going to set you up for things like surface area, volume, all these different things that you have to do with circles. We are going to jump into our sample questions. Formulas may or may not be provided. I highly suggest trying to not use formulas for these, to actually try to get them from your brain and not use any of them already written down. See what you can do on your own and then check in. All right, sample question number 1, find the circumference, use 3.14 for pi. The first thing I think about, I know that when I do the circumference, I'm trying to find the outside of the circle. So I'm trying to find the outside. I know that I have to use pi, and pi stands for how many times the diameter fits around the outside of the circle. 1, 2, 3, and a little bit. So in this case, I know that what I'm going to do is I'm going to take 3.14 times 14, because our formula is pi d or 2 pi r. In this case, we were given diameter, so pi d is the better one to use here. If you wanted to double it, totally up to you. You end up doing it anyway. So 4 times 4 is 16. Drop the 6, carry the 1. 4 times 1 is 4, plus 1 is 5. 4 times 3 is 12. I'm going to cancel this out. Drop it, 0. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Add them together, 6, 9, 3, 4. 2 numbers after the decimal. 2 numbers after our decimal. So it is 43 and 96 hundredths centimeters. Easy peasy. The biggest challenge of this is making sure you know the formulas, can use the formulas, and you understand them. Question number 2. Find the circumference of a circle with a radius of 4.5 centimeters. Use 3.14 for pi. One of the things to use, if you like to label and see it, we can draw out our circle. It says that we're finding the circumference and the radius is 4.5. I know the radius is that shorter distance from the center to the outside, and I remember circumference is equal to pi d or 2 pi r. In this case, we have radius, so we're going to use 2 pi r. Another way to think about it is 2 times 4.5 times 3.14. So if we do 2 times 4.5, that's actually just going to give you 9 because it's twice as much. So I'm left with 3.14 times 9, and that's going to give me 9 times 4 is 36. Drop the 6, carry the 3. 9 times 1 is 9, plus 3 is 12. 9 times 3 is 27, plus 1 is 28. 2 numbers after the decimal, 2 numbers after the decimal. So your answer is 28.26 centimeters is going to be your circumference. Remember, perimeter does not have to be squared because that's not how we do perimeter or circumference. All right, sample question number 3. Find the perimeter. Use 3.14 for pi. I'm just going to move this shape over. We have a semicircle here. So the first thing that we're going to do is I notice that this part right here is half of the circumference. So that's going to be the first thing we have to find. But we still have one piece left because we still have the perimeter. So we still have to figure out this piece down here. And what is that piece? That's actually the diameter, right? Because that goes through the center to both sides. So if the radius is equal to 16 millimeters times 2, the diameter must be equal to 32 millimeters. So we know that the diameter is going to be 32 millimeters, and we have to make sure we add that on at the end because it is part of the outside of the shape for this semicircle. So we're going to look for half of circumference. We know circumference is equal to pi d or 2 pi r. We have both, but pi d is just one less step, so I'm just going to use that since we found diameter in step 1. So I'm going to use 3.14 times 32. So when we multiply 3.14 times 32, we get 2 times 4 is 8, 2 times 1 is 2, 2 times 3 is 6. We're going to add our placeholder 0. 3 times 4 is 12. Drop the 2, carry the 1. 3 times 1 is 3, plus 1 is 4. And 3 times 3 is 9. So when we add these together, we get 8, 4, that's 10. And we add it, we get 100, or 10048. There are 2 numbers after the decimal in your problem. So there's 2 numbers after the decimal in your answer. So this would be our circumference of the entire shape. So next, we're going to take our answer from before, 100.48 or 48 hundredths, and we are going to divide that by 2. Now, we're going to divide that by 2 because we want half of the circumference, not the full thing. So we do 2 goes into 1 0 times, 2 goes into 10 5 times, 2 times 5 is 10. Subtract, we get 0, bring down a 0. So that is also 0. 2 times 0 is 0. Subtract 0, bring down our 4. I'm going to remember this decimal point, so I'm going to bring it straight up. 4 divided by 2 is 2. 2 times 2 is 4. Subtract, we get 0. Bring down our 8. 8 divided by 2 is 4. 2 times 4 is 8. Subtract, and we are going to get 0. Now, that is for half the circumference. But what we cannot forget is adding this part below here, which is the diameter, since that also reaches the outside. So in a different color, what we're going to take is half of our circumference, 50 and 24 hundredths. We're going to add what our diameter is, which is 32. Add those together, we get 4,228, or 82 and 24 hundredths millimeters would be our perimeter. Sample question number 4. What is the area of a circle with a radius of 3.75 inches? Use 3.14 for pi. If it helps you, draw out your circle, see what you have. Center, we know our radius is 3.75. If I remember my formula to find the area of a circle is pi times r, or pi r squared. So my first step, I'm going to fill that in. That's 3.14. Let's make this a little bit cleaner for you. So I'm going to do 3.14 times 3.75 times 3.75. So let's work through part 1 of our multiplication. I'm going to do the squared part first. So 3.75 times 3.75. Okay, let's work through. 5 times 7 is 35, plus 2 is 37. 5 times 3 is 15, plus 2 is 18. I'm actually going to change colors this time because when it gets really long like this, I want to make sure I don't confuse myself. 7 times 5 is 35, drop the 5, carry the 3. 7 times 7 is 49, plus 3 is 52, drop the 2, carry the 5. 7 times 3 is 21, plus 5 is 26. All right, last row. Double zeros, cross these out. 3 times 5 is 15, drop the 5, carry the 1. Oh, sneaking up there. 3 times 7 is 21, plus 1 is 22, drop the 2, carry the 2. 3 times 3 is 9, plus 2 is 11. Whew, made it, and we're not even done yet. So that's 5, 12, 10, that's 16, 2, 4, 10, 4, 1, and 4 numbers after the decimal. So it's 14.0625, 2 numbers each here. Whew. And are we ready for what's next? My hand might not be, but I know we are. So we're going to multiply that, since we did these two here, times 3.14. So let's go through as best as we can. I'm going to give each row a different color. So 4 times 5 is 20. Drop the 0, carry the 2. 4 times 2 is 8, plus 2 is 10. Drop the 0, carry the 1. 4 times 6 is 24. Plus 1 is 25, carry the 2. 4 times 0 is 0, plus 2 is 2. 4 times 4 is 16, drop the 6, carry the 1. 4 times 1 is 4, plus 1 is 5. Whew, that was a long row. Cancel these out. So this row should be a little bit easier. 1 times 5, so placeholder 0. 1 times 5 is 5. 1 times 2 is 2. 6, 0, 4, 1. Much better row this time. So final row, 2 zeros for placeholders. 3 times 5 is 15, drop the 5, carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 6 is 18. Drop the 8, carry the 1. 3 times 0 is 0 plus 1 is 1. 3 times 4 is 12. Drop this 2, carry the 1. 3 times 1 is 3 plus 1 is 4. Whew. Add it together. That's 0, 5, 10, that's 12. 3, 9, 16. 14, 15. 9, 10, 11. 4. Whew. 4. We had, and this is fun. So let's get a different color that we haven't used. We have 1, 2, 3, 4 numbers after the decimal, 2 numbers after the decimal. So that means 6 numbers after the decimal. So 1, 2, 3, 4, 5, 6. Whew. So our final answer will be 44.15625. We're going to cancel out this last 0. It has no place value. Inches squared. Whew. Lots of multiplication. What is the area of a circle with the diameter of 14.5 meters? Use 3.14 for pi. All right, so if we look at the area of a circle, we have the diameter, but when we remember the area of a circle is going to be pi r squared. So we do need the radius. So what we do have to split is 14.5 divided by 2. So if we do that, that's going to give me 7. So we get 7.25. So what we just figured out is r equals 7.25. And I can hear that we're going to be doing a lot of multiplication in here as well. So now for this one, we are going to imagine as if you did have a calculator on the exam. We did the multiplication for the one before. So setting it up, just so that we're not watching all of the multiplication, we do have our 3.14 is for pi times 7.25 times 7.25. So I like to do just the r squared first. So we have 7.25 times 7.25, which is going to equal 52.5625. And we have 3.14 times that. So now we multiply it by 3.14. And we get 165.04625. And what is that? Meters squared. Now, if you needed to see the full out multiplication, go check what we did in the last problem, which has all of the multiplication there for you. All right, sample question number 6. What is the area of a semicircle with a diameter of 36 meters or centimeters? Use 3.14 for pi. So when we look at a semicircle, we notice that a semicircle is half of a circle. And we're looking for the area, so we're really only looking for 1/2 of the circle. But that means that we can find the whole circle and divide it by 2. We know that the diameter is 36. And when we find area equals pi r squared, if the diameter is equal to 36, our radius, if we divided that by 2, so d over 2 equals radius, so 36 divided by 2 equals 18. So in this case, our radius is 18, so pi r squared, but because it is a semicircle, we're going to divide it by 2. So if we filled it in, we have 3.14 times 18 times 18, and then we're going to divide that by 2. And I'm writing it this way just so that you can do the chain of thought. So let's work inside. If we're going to do order of operations, if that's how you want to do it, 3.14 times 18 is going to be 56.52 times 18 divided by 2. So when we multiply those together, we get 1017.52 0.36 or 36 hundredths, and we're going to divide that by 2. Which leaves us with 508.68 hundredths. You've seen the multiplication, you've seen the dividing by 2. You got this part of the numbers. It's making sure that you had to remember to divide by 2. One thing I forgot is to make sure that we put centimeters squared. Otherwise, it would be wrong because the problem dealt with area. All right, we've come to the end of finding the area and perimeter, which is also known as circumference of circles. It is your time to go to Nurse Hub, practice all of these problems the best that you can. And I can't wait to see you next time. You got this.
Hey everybody, Brian here at Nurse Hub. Can't wait to go over this lesson where today we're going to cover area and perimeter of basic shapes. Hey everybody, this is Brian here at Nurse Hub, coming to you with your next lesson, the area and perimeter of basic shapes. So let's jump right into what our goals are for today. Our goals, we will be able to find the area and perimeters of triangles, squares, rectangles, and other polygons. And we'll get into some of these definitions later as well. All right, key vocabulary number 1 is area. It's how much shape a space, or how much space a shape takes up. So one way that we always do area, that you'll see it as well, you'll see it in something that we call units squared. So that's going to be area. What that means is, for example, if the top was 3 and say the side was 4 units, it means that if this was perfectly set up and we had 3 units going down and 4 units going across, each of these boxes would be considered one square. They would be 1 by 1. Now I know this drawing is not perfectly to scale, but we get the idea that it would be a 1 by 1 square. That's why we call it units squared. Making sure that you have your units for area is going to be super important. Perimeter is the distance around the outside of the shape. So if we had, say, 4 inches up top, 3 inches on the side, 4 inches on the bottom, because it is a rectangle, so opposite sides are equal, we would look at the distance around the outside of the shape. So that would be 4 plus 3 plus another 4 plus another 3 would tell us our perimeter around the outside, which would be 14 units in this case. 3, if you hear the word regular, that means that all sides of the shape are equal. So if you see something called a regular pentagon, that means that all 5 sides of that pentagon are equal. If it does not say regular, we cannot assume that all sides are equal. So really make sure that we understand the meaning of that word. Polygon just means many-sided figure. So the word poly is going to mean many. So when you see that, it just means a many-sided figure. The most common ones that you are going to run into would be a pentagon, which is 5 sides, hexagon, 6 sides, octagon, 8 sides. This is one of those where knowing your prefixes is going to be important here. You could think of the pentagon, which is a 5-sided building here where I am, just right outside DC. And then octagon, I think of something like an octopus, right? 8 legs. Hexagon, not really something that I can easily think of something, but these are going to be the most common ones that you will come across. Key point number 1, if you come across a perimeter, you're just going to add up all sides of the shape. And this is going to be regardless of what the shape is. All perimeter, all the time, is the same formula. You add all of these up. So if we were going to take the perimeter of this shape, we see that we have 9 centimeters, 8 centimeters, 12 centimeters. If it helps you to go around the outside as you write numbers, that's 9, 8, 12 to make sure you've gone all the way across. That is something you can absolutely do as well. We can add these together. That gives us 29 centimeters. Notice the units are not squared because you didn't make any 1 by 1 squares. You just walked around the outside. You just tracked the distance around the outside. So our perimeter would just be 29
centimeters. How do we know it was centimeters? Because the units were right here. 2, still with perimeter, but if a shape is regular, like a square, all sides of the shape are equal. Now, notice how we do see up top that this does say 6 centimeters, and we also see this line. All of the sides have that same one line. That is shorthand for letting us know that all of these sides are 6 centimeters. So that if you are missing some notifications from there, some measurements, that you can assume that it is regular. So you look to the one measurement you do have. 3, draw out the shape if need be. There are a lot of times where it just might actually say, you have a square. And it gives you some directions. The best thing I can tell you to do is draw out that square or draw out whatever shape it tells you to. Keeping a lot of information in your head is going to be hard. So making a visual to keep track of the information is really important. Key point number 4 for perimeter. Remember, opposite sides of a rectangle are equal in length. So if we look here, we see that the top is 16 and it has one line. Directly across also only has one line. That is shorthand for letting you know that those two sides are equal. 16 centimeters. The same thing with 10 centimeters here. We see 2 lines. We match it to the other set of 2 lines. We get 10 centimeters. Now, if you remember, we were only given 16 centimeters and 10 centimeters to start. The number of times I have seen people just do 16 plus 10, which is 26, and say that that's the perimeter. That is not correct. Because you had only gone one side, 2 sides. You still have 2 more sides to go. So make sure that you include all the numbers of the outsides. You have 4 sides here that are on the outside. 4 numbers get added together. Best way to check. All right, again, make sure the amount of numbers you added matches the number of sides in the shape. I just started to mention that in the slide before. But again, it's because, like I said, people are going to stop and just see 2 numbers and add 2 numbers. That is honestly what you're going to see the most of, because they're checking to see, do you actually understand what perimeter is? And to understand it is to know that you can do 2 things. You can do 25 plus 15, which gives you 40, multiply it by 2 since you have 2 of each, which gives you 80, or you could have actually just written out 25 plus 15 plus 25 plus 15, still getting 80 centimeters for both. Let's make sure we never forget our units. Totally up to you. All right, so let's jump into the area. The rectangular formula, that just means length times width equals area. So you take the length of any of your shapes, you multiply it by the width, and that is going to give you the area. Real quick, again, I'm going to show you why this works. So the top has 6, so it's broken into 6 pieces. And the bottom part is going to be broken into 4. These actually are going to be better squares than the example I showed you before. So if you looked at all of these 1 by 1 squares, if we counted them up, that would be 1, 2, 3, 4, 5. Oh, you're going to hang out with me till I get these done. 11, 12, we're halfway there. 13, 14. I know you already know the answer, but I want you to understand why it is the answer. We have 24 of these squares in there, which was the same as 6 times 4, which gave us 24. Our units are feet squared. You might also see it as square feet, or you might see the word feet squared. All of these are going to be acceptable when you put in this answer. If you're going to have a square formula, that's side times side equals area, or side squared. This is the same thing as length times width. So if we actually took a square, let's make this square. There we go. All right, so if we take this square, we know that all sides of a square are going to be equal. So if this is 4 and this is 4, we know that our formula would be length times width, which is 4 times 4, which is equals 16. Why we say side is because since all four sides are the same, they don't really get called length and width. 4 times 4 can also be written as 4 squared. All squares are rectangles, so therefore it does still follow length times width, but know that most of the time you may see something where you are only given one side and asked to find the area. So the triangle formula, and if we look, I'm going to show you why we get to the formula that we do before it goes on. So any triangle is actually half of a rectangle. So if we were going to look for the rectangle here, we would actually do, length times width. So let's say 9 times 8 in this case equals 72. But this triangle is only 1/2 of that rectangle. So we have to split this area by 2, or into 2 parts, just to get the half that is the triangle. So if we did 72 divided by 2, this triangle is going to be 36 centimeters squared. Now, we've seen that since every triangle is half of a rectangle, we take our rectangle formula, but instead of using the word length, we're going to use the word base. So the base is the bottom of the shape, times, we're going to use the word height, which is this shape, and we can divide it by 2. So it's base times height divided by 2. If you want to think of it as length times width divided by 2, that's great too. Just remember the height of any triangle is the distance from the bottom to the top in a vertical line. When you look for height at the doctor, you do not slant. You stand as straight up as you can, because some of us want to be taller than we actually are. We do not lean over. So you have to go from the base to the highest point of the triangle that is a vertical straight line. Now, one thing, let me erase a few of this real quick. I want you to know that you can do this a few ways. Now, you could do 9 times 8 divided by 2, which is 72 divided by 2, which we know equals 36. Another way to do this is, they also call it 1/2 times base times height. So same idea as dividing by 2. You could actually multiply 1/2 times the base, or you could do 1/2, I'm sure you guessed it, times the height instead. So if we did this, we could do 1/2 times 8 times 9. So 1/2 of 8 is 4 times 9 equals 36. Or we could have done 1/2 times the height, which is 9, times 8. Not so fun, but that's 4.5 times 8, which is also 36. 3 different ways to do the same thing, whichever's easier for you. But those of you that have seen some of my videos so far, I like to stick with smaller numbers first. So if it's easier to do half of 8 than do 72 divided by 2, that's the way I'm going to personally go. But you have all the options. A reminder, again, I talked about this before, but I want you to see what happens. If the height is the straight line vertical distance from the base to the highest point of the triangle. So I want us to first look at the base. So I'm going to put the bases in orange. So let me highlight the bases now of each triangle. So the base is right here. The base is here. The base is right here. Next, we're going to look at the highest point of every triangle. So if we look at the highest point, that's what I'm going to show you now. That's here. That's here. That's here. So the final thing that I'm going to show you is what the height is going to look like. Now, I'm going to show you the 2 easier ones first. This is our height with an H. This goes from the base directly to the top. So right here would be our height. I put a dotted line because that dotted line does not exist in the triangle, but that is our height. Now this one, I'm going to show you 2 things have to happen. You see that if I came straight down, I'm not going to hit anything. Well, in this case, we would actually extend the line of the base, the imaginary line, so that this would still be our height outside. So if you see a triangle that looks like this, then it is, which is most likely always going to happen when you have an obtuse triangle, which means that this angle is larger than 90, you're going to run into this shape. Just look for the height. Remember, it's not the slanted lines. It has to be a vertical line from the bottom to the top. The units are squared for all problems. So I've showed you this before. I've shown you 2 times at this point why it is squared. Let's just go over it once more. If we broke the top down into 5 pieces and we broke the bottom down into 3 pieces, we get better at this every time. We'd have 1 by 1 squares. How many squares would we have? You could guess 5 times 3 equals 15. Important to note, what are your units? In this case, it is inches. So we could write out inches squared, since now we have squares.
All right, so why do we need to know this? From floor space, rugs, buildings, fencing, and distance, everything takes up space, even smaller objects that may be used to help patients. It is helpful to know how to find the area, perimeter, and different situational impacts these have on real-world problems.
You know what's next? We are going to quickly model our triangle again. Why do we model this? Because if you can remember where we get these from, you are more likely to remember what the formulas are. If you stick to just straight memorization, as someone who's taught for 12 years, if you stick to straight memorization, it does not last a long time. If you stick to understanding why that formula is the way that it is, then you can remember long term. So we look at, I know a triangle is, if I added the same triangle, I could make a rectangle. So I'm going to put in the dotted line to show my rectangle. I know opposite sides of rectangles are equivalent. And I remember that I have length times width equals area. So I'm going to do 15 times 10. Now, I know this is going to give me 150. If I looked at 15 times 1, that's 15, and I bring my 0 straight down. So right now, I have 150 centimeters squared. But that's for the whole rectangle. But we're not looking for the whole rectangle. Remember, we're looking for only this part, which is half. So I'm looking for 150 divided by 2. Now, you could do long division if you need to. There are some multiplication or division problems you are going to know immediately. So 150 divided by 2 is 75. We look for our units, which are centimeters and squared. That's why our formula, if you remember, is going to be base times height divided by 2, or if you like to think about it as 1/2 base times height. This is what you could be using. If you are creating formula flashcards, this would be a great one to write down. Up to you. We showed you the square units. I can show you these again. Why do I show you this so many times? Because I want you to stop remembering formulas and understanding where they come from. So you look, you have 6 meters times 4 meters. We know that we have a 6 by 4, which will give us 24 meters squared. Also knowing abbreviations that M is for meters can also help later on instead of having to write out full words. It is time for those sample questions. So as always, when we get to them, you may hit pause, go over them, see what you're able to do on your own, then come back and see if your answer is correct. Sample question number 1. What is the perimeter and area of a rectangle with a length of 14 inches and a width of 8 inches? I notice that this problem does not give me a picture. So the first thing I'm going to do, because I'm dealing with a rectangle and I'm looking for perimeter and area, is that I'm going to draw out this rectangle. Rectangles do not have to be perfect. They do not have to be drawn to scale. And honestly, if you're drawing your own, it does not matter if you put 14 here or you put 14 here. as long as the opposite sides are equal and you've included both sets of numbers. So we have 14 and a width of 8. So just for me, I'm going to put 14 and 8 over here. Why? Because if I'm dealing with perimeter, sometimes it helps to label all 4 sides. So let's deal with the perimeter first. I know the perimeter is the walk around the outside, so if I started at 14, so that's 14 plus 8 plus 14 plus 8. If you want to do 14 times 2 plus 8 times 2, by all means, be my guest. Everyone does this a little bit differently if you have tricks that work for you, as long as the answer is the same. So 8 plus 4 is 12, plus 8 is 20, plus 4 is 24, so drop the 4, carry the 2. That is going to give me 2 plus 1 is 4. And remembering our units, as you can see, I forgot to put in, but luckily we double checked. Our perimeter is going to be 44 inches. Not squared because we did not make a square. We have area. I'm remembering to picture that if I did this, I would have 14 lines going down. Don't count these. That's probably not 14. And then 8 going across. So that reminds me that I'm going to do 14 times 8. 8 times 4 is 32. Drop the 2, carry the 3. 8 times 1 is 8, plus 3 is 11. So I have 112. What are my units? Inches. And because I made all those beautiful tiny squares, inches squared. Notice that this might have been more difficult had I not drawn a picture, but we didn't hurt anything by drawing one. If anything, we did help ourselves. Sample question number 2. Which of the following best describes the perimeter and area of the square above? So I'm not even going to look at the answer choices just yet. What I'm going to do is I'm going to notice what is up there, what shape I have, what it means. So I notice in this case, I do have a square. What does that mean? Well, that means that all 4 sides are equal. So if this side's 6, all 4 sides are going to be equal. So that's 6, 6, 6. So I'm looking for the perimeter again. So let's keep the perimeter over here. And I know that that perimeter is going to be 1 6, 2 6s, 3 6s, 4 6s, which also works as 4 times 6. You could have added 6 plus 6 plus 6 plus 6, same thing as 6 plus 4. So I know my perimeter is going to be 24, what are these, centimeters. Okay, I notice it does have all centimeters. The perimeter is 24 centimeters. C and D both say the perimeter is 24. So I'm going to knock out A and B. Those are not going to be for us. Next, let's look at the area. I know that area is going to be length times width for a shape like this, because again, I'm picturing the drawings, 6 boxes going down, 6 across. That's going to give me 6 times 6, which is going to be 36. Again, we have centimeters squared. So the correct answer is going to be D. One good thing to notice is why someone might have gotten this wrong. So if they chose C, they accidentally did 6 plus 6, which is not the same as 6 times 6. So we keep our answer as D. Sample question number 3. What is the area of a triangle with a base of 15 inches and a height of 8 inches? Now, notice it didn't give us a specific triangle to work with. That's fine. So we're going to go with the easiest triangle. I'm going to think of a right triangle. So that means my straight line down here, my diagonal, and then my base. So I'm looking for the area of a triangle. Great, we got a triangle. The base is 15 inches. Got it. And a height of 8 inches. So 2 things to think about. Is the height here or is the height here? Think about it. Is it A or is it B? Well, remember, our height is going from the lowest point to the highest point in a vertical straight line. So we actually have our height right here. So A is going to be our correct answer for the height. We know that it is inches, so I'm going to quickly just put in inches. Now, when I picture this, instead of memorizing a formula, I remember triangles are half of rectangles. So I can look at 1/2 times 8 times 15. You could have also done 15 times 8 divided by 2. But here, as you get to know, I like smaller numbers. If I think, what's easier to find, half of 8 or half of 15, I'm going to do half of 8. So 1/2 times 8 is 4 times 15. 4 times 15, if you want to see it. 4 times 5 is 20. 4 times 1 is 4, plus 2 is 6. So we get 60. Our units are inches. And since it's area, it is squared. Just to check, this question only asked for area. It did not ask for perimeter. So we don't have to find anything else. Sample question number 4. If the area of a rectangle is 84 inches squared and the width is 7 inches, what is the length of the rectangle? All right, so I'm just going to draw a rectangle first, and here's why we do this. Because this question had a lot of information, let's figure out where to put everything. So I know the area of the rectangle is 84 inches. So I'm going to put that inside, that the whole thing is 84 inches squared. If it helps you to see that this is what that means, great. And let's just box this so we can see it. So we have 84 inches squared. Great. The width is 7 inches. Generally, the width is smaller than the length, so I'm going to put 7 inches here. Which means we're looking for our length. One thing to think about from here, some of us may have figured it out, but if we're not sure, we think about the formula. I know that length times width equals area. So if I can fill in what I have, my length, I'm going to put as x, I don't know it, times my width, which is 7, is equal to my area, which is 84. How do I then solve for x? Well, if x is being multiplied by 7, the only thing to do is to divide both sides by 7 to find the missing x value. You could use long division for this, but we're going to jump down to x is equal to 12. 12 what? 12 inches. I guarantee there might be an answer choice that would say 12 centimeters. Just to see if you're paying attention, doesn't make sense to get a question wrong because you didn't pay attention to the units at the end. Sample question number 5. A farmer is building a hexagonal fence around a field on his farm. If each side of the hexagon is 425 feet long, and each foot of fencing costs $2.50, how much will he spend to fully enclose this field? All right, so a few things. I know that I have a hexagonal fence, and that word is so much fun to say. So I look at hexagon, that tells me that it's 6 sides. So that's 1, 2, 3, 4, 5, 6. Ooh. All right, so thank you for going with that drawing because we're just going to say that that's great for this one. So we have our hexagonal fence. Great. Each side of the hexagon, so we see each side is 425 feet. That's just a good indicator to let me know that all of these sides are equal. So remember, that makes this a regular hexagon. Do we need to know that for now? Probably not, but good thing to notice. So each side is 425. Good. And we know per foot, it is $2.50. And we are looking for the total cost. We're looking for how much will he spend to fully enclose the field. So we have to figure out, is this perimeter or is this going to be area? And it can't just be by looking at the shape, because later on you will have shapes that look like this and you'll be able to still solve for area. If we look, it says fencing. And when you think about fencing, does fencing go around the outside of a property? Or does fencing take up everything inside a property? Well, last time I checked, the fencing goes on the outside. So this is going to be a problem that involves perimeter. So our first step is going to be to find the perimeter of this shape. Now, shortcut is that I have 425 6 times. So I'm just going to do 425 times 6. 6 times 5 is 30. 6 times 2 is 12, plus 3 is 15. 6 times 4 is 24, plus 1 is 25. So this is 2,550, and this is going to be, just like all of these say, it's 2,550 feet. Are we done with the question? No, because it said, how much will he spend? So if we have 2,550 feet at $2.50 a piece, we can do that multiplication. So 2,550 times $2.50. Remember, we do not have to line up decimals to solve. Our first row is just going to be zeros. Always a great start. Placeholder 0. 5 times 0 is 0. 5 times 5 is 25. Drop the 5, carry the 2. Same thing. 25 plus 2 is 27. 5 times 2 is 10, plus 2 is 12. I'm going to cross these out. We use them. Now I go to the 2, so it is 2 placeholder zeros. 2 times 0 is 0. 2 times 5 is 10. Drop the 0, carry the 1. 2 times 5 is 10, plus 1 is 11. Drop the 1, carry the 1. 2 times 2 is 4, plus 1 is 5. So we're going to add these together. That is 0, 0, 5, 7, 3, 6. We notice that there are 2 numbers after the decimal in the problem, so we go 1, 2. So our total cost is $6,375. Knowing what unit your problem is in are going to help you figure out what you just found. All right, sample question number 6. Shay is painting each wall of her square bedroom. If the walls are 9.5 feet high and 14 feet long, what is the total area she has to paint? If a paint can cover 200 feet squared, how many cans of paint will Shay have to buy? Now, let's look at first sentence. I know that she is painting each wall of her square bedroom. So at first, I'm going to picture her square bedroom. So this is her square bedroom. Now, one thing I want us to note is that this is the floor that we're looking at. Right, when you look at, if you've ever seen like a floor plan for a house or an apartment, it always has the floor is drawn. So you don't see the walls, but you would see the floor. Now, we know that the walls are 9.5 feet high and 14 feet long. That does not show up here, right? This is the floor. So I'm going to have to take another one. And I'm going to say this is the wall. And what do we know about the wall? The wall is 9.5 feet high. And it is 14 feet long. So we know that one wall is 14 feet by 9.5 feet. And we want to know that if she's going to paint all 4 walls like this, notice it says nothing about a door, so we're going to not even pay attention to that. It doesn't bring it in, nothing to worry about there. It says all 4 walls have the same. Now, how do we know that they're all the same? Because it is a square bedroom. So all 4 walls are going to be the same. So I need to find the area of this whole wall, which is 14 times 9.5. So let's do that math first. 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7. Placeholder 0. 9 times 4 is 36. 9 times 1 is 9, plus 3 is 12. So I'm going to add these together. 0, 13, 3, 1. One number after the decimal here, so it's going to be 133. So one quick note. One wall. One of them is 133 feet squared. How many walls are going to be in her square bedroom? That's right, we have 4 of them. So we have 133 times 4. 4 times 3 is 12. Same thing, 12 plus 1 is 13. 4 times 1 is 4, plus 1 is 5. 532 feet squared. What do we have to do? Label it. What is this? This is for all 4 walls. What is it? The area of all 4 walls. So we had the walls, and we found the total area that she has to paint. So she has to paint 532 feet squared of wall. We're not done yet. There's 2 parts to this question. So let's look at part 2. If a paint can cover 200 feet squared, how many cans of paint will Shay have to buy? So if we look, a few ways to do this. You could do 500. No, not 500. 532, excuse me. 532 divided by 200. We could. If we look at that, that's 0, 0. That is 2. That means we have 2 cans, not the bird, but 2 cans of paint, but we would need 132 square feet left to paint. So she does have to buy another bucket of paint to make sure that there is nothing left over. So she needs 3 cans of paint. This question did have multiple parts. We just had to make sure we took time to work through them. All right, it is your turn to go practice area and perimeter of basic shapes. So go forth, see if you can not memorize the formulas, but use pictures to help you remember how to find the area. That, again, is going to be something that helps you with long-term remembrance, long-term memory, and will help you out when you take your test. All right, can't wait to see y'all soon. Good luck. Hey everybody, Brian here. So wonderful to have you. Today we're going to cover the area and perimeter of irregular shapes. You ready? Hey everybody, it's Brian here with area and perimeter of irregular shapes on the TEAS math course with me. So let's jump right into what our goals are for this lesson. Our goals, we will be able to find the area and perimeter of irregular shapes. We are going to get into what the idea of irregular shapes are in just a second. All right, told you. So here we have number 1, which is irregular shapes. These are shapes that do not look like the shapes we know how to easily find the area of. So irregular shapes, you can see that it is a mixture of different shapes. We don't know how to find the area of the shape specifically, as it is not a square, a rectangle, a triangle, or a circle at this point. So we are just going to call this irregular. That's how it got its name. Remember that area is how much space an object takes up, something like carpeting, so that if we were going to find the inside of this shape, we would be doing 6 times 4 gives us 24, in this case, meters squared. Perimeter, that is the distance around the outside of the shape. So we generally think fencing. So remember that we are going from one end all the way to the other. So that's 6, 4, another 6, and another 4. So if we added these together, it would be 20 meters would be the perimeter of this shape. Making sure you do not make the mistake of adding just 6 and 4 together. It would be twice as much. 4 sides, we add 4 numbers together. Key points for area. So number 1, and this is going to be very important, this is how we tackle these irregular shapes. We are going to break down the irregular shapes into smaller, recognizable shapes. So that is squares, rectangles, triangles, semicircles, circles, things that we know how to find. There may be multiple options, and that is okay. But if you choose your option, B is really important. However you break down a shape, make sure that you can easily find the length and width, or the base or height, depending on whatever you broke it down to, easily. If you cannot find it easily, then try to break down your shape in another way. Usually there are more than one option. So, for example, if we looked here, we have a shape that we can see is absolutely created by rectangles put together, right? Could be squares, we'll see, depending on how we break things down. You get the option to figure out how you would like to break these down. So if I was going to break some of these down, let's look. So we could go either horizontally or vertically for us to figure out which way it's going to work. Now, it's up to you which way you want to do it, but again, it has to be something that you can find easily. So, what if we did a cross, right? So I'm going to go across here. Now, you could have done two different ones if you wanted to, but I would suggest not creating too many extra. So create as many smaller shapes. Don't create the least amount of extra shapes that you can. Right now, 3 rectangles seemed like it was the most appropriate for this. We could not have done it in 2, so let's go with it. One thing I want to check. For area, we know that it is length times width. Here's how I check to see if this helps me. So here, I know that this would be 4 times 7, because 7 goes from here to here, right? It's that width. And 4 goes from here to here. So that's 4 times 7. We're going to get rid of that. Here, we know that our width of this one is 6, and that is 6 by, here's where we're going to make the biggest mistake. So 6 times, or actually let me do that in white. That's a little bit easier to see. 6 times, if 10 is actually the whole thing. 10 was not just the piece that we wanted. That's what's really important to remember. So you have to think, is there anything else in this shape that gives me a clue as to what this length could be? What I notice is right here. This from here to here is 7, which then means that from here to here is also going to be 7. So I have 6 times 7. That's going to be this triangle, this rectangle over here. Now, we have to look at the one on the bottom. It doesn't have any numbers other than 9. But one really important thing to remember is that 9 is only from here to here. We're forgetting this part, and we need this over here. So I know here is 9. I notice that this must also be 6 here, because opposite sides of rectangles are the same size, right? They're even. And same here would be 4. So if I did 4 plus 6 plus 9, that's going to give me a length of 19. Now I'm just missing from here to here. So I know if the whole thing from top to bottom was 10, and from here to here was 7, because that's the orange line there, then what's left from here to here must be 10 minus 7, which is 3. So this width must be 3. So in here would be 19 times 3. So notice I was able to find the length and widths of all of these shapes in here to help us find the pieces. We may have done pieces differently. Again, that is okay. But what's most important is that we could figure out each of these. The most important part, again, is also making sure that you could find your lengths and your widths. So, again, if I showed you over here, we could have separated it going up and down. So let's look at this one. I know that here to here is 10, so here to here must also be 10. And that's one good thing to know. So I know that this first shape is going to be 10 is our length times 4. That works for me. Now over here, I see that my width is 6 for the whole shape. And my length is 10 for the whole shape here. So I know in here will be 10 times 6, which leaves us to just this rectangle in the middle, or just about the middle. I know that from here to here is 9, so our length would be 9. And I'm looking for this little piece. Let's see what color is going to work here. This little piece right here. So if I'm looking for here to here, and I know from the top to where we started is 7, that must mean if the whole thing is 10 and this piece is 7, this must be 3. So to find the area of this inside would be 9 times 3. Notice this one was a little bit easier than what I showed you on the last one. That's what I said. You can change how you decide to draw, but that might change the difficulty of what you've given yourself. So it may be a good idea to take a second, see what information you have before you decide how you're going to cut these shapes. You see that if we did this, 4 times 10 was 40 inches squared, 9 times 3 was 27 inches squared, then we had 60 inches squared. There, we would just add up the areas of the shape, so that's 60, 40, 27, that's 7, that gives me 127 inches squared. So now we could find the area of the entire shape. Key points, make sure that you've used the correct units and added the correct numbers together. Make sure that your units are squared and make sure that you've used the right numbers. I guarantee so many times you might accidentally do subtraction wrong real quick. You might have said 10 minus 7 was 4. Just double check to make sure you use the right numbers. Perimeter, you're just going to fill in any missing side lengths on the outside of the shape. So I'm just going to move this up just a little bit here now that we're done with it. One thing is to always pay attention to the overall lengths of something. So what I mean by that is, what is the length from top to bottom? Can we figure that out? And what is the length going across? So finding missing pieces that you know are going to be helpful. So for example, if we're first going to focus on the width, I know from here to here is going to be 3 because that matches with what's across. I've also noticed that from here to here matches across with the 9. So that must mean I get 12 centimeters is going to be my overall height of this whole thing, or the length of this side. I also noticed that if the entire thing up top is 18, so if the whole thing is 18, and that I know from here to here is 6, like in this picture, this must be 12, this missing piece, which is right here. So that gives me 12 centimeters. So now I look, if I went around the outside of my shape, which I'll show you real quick in black, okay, that's 6. This whole thing is 12, 18, 9, 12, 3. By just walking around real quick, I was able to see that I did have all of my sides filled in. So this way I could add them all up to get the perimeter. You see that we found these here, so we could quickly add these up. I do like to just go through, so for example, that's 12, 3, 6, 12, 18, 9. I just am visually showing you how my eye is going around the whole outside just to make sure I had all my numbers. I also know that there's 1, 2, 3, 4, 5, 6 sides, and I have 6 numbers. So 2 plus 3 is 5, plus 6 is 11, plus 2 is 13, plus 8 is 21, plus 9 is 30. So drop the 0, carry the 3, 3, 4, 5. We have 50 centimeters is going to be, just kidding, not 50. We have our, so again, that was 30. 3, 4, 5, 6. So 60 centimeters. Whew. That was going to be not great if we got it wrong, especially with basic addition right there. All right. Let's get into number 3. Make sure you've included all the numbers. If there are 8 sides, make sure you added 8 numbers. I know you've heard me talk about this a lot. It's because the biggest mistake is missing a number, that you see a blank side and you just forget to include it, or that you forgot to find how much it was and add it in. Doesn't make sense to know how to find perimeter and then make a mistake that way. Why? Again, from floor spaces, rugs, buildings, field, fencing, and distance, everything is going to take up space, even smaller objects that may be used to help patients. Unfortunately, not all shapes work out perfectly or are those regular shapes, so it is helpful to know how to find the area, the perimeter, and different situational impacts that these have on real-world problems. All right, 2 ways that we can do this. I'm going to show you something a little interesting. So let's take first way 1. We could do something like this right here, right? So inside we see, and I'm going to show you this in yellow, we see our width is 8. Our length is 11, so that would be 8 times 11 for here. I notice my width is 5, but I'm stuck on what my length is. Notice that 20 goes from here to here, but I only want from here to here, right? That's what's part of this shape right here. So if from here to here is 20, there must be something else here. Oh, I notice 8. So from these 2 points is 8, the rest totaling 20. This must be 12 inches. So 12 inches, so 5 times 12. Why did I put that down there? There we go, much better. 5 times 12. Notice I have length and widths for both, so I could solve it. But that's not the point that I'm going to show you in this point right here. A second way that if we were going to go across, so let me show you, we have this 11 here, won't let me move it just yet, but if I was to go like this instead, if I cut it across. If I looked, I have 8 times, and I'm looking for what this is right here. I know the whole thing is 11. I also notice from here to here is 5. So that must mean this missing piece from here to here is 6. Okay, so this is 6. So up top is going to be 8 times 6. Down here, I have my width of 20, which is the whole shape. My length of 20 and my width of 5. All right, so I have both of these. Notice, let's see if we get the same answer. So I have 8 times 11 is 88 over here. 5 times 12 is 60, and let's add that up. So 88 plus 60, that's 8, that's 14. We get 148 inches squared. We know this is 48. 20 times 5 is 100. 100 plus 48, 841 inches squared. And oh my gosh, would you look at that? 148 inches squared is equal to 148 inches squared. Both of these methods are going to work, so use one that works for you. We're going to jump into some sample questions. If you do need a refresher to remember the area and perimeter formulas for different shapes, please go back and look at those before you jump into these. Formulas may or may not be included in these sample questions. Try them out on your own. See if you're able to get them before we continue on. All right, we're going to look, what is the area of this shape? So again, we're going to focus on area. So we're thinking of area formulas, and we have to think, what shapes do we have here? All right, so if we're going to take a look at our shapes, here's what we start to notice. All right, so I see if I draw a line here, I have a semicircle, and I have what shape is here? Okay, I see this is 6, and I see this is 6. So this is a square. So let's break down our shapes into two pieces since we're finding the area. So if we look at the square, that's just going to be simple length times width. So that's 6 times 6 equals 36 meters squared. Now I have my semicircle, which is really just half of a circle. So we're going to look at what is a circle. So we're going to take circle, and we know that the area of a circle, from picturing it from our circle lesson, is pi r squared. That's the area. But what is our radius? I don't even have a diameter for this circle. Oh, wait. If I look, if down here is 6, here is 6. So I know that the diameter is equal to 6, which means the radius is half of that, which is 3. So I know my radius is 3, so I have pi times 3 times 3, because this right here is r squared. So 3 times 3 is 9, so I have 9 pi. And say in this case we had to use 3.14 for pi. I know it didn't tell us. Most of the time it will. Check your answer choices. So let's do 3.14 times 9. 9 times 4 is 36. That's 9 plus 3 is 12. 27, 28. We had two numbers after the decimal in the whole problem. So our decimal point is here. We have 28.26, or 28 and 26 hundredths, plus 36, because this is our semicircle, and 36 is our rectangle. Add them together. You get 64 and 26 hundredths meters squared for the area. There was only one way to split this shape up. That was the best way to do it. Otherwise, you would have ended up with a quarter of a circle on both ends. It just would have been way too confusing. So, all right, we are going to look at sample question number 2. What is the area and perimeter of the shape below? I'm just going to slide this over just a little bit so we do have a little bit more space for us to solve a few things. All right, we're looking for area and perimeter. I do notice that we have some missing sides, so we're going to focus on perimeter first. Perimeter is going to force you to find those missing sides, which actually is going to help us find the area a lot easier later on. So if we label our two sides that we are missing, that is this side here, and we have B over here. So A and B. If I look in this shape, I can make the assumption that this side is going to be 12 centimeters. You'll be able to see it a little bit easier on paper, but they do line up. They are the same length. If you put a ruler and checked, they would have the same side length, meaning if you looked across, they would both meet in the same spot. So that's how we're going to use 12 there. You can tell when they are definitely different. So we have our missing side B is 12. Now we look at, can we find missing side A? All right. So we notice that the whole thing is 12, and we're going to use clues or hints that go the same direction. So I know from here to here is 4, and you may not be able to see the best. That's why I'm going to give you these lines. Also here to here is also 4. Let's put that here so it's not as confusing. And we're looking for what's in the middle. So together, 4 and 4 is 8. So 8 out of the 20 we figured out. So A must actually be equal to 12 centimeters, because 20 minus 4 is 16, minus 4 again is 12. Now I have all my sides of my shape, so I'm going to add them up together. So let's keep track. That's 12 plus 4 plus 6 plus 12 plus 6 plus 4 plus 12 plus 20. Now you can see why I showed you to go around, just because it was a little bit easier for us. So here's one thing I'm going to do. 8 numbers is actually a lot to add. So what I'm going to do is I'm going to move these 4 numbers to different parts. So 6, 4, 12, and 20, and I'll show you why. Some of us get a little flustered when there's a lot of numbers. Totally fine, especially when it feels like it's a stressful environment. So let's split them up into two groups. So 6 plus 4 is 10, plus 2 plus 2 is 4, which would be 14. So this part's 34, that's 10, that's 12, 42. And if we did 42 plus 34 for the two parts, that's 76. So our perimeter is equal to, let's keep it up here, 76 centimeters. Now we're going to look at our area. Is 76 centimeters. So if we update with what we know, so one thing that's missing was that this was 6 centimeters, this was 6 centimeters. That's from the other problem that was already labeled 12 centimeters, and we know this is also 12 centimeters. So from here, we can start to figure out how do we want to draw our lines. So the first thing I'm going to do is I'm going to imagine if I drew all my lines going this direction and see if it's fairly easy. Okay, this would be 12 times 4 because this box is right here. This one would also be 12 times 4. So that's fairly easy. Now we're just stuck finding the inside box. So we know that the length is 12 because it tells us above that it is 12. So we're missing our width. Where is our width? Well, it's going to be this purple line right here that you see me shading in a lot. So let's use our context clues. We know from the top to the bottom is 12. So we look for any numbers that are going to help us. One I've noticed is that from here to here, we have 6. So if the whole thing's 12 and I have here to here is 6 centimeters, that means the missing part must also be 6 centimeters. So this right here must also be 6. So this middle box is 12 times 6. So 12 times 4, we have, that is 48. 12 times 4 over here is also 48. And our box up here is lovely going to be 72 centimeters squared. So what's left, as I put these in, centimeters squared, is just to add them together. So we have 48 centimeters squared, 48 centimeters squared, and 72 centimeters squared. So 2 plus 8 is 10, plus 8 is 18. That's 8. 4 plus 4 is 8, plus 1 is 9, plus 7 is 16. So we have 168 centimeters squared. So our answer to sample question 2 is we have our, and our area is 168 centimeters squared. Sample question 3, what is the area of this shape? Notice we've just done area. So let's get creative. How do we want to split these up? All right, so let's say I'm going to go down here again. So I'm going to look at the yellow shape that I just created. And that is going to give me 16 times 16. Easy peasy. Great. All right, let's look at another shape. So if we can cut it across, either way, it is up to you. Let's see. I'm going to cut it up and down to create this green box here. Why? Because it is easier. The length of the whole thing is 38. The width is 7, so I can do 38 times 7. Which leaves us to find our final box, which is this pink box right here, or whatever this color is that you would like to call it. Now, we know that it's not 50, because 50 is the whole thing, and it's not 8, just because 8 is right there. Doesn't necessarily mean it is going to work for us. So let's look at a few context clues first. So let's look at, if we know the whole thing is 50, let's look at some pieces that we know. Well, I can see in green that from here to right here is 7. And if I use the yellow, from here to here is 16. And just excuse that this is not drawn to scale, so we know that there's a good amount missing in the middle. It's fine that the length is a little bit different. Don't even worry about it. Go with the numbers that you see. A lot of times the shapes that you're going to see are not actually drawn to scale either. So don't let that trip you up. Don't guess when you can actually find out. Which means we're looking for what's right here. So 50 minus 16 minus 7. 50 minus 16 is going to be 34. Minus 7 is going to be 27. So this must be 27. And now we're going to look for the other side. Remember, we are looking for what is right here. We know the whole thing is 38. Is there anything that helps? Well, I see, and maybe you noticed it too, that this part of the wall, or this line, is 30 meters. So that actually matches perfectly to what's left out of 38. So this is 30 meters, which means that this has to be 8 meters. So this has to be 27 by 8. We were able to find the area, we were able to find the length and the width for all of these shapes. So let's do the math for these. All right. So we have 7 times 8 is 56. Drop the 6, carry the 5. 7 times 3 is 21, plus 5 is 26. So here we have 266 centimeters squared. 16 times 16, 36. That's 1. That's plus 3 is 9. Drop the 0. That's 6. That's 1. Add them together. So we have 256 centimeters squared. And then we're going to do 27 times 8. Let's just take it to the side. 27 times 8. That is 56, 216 centimeters squared. So to find our final answer, we must take all three. So we have 266, 256, and 216. We add those three together. So 6 3 times, that's 18. That's 7, plus 5 is 12, plus 1 is 13. 2 plus 2 plus 2 plus 1 is 7. So we have 738 meters squared. All right, last two sample questions. We do have, what is the area of this shape? So let's go into what we see. All right, again, think about how are you going to cut this shape? Are you going to cut it this direction, or are you going to cut them across? Up to you, but take a second to think about where you would cut it. All right, so what I'm going to do first is I'm actually going to cut this shape like this here. Why? Because I know that my length is 2.5 and my width is 0.5. So that is going to be an easy one to find. Great. If I look, I'm either going to cut down this direction or I can cut across. Doesn't matter. So actually, let's keep this one cut across this way. Why? Because we already have our dimensions done. We actually have 1.5 times 3. Right? So we have 1.5 as our width. 3 is our length. Great. Which means, again, we have to find our purple box. Now, notice two things. We don't actually have any of our dimensions. Why? Because 6.5 is for this whole thing, and we are just going to try to find what is worth the purple. So, we know that the whole thing is 6.5. From here to here, we use our context clues. Above is 1.5 meters. So if we're looking for the purple, that must be 6.5 minus 1.5, which leads us to 5. So we have our width is 5, so that's going to be 5 meters going across, and now we have to look at our opposite side. So let's look at how do we find our missing width. So how do we find this piece right here? Well, if we look across, we know the whole thing was told to us as 3. We also saw that this yellow piece was 0.5. So if we subtracted, this must mean that this purple piece is 2.5. How? Because if you did 3.0 minus 0.5, you would have gotten the answer of 2.5. So we know that this is actually, and let me put this in, 2.5 times 5. So we have our 3. So now that we have our 3 dimensions, we can actually solve our problems. So let's start with some easy ones. So 3 times 5 is 15. Drop the 5, carry the 1. 3 times 1 is 3, plus 1 is 4. 1 number after the decimal, 1 number after the decimal. So we know that one of our answers pieces is going to be 4.5. And I'm going to put the meters over here. Okay, let's do our purple box. So 5 times 5 is 25. Drop the 5, carry the 2. 5 times 2 is 10, plus 2 is 12. Again, 1 number after the decimal, 1 number after the decimal. So we have 12.5. Remembering to make sure I line up my decimal points because I am going to be adding at the end. 5 times 5 is 25. Drop the 5, carry the 2. 5 times 2 is 10, plus 2 is 12. So very similar, but if we look, they are 2 numbers after the decimal, 2 numbers after the decimal, so it's 1.25. And I'm going to add these together. I'm going to put in some placeholder zeros when I add. So that's 5, that's 10, plus 2 is 12. Drop the 2, carry the 1, bring down my decimal point. 4 plus 2 is 6, plus 1 is 7, plus another 1 is 8. Nothing to carry over, so we bring down the 1. So our answer is 18.25 meters squared. Notice we did have to use all of those pieces. Once you have that, your tools are going to be wonderful. Sample question number 5. What is the area of this shape? Let's again go with it. So I'm just going to move a few things around for us to make it a little bit easier to break things down. If you notice, we've gradually lost a few of our labels because we want to make sure that we can understand how to find missing pieces. So what I'm going to do is I'm going to look at easier ways to break down the shape. Okay, let's start with our green box here. Okay, so I'm going to do this. Why? Because if you notice, over here, we do have 20 centimeters. So is going to be 20 is our length times 5 is our width. And we can do this real quick, is going to give us 100. All right, if I look here, we have a few options again. Let's see which one that we would like to do. So let's figure out our yellow box. I'm going to think about, well, what if I did this? Again, what if I just did another vertical line? Let's see. I know that my length or width is going to be 18. So it is going to be 18 times something. Now I'm just going to look for this piece. I am missing a horizontal piece. So I'm going to draw out the whole thing to see what helps. Okay, so I know the whole thing is 24. And actually, let me designate my pink box 2, just in case, because you are going to see why we need it here. All right, so if we look, let's put in down what we know. We know from this part to here is going to be 5 centimeters. The purple tells me from here to here is going to be another 10. So together right now we have 15. So 24 minus 15 tells us what this missing piece must be 9. So this must be 18 times 9. And now we have our final box left. So let's see what we know so far. We know that we have part of our box, which is here, which is the bottom part of it. So we know we're going to be multiplying 10 times something. What we're missing is going to be this piece over here. Now, is our width or length, but it's going to be our vertical line. So again, we look at the whole thing. And even see, look at me, I didn't even go to the whole thing. The whole thing goes all the way down here. Notice what we're really trying to figure out is the purple part. Do you notice how 18 actually continues a little bit further? So that's not really going to help us. And I don't see anything that tells us what that remaining little piece would be. So 18 in this isn't going to help us. But what I do notice by looking at my shape is that right here, and let's see if I can find a better color to do that in. Let's actually do this in yellow again. From here to here is 12, which means that from here to here is 12. So, if the whole thing, and that's the part that we're missing, if the whole thing is 20, because that's what it says right here, and I know about 12 of it, so that must mean that what is left is 8, because 20 minus 12 is 8. So the missing side length is actually going to be 8 centimeters. So we have 8 by 10, because this side is going to be 8. All right, now that we have all of our pieces, we can solve for all of our multiplication. 10 times 8 is just going to be 80. And then 9 times 8 is 72. Drop the 2, carry the 7. 9 times 1 is 9, plus 7 is 16. So we have 100 plus 80 plus 162. So let's actually get into the final addition. And I'm just going to erase a little bit of this so we have a good amount of space. So we have 100 plus 80 plus 162. That's 2. That's 14. 342 centimeters squared. There we go. All right, it is your turn to go try these irregular shapes. Remember, if you don't like the way that you broke down a shape, try a different way. Use the clues that are given in any of these problems to figure out missing side lengths. You have it. You just need to take a second, calm down, take a deep breath, and go for it. Can't wait to see you in the next lesson. So proud of you for finishing this one. Go forth, and I'll talk to y'all soon. Hey everybody, Brian here. So wonderful to have you. So wonderful to be going over our next lesson together, where we cover word problems with area and perimeter. Hey everybody, welcome to Area and Perimeter Word Problems on the TEAS with me, Brian. So let's jump right in. All right, our goals for this lesson is that we will be able to solve word problems involving perimeter and area. A few key vocabulary words. Number 1, we have the word area, and this is the amount of space a shape takes up and is measured in square units. So for example, if we had this rectangle here that was 6 meters wide and 8 meters long, the area of the entire shape would be 48 square meters. As for our first one, for area, we use square meters. Second, we have perimeter. That is the distance around the outside of the shape. So if we looked at this current shape here, we know that opposite widths of rectangles are equivalent. So we have 6 for the width, 8 meters for the length. If we added all 4 together, that's 8, 6, 8, and 6. If we added all 4 of these together, 8 plus 6 is 14, plus 8 is 22, plus 6 is 28, and we get meters. Remember, perimeter, we just put the units. All right, 3, we have the word regular. So this is a very important keyword that you will see, which means that a shape where all sides of the shape are of equal length. So if we had a regular hexagon, if we drew that out, we would notice that all sides of the hexagon would be, say, if this one was 10 meters, all sides of the hexagon would be 10 meters. 4, we have irregular, and that means a shape that does not follow the normal conventions of basic shapes. So, for example, a rectangle, we can easily just do length times width to find the area. Circle, we have pi r squared. Triangle, we have 1/2 base times height. An irregular shape here would have to be cut down into smaller pieces of basic shapes to find the total area. 5, we have the word circumference, and that would be the distance around the outside of the circle. So if you hear the word circumference, that's what that means. Circumference, we usually find it as pi d. Remember, pi is the number of times that the circumference fits around the diameter fits around the outside of the circle. So if we had our shape and we had our diameter here, that would be once, twice, 3 times, and we can see here a little bit. When we come across word problems, these are the same things that we're going to follow every single time. 1, we're going to read the whole problem fully. Really important to understand exactly what is happening in the problem before you decide to jump in and tackle anything. 2, if a problem mentions a shape but does not include a picture, draw it out. It's really helpful when you get information to draw out the shape to see what it looks like. This way you are not trying to keep any numbers in your head. You have them in front of you, and you're less likely to make any small mistakes or small errors. 3, if it's perimeter, make sure you've labeled each side. One of the things that we notice is that here people would say 8 plus 12 gives me 20 centimeters, and that's the perimeter. That's not going to work for this problem. Not the way that we do it. Remember, if you label all sides and you're trying to find perimeter, that is going to help you to remember. You have 4 numbers. You're going to add all 4 sides together, and it would give you 40 centimeters for the perimeter. Otherwise, you would end up with half of the perimeter. 4, if it's an area problem, fill in the dimensions that you need and think about the formula. So here we have a square. How do I know it's a square? Because these red lines let us know that all 4 of these sides are the same. So if I have the width, or I know one side, I know that for area, I just need the other side. Area is equal to length times width, or if it's a square, we have side squared, or side times side. So in this case, the area would be 7 times 7, or 49 meters squared, and we make sure we have our units. 5, if it's an irregular shape, break that shape down into smaller pieces using easier shapes. So we can see that this yellow box would be a rectangle. We have the blue one's a rectangle, and the white is a rectangle at the bottom. Same with the shape on the right. We can still break it down into 3 rectangles. Why do we use rectangles? Because we know the area of rectangles are length times width. 6, make sure you've included all the correct numbers and answered the question. This is just a double check. Make sure that you didn't make a mistake by the numbers that you used. Make sure if it's perimeter, you added all of the sides together, and that you've actually answered the question. So did it ask you to find the area, or did it ask you to find the price for carpeting? Just an example, just very much pay attention to what the question is asking. Why do we do this? Again, the area and perimeter problems do not necessarily present themselves as pictures, but they do have a real-world context. It's important to be able to interpret information from regular and irregular shapes to solve these problems. It could be carpeting, painting, fencing, floor plans, devices being put into the body for surgical or health reasons. These are just a few places where this is going to show up in the real world. All right, so one of the things that's important we talked about before is just making sure that you can model information. So if we have number 1 and we want to model a circle with a radius of 5, we would draw out our circle. I know that radius is from the middle to the end, and I know that is 5. Just a quick drawing. so I can see it. Same thing if I saw that I had a rectangle whose length is 6 and width is 5, I'm going to draw out that rectangle. I'm going to say, okay, I know the length is 6 and I know the width is 5. It didn't tell me units, it just told me 6 and 5. So this would be 6 units and 5 units. All right, we are going to jump into our sample questions. So do this however you need to. If you need some examples, do it with me. If you would like to try them on your own, pause the video and continue when you are finished to see if your answer is correct. Sample question number 1. What is the perimeter and area of a rectangle with a length of 14 inches and a width of 8 inches? I notice that this problem does not give me a picture. So the first thing I'm going to do, because I'm dealing with a rectangle and I'm looking for perimeter and area, is that I'm going to draw out this rectangle. Rectangles do not have to be perfect. They do not have to be drawn to scale. And honestly, if you're drawing your own, it does not matter if you put 14 here or you put 14 here, as long as the opposite sides are equal and you've included both sets of numbers. So we have 14 and a width of 8. So just for me, I'm going to put 14 and 8 over here. Why? Because if I'm dealing with perimeter, sometimes it helps to label all 4 sides. So let's deal with the perimeter first. I know the perimeter is the walk around the outside. So if I started at 14, so that's 14 plus 8 plus 14 plus 8. If you want to do 14 times 2 plus 8 times 2, by all means, be my guest. Everyone does this a little bit differently if you have tricks that work for you, as long as the answer is the same. So 8 plus 4 is 12, plus 8 is 20, plus 4 is 24, so drop the 4, carry the 2. That is going to give me 2 plus 1 is 4. And remembering our units, as you can see, I forgot to put in, but luckily we double checked. Our perimeter is going to be 44 inches. Not squared because we did not make a square. We have area. I'm remembering to picture that if I did this, I would have 14 lines going down. Don't count these. That's probably not 14. And then 8 going across. So that reminds me that I'm going to do 14 times 8. 8 times 4 is 32. Drop the 2, carry the 3. 8 times 1 is 8, plus 3 is 11. So I have 112. What are my units? Inches. And because I made all those beautiful tiny squares, inches squared. Notice that this might have been more difficult had I not drawn a picture, but we didn't hurt anything by drawing one. If anything, we did help ourselves. All right, sample question number 2. A rectangular living room is 13 feet by 18 feet. Lynn wants to put new carpeting down that costs $17.85 per square foot. How much money will Lynn spend on new carpeting for her living room? So let's go step by step. If we look at number 1, it says we have a rectangular living room is 13 feet by 18 feet. So let's draw it out. And we label. Longer side is going to be 13 feet. Or 18 feet, excuse me, because that's the length. And we know that our width is going to be 13 feet. I know that Lynn is putting down carpeting. And when I think about carpeting, imagine this lovely yellow carpet, that's seeing how much space the entire room takes up. So this is going to be an area problem because carpet is taking up an amount of space on the floor. Carpet's not going to go around the outside of the room. It's going to go over the floor of the entire room. So I know that that's an area problem. And I know that it is $17.85 per square foot. And we're looking for how much money will Lynn spend on new carpeting for her living room. So first, we're going to find the area of the rectangle. When we do area of a rectangle, that's going to be length times width which in this case is going to be, length is 18 feet times 13 feet, and that is going to equal 234 feet squared. So we know the whole thing is 234 feet squared. Now we're going to find the total cost. It says $17.85 per square foot, and we have 234 square feet, or feet squared. So I'm going to take 234 and we're going to multiply it by $17.85. So 234 times $17.85 is going to give us $4,176.90. So that is how much Lynn will have to spend on the new carpeting for her living room. All right, let's get into sample question number 3. The following is a picture of an apartment floor plan. If Jordan is looking for an apartment that is at least 750 square feet, does this apartment fit her criterion? Why or why not? So we see here that we have an irregular shape. We have a lot of different rectangles put together. We see a floor plan. So let's look at this. It says, does this apartment fit her criterion? Separately, we know that we are looking for our goal, and I'm going to put this over here, is 750 square feet. So when I see square feet, I know that this whole problem is not going to deal with perimeter, but it's going to be an area problem, because the units in square feet match the units that we give for area. Now, here's what I can see. Let's first look at the rooms that we have. So if we're going to look at the bedroom and how we find the area, we're going to look at a few things. So I know the bedroom is 12 feet by 12 feet. So if I'm going to find the area, I'm going to multiply 12 times 12. So I know the bedroom is equal to 144 feet squared. Let's look at the bathroom. Okay, I have a length of 7, so that's the top, and I see that the lines on the sides are the same, which means that this is a square, and the bathroom must be 7 feet by 7 feet. So the bathroom is equal to 49 feet squared. Let's go to the kitchen. Again, I see the kitchen is a rectangle, so I see the length is 15 feet times the width, which is 8 feet. So if we did 15 times 8, that's going to give us 120 feet squared. We have 2 rooms left to cover, so let's get to the dining room. Dining room, again, we see is 10 feet by 10 feet. So we do have a length and a width. So that's 10 times 10. And that's going to equal 100 feet squared. And now we have 1 room left. We have the living room. Now, in the living room, if you notice, I don't have a length and I don't see a width. One thing I do notice is that the length of the dining room and the length of the width of the dining room and the width of the living room are the exact same. So I know that the living room is going to be 10 feet wide. But now I have to find the length. So how do I do that? One thing I can do is I can look at the length of the whole line. So if I just deleted this part here, if I look at this whole thing, I'm trying to figure out how much is this whole thing. Well, I know the whole thing also matches up here where I can do 12 plus 7 plus 15, because that is the same length as the top. So the length up top is 12 plus 7 is 19 plus 15. It's 34 feet. Which means down here must also be 34 feet. And if the dining room is 10 feet, the living room must be 34 minus 10, which is equal to 24 feet. So the living room must be 24 feet long. We could use the opposite sides to help us. So 24 times 10 is equal to 240 feet squared. We can add all of these numbers together. So 4 plus 9 is 13. 1 plus 4 is 5, plus 4 is 9, plus 2 is 11, plus 5 is 15. That's 1, 2, 3, 4, 5, 6, 653 feet squared. So we found how many square feet we had. So let's go back to the question. Well, the criterion was 750 square feet. So our answer, no. The apartment isn't big enough. The criterion was 750 square feet, and this apartment is only 653 feet squared. So no, it does not fit. All right, sample question number 4, our final sample question. Blake noticed the following patch of grass in his yard died. He wants to replace that grass with sod that costs $22.50 per square foot. How much will he spend to replace the dead grass with sod? And we have our shape here. All right, so let's take this to the side. One thing I'm going to add is the sod is $22.50 per square foot. And that's what we need to know. All right, now when we think about grass and we're putting grass down, we think of filling it in. So we're really looking for, what type of problem is this? If you're looking up everything here, we know it is going to be an area problem. So let's look at the shapes that we have here. What I notice is that we have a rectangle. And to find the area of a rectangle, we know its length times width. So in this case, we have 12 times 8 equals, and that's going to give us 96 square feet. Next, we have, if we have a semicircle, because if we see here, we do have a semicircle. So if we traveled along this line here, we'd see that we had a semicircle. But we actually have 2 of the exact same semicircles. So area-wise, we don't need a semicircle. We're actually just going to find the area of the circle. Now remember, the area of a circle is going to be pi r squared. And in this case, we're going to use 3.14 for pi. So we have 3.14 times r. Now, I notice I don't really have an r. But what I do notice is if I looked at my circles, I see the semicircle part right here. That's the diameter. And the diameter is equal to 8. And the radius is half, so the radius must then be equal to 4. So I really have 3.14 times 4 times 4. And that's going to equal 3.14 times 4 times 4, 50.24 square feet. So if we looked for the total square feet, we would add the two together. 96 plus 50.24 is going to equal 146.24 square feet. But we know that the sod costs $22.50 per square foot. So if each of those costs $22.50, we know that it's going to be a multiplication problem. So we're going to multiply these two numbers together, and we're going to get 3,290 and 40 cents will be the total cost. That is an expensive amount of grass for that dead patch. All right, well, we have come to the end of our lesson. It is your turn to go ahead, try some of these questions on your own. Again, remember to draw out these problems, but you got it, and I can't wait to see you again. Good luck.
Hey everybody, Brian here at NurseHub. So great to see you. And today, you might want to get your paint and wrapping paper ready because we're going to be going over surface area.
Hey everybody, this is Brian here at NurseHub, coming to you with our newest lesson of surface area on the TEAS math course. So, let's dive right in. What are our goals? Our goals is that we will be able to find the surface area of three-dimensional shapes. What does that mean? So when we talk about surface area, that is the total outside area of a three-dimensional shape. So if I were to cover the whole outside in paint, how much paint would I need? So we think about if you're gift wrapping, things that take on the outside of a shape as opposed to filling in anything on the inside. One of the things that we use to do this is something called a net. And a net is just a model of a 3D shape broken down to its sides. So if we looked at our 3D shape here, which is the official term for a rectangular prism, if you would like to write this down, show it, notice that this is what we have here. So rectangular prism as the shape, and then we have its net on the side. The net just being broken down into the sides that make it up. One way to think about a net is like if you got a box in the mail, you got a package in the mail, and you were going to break down that box so that you could recycle it, and you cut that box open, what would be the pieces that would be folded together to have made that box in the first place? So you're really just breaking down the shape, that is something that's 3D, into the 2D pieces that make it up. So if we looked at this part here, and we noticed that this was 12, 12, 12, 12, 10, and 10, we could add all four of those pieces, all six of those pieces, together, and that would give us our full surface. All right, key point number one is that area is additive. What does that mean? It means that you can find the area of each different part of the net and actually put them together. Area. Second key point. We're going to hear this a lot. Break a shape down into its net. It makes it much more easy to label and to see how many sides you are actually working with. So if we had a cube, cube, we know all sides are equal, so the length, the width, and the height would all be 4. So in this case, you would notice that each side would be actually 4. One thing really does help to label as much as you can, because then you're actually able to see the different pieces that are there. So making sure that you do have a length and width for every shape that it is involved on the inside. So if you notice that this would end up being, each of these boxes would end up being 16 units, because 4 times 4 is 16. So you have 16, 6 times, 16 times 6 would be 96 units squared. Again, what I would suggest is that when you see the nets, to have them down someplace else so that you can study what those nets look like, especially when we get to things like cylinders, which may be a little bit more confusing. We are going to use our area formulas to find the pieces of the net before adding the pieces together. Remembering that those two most important ones are going to be circles, which is pi r squared, and rectangles and squares, which is length times width. Those are the ones that we will be going to work with. Those are the shapes that you're going to see the most when you're working through your practice questions. 4, area uses square units. Remember, be sure to include that your units are squared. Some of the answers may not have squared units. Those are wrong. Make sure that if you're doing area, it's units squared. If the units are feet, centimeters, etc., you can just use those instead of units. So feet squared, centimeters squared, meters squared, knowing that units we use if we're not actually given a direct measurement. Why do we do this? So surface area determines how much outside space something does take up. So knowing how to find surface area enhances spatial understanding of objects. In hospitals, different tools or implants may be needed, or you may need to actually find the surface area and the specifics about those to ensure safety for patients and staff. So as you know, we've gotten to our sample questions here. See if you can figure out anything on your own, then watch through those videos. I get some cylinders may be a bit confusing. Try whatever you can and see if you get your answers right.
Sample question number 1. What is the surface area of a cylinder with a diameter of 10 centimeters and a height of 14 centimeters? Use 3.14 for pi. When we get a problem like this, especially in geometry, most important thing to pay attention to is the shape that we're working with. In this problem, we're dealing with a cylinder. So the first thing I'm going to do is draw out this cylinder. When you're in geometry, one of the best things that you can do, and who cares how perfect it is to have your cylinder drawn, or whatever shape you're dealing with drawn. And I'm going to put the white dot in the center to let us know that's where the middle of that circle is. Now I'm going to fill in the dimensions of what the problem tells me. So it says this is going to be a diameter of 10 centimeters. So I'm going to go through the middle of the circle, and I'm going to label that 10 centimeters. Same thing down here, showing you that no matter what angle you go through, from the side of the circle to another, as long as you go through the center, it's always going to be 10 centimeters. That's what makes it the diameter. Then we have our height of 14 centimeters. So that's going to be from the top of the shape to the bottom of the shape is going to be 14 centimeters. Now, one important thing I do, especially with surface area, I like to know what shapes make up this larger shape. A lot of places are going to tell you just to memorize a formula. Those formulas don't always work, which what I mean by that is the formulas themselves work, but memorizing them, especially in a high pressure situation, can be very difficult. So let's build what the formula for this would be. I'm going to do 2 circles because that's going to be, say, the top. This circle is going to be the bottom. And if we were looking at what shape is the side of this, think about this like a can. What fills the whole side of a can? Well, that would be the label. And if you took the label off of a can, what shape is it? Well, it's a rectangle. So this is the label, or we're going to call this the side. So what I'm really finding is the area of 2 circles, and I'm finding the area of the label, which is the rectangle. If I can do that, then I know I'm going to be putting them together, and that's going to give me my final total area. When we deal with complex shapes like this, we can break them down into simpler shapes and put them back together again, because area is what we call additive. That means we can add different areas together if we put them together. Just like if you put a kitchen next to your bedroom, you would count the surface area of both rooms in the total surface area, total area of the house, the square footage. All right, so what do we know about our circles? Well, I know each circle has a diameter of 10 centimeters. What do I know about the area of a circle? So my formula. Well, I know that's going to be pi r squared. So area of my circle is pi r squared. Now we know pi is equal to 3.14. So we're going to do 3.14. We're going to multiply that by r. This says r squared, but we have our diameter. So if our diameter is equal to 10 centimeters, our radius only goes from the center and to the outside. So our radius is half of whatever our diameter is. So our radius is 5 centimeters. So that's 3.14 times 5 times 5. Remember, r is squared. Squared means it's the same number being multiplied by itself. So make sure you did 5 times 5 and not 5 times 2. Now, because we have two circles, I'm also going to multiply this by 2. All right? That's going to cover the top and the bottom. So if we do this and I multiply these all together, what do we get? Well, we actually end up with 157 centimeters squared. So the area of both of my circles is 157 centimeters squared. So I'm going to bring that down here because I know I'm going to add from here. So let's get to our next one. Now we're going to look at the label. When we look at the label of this, we know that the height of the label is going to be 14 centimeters. And when we discuss the formula of a rectangle, we know that that's actually going to be the length times the width. Now, technically, it does not matter if you interchange these accidentally. You do not need to worry about it. You'll be fine. Multiplication, the order does not matter. So if you accidentally say one is the length and one is the width, in this case, it's not going to change your answer. All right. So I'm going to assign width as 14 just because of how this is drawn. So I know that this is 14 centimeters. But what I'm really looking for is what is this length up here? What is this length? Oh, there we go. What is this length? Now I have to think about what does the label actually go around? What does the top of the label go around? Well, if you look at the top of the soup can or even the bottom, the label goes around the entire outside of that circle. What else do we know goes around the outside of the circle? Well, that's circumference. So the length of this label is always going to be the circumference of the circle. So this is actually going to be the circumference times 14. Now, what is the circumference? What is the formula? Well, that's just pi times the diameter, or pi times d. So if pi is equal to 3.14, we know our diameter is 10. That was given to us in the problem. And our width is 14. I can multiply these all together and get my answer. So what do we get when we do that? Let's see. So we're going to do 3.14 times 10 times 14. And we should end up with 439.6 centimeters squared. Now remember, that's just the label, so we have to bring that down to our addition problem. I'm keeping the units involved because most likely in your answer choices, they may give you an answer choice where it just says centimeters or it says centimeters cubed. I want to make sure that I remember it's centimeters squared and I don't leave it up to chance at the end. So if we put these together, and I add my 157 and 439.6, that's going to equal, which is luckily our final answer, 596.6 centimeters squared.
What is the surface area of a rectangular prism that has a length of 8 inches, width of 4 inches, and a height of 5 inches. All right, so let's actually draw the rectangular prism first, just so you can see it. So I'm going to go over this way, try to do something that looks very similar over here, and then just connect these pieces. A lot of geometry is just changing your eyes to see. We may see things a little bit differently. I'm going to pretend like this part here is the bottom of the shape. So I'm going to erase this. Actually, let me leave that here for now, and let's just label our shape. So we are looking for surface area. It has a length of 8 inches, so I'm going to put 8 down here. It has a width of 4 inches. So if this is our length, my width is 4, and it does have a height of 5 inches. So the first thing I'm going to do is that I'm actually going to draw out the net of this shape. So I notice that I have the tinier sides, the tinier rectangles on the sides. Then I'm going to think about if this was the one that's in blue. So think about the base or the bottom. I have 4 more sides. So this is going to be your net of the rectangular prism. Now the most complicated thing about this is figuring out where your labels are to see what the net should be labeled as. Now, first one I noticed, so if we look at where the 5 and the 4 are on the side on those tiny ones, if that flap fell down, the top would be 5, and the side here would be 4. Now, also remember, because this is a rectangular prism, opposite sides are equal. So this is also 5, and then this side is also 4. Which then means this side is 4, and this side is 4. We use that because that's actually going to give us a hint to the inside. Notice that if the blue part that's filled in is our base, if 4 is the length, 4 goes then with 8. So in this case, 8 is going to be here. So 8, 8. And if you've noticed, opposite sides of rectangles are equal. So this is also 8. This is 8. This is 8. But notice that the base is going to be opposite of the top. So actually we have a repeat of the base because the bottom and up here would be equivalent. So that tells me that this side is 4 and this side is also 4. So that leaves us missing with a piece. But if you notice and you looked at the front, this one here is also 5 inches. That's also the height. So the 5 and the 8 also interact for this front rectangle. So if we did that, that's the front rectangle right there, which means that this missing side must also be 5 here. And since there's 2 of them, this is also 5. Now that would also make sense because in the box, these corners would actually be stuck together. So if you thought about a box that opened, those 2 would just become one height, if that helps. All right, so now what we have is we have some of our boxes here. So we notice that we have 8 times 5, 8 times 5. So we actually have 8 times 5 twice. So we have 8 times 5, and we have 8 times 5 for the areas. And we'll get all the answers in a second. We're just organizing. What we also have is, so let's circle those. We also have 2 8 times 4s. And we also have 2 5 times 4s. So let's just go through. 8 times 5, that's 40. 40, 32, 32, 20, 20. And we can add these all up. So if it helps, I know 40 and 40, that's going to give me 80. 20 and 20, that's 40. 32 and 32, 64. So if I add these together, that's 4, that's 18. So I have 184 inches. Can you get the units? That's right, it is squared. 184 inches squared. Sample question number 3. A company is building a rectangular shipping container out of metal. How much metal would be needed to make a shipping container that is 7 feet wide, 10 feet high, and 12 feet long? Let's take that exact same idea. So we have our shipping container. Let's connect it. If we had our 7 feet wide, all right, so that's 7 feet wide, 10 feet high. Let's do that. Here's 10. And then we have 12 feet long. If again we pictured our net, tinier rectangles on the side, that would be our bottom piece. So right here. And then I know that I have 4 of these coming off. All right, so now we start to label. I know that if this was there, here would be 7, 7, 7, 7. So actually, let's erase this in here, just so it makes everything else easier to see. 7. All right. We know that the longest part is 12, so this must be, we know that all 4 of these here are 12. 12. Actually, we end up writing it 5 times because 2 of these actually meet and share. Then we see where the 10 would go. So here, the sides are easy to pick that up. We talked about how the corners meet, and then opposite sides are equivalent. So we actually end up with all of our dimensions. Actually, that's a 7. Let me erase that for you. The kids I used to teach always used to ask if it was a 7 or a 1, so I always had to add a line in there to make sure. All right, so here's what we notice. We have a few different areas. So let's start from the top, work our way down, and then we'll go to the sides. So we have 10 times 12. 12 times 7. We have our 10 times 12 again. And then another 12 times 7. And then we have our 2 sides, which is 10 times, actually, we're going to move this because it gets a little crazy looking. Let's move these up a little bit. There we go. Then we have 10 times 7. So 10 times 7. And we have that again. 10 times 7. So let's just run through them real quick. 10 times 12 is 120. 12 times 7 is 84. 120, 84, 70, 70. If you want to add all 4 of these together, go ahead if you want to. I know 120 plus 120 is not 140, but 240. 70 plus 70 is 140. So these have been gone. These have been used. And then I know 84 plus 84. 80 plus 80 is 160. 4 plus 4 is 8. So it's 168. Add them together. 8. That's 14. That 1 plus 2 is 3, 4, 5. 548. 548 what? Feet squared. Our final sample question. For a school project, James spray painted the outside of a can that has a diameter of 4 inches and a height of 8 inches. How much paint is used to cover the outside of the entire can? So let's draw out what our can is going to look like. So we have the top, the sides, and then the bottom of the can here. So if we look, I'm just going to fill this in white so you can see that is the bottom. We know that the diameter is 4 inches. So let's look. Diameter across gives us a 4. Diameter across gives us a 4. And the height is going to be 8 inches. So 4 inches. Let's see if you can't really see that. That's 4 inches there and 8 inches. All right, so let's draw our net, because that's going to show us what everything looks like. So we know we have a circle on the top, connected with a rectangle, just like a soup label. That's what our cylinder is. And a circle on the bottom. So it kind of just looks like a division sign that just got smushed together. So again, let's put in what we know. Diameter is 4. Diameter is 4. And then our height is 8. So we know that the one thing that we're missing is also going to be the distance around the outside of the circle is actually going to be equal to the length of the rectangle. So we're going to get to that in a second. So let's focus first on the circle. And we know that the area of a circle is pi r squared. And we've been using 3.14 for pi. So if the diameter is equal to 4, we know the radius is going to be equal to 2. So we have 3.14 times 2 times 2. So that really means 3.14 times 4. So that's 16. That's 5. That's 12. 2 numbers after the decimal. 12.56 inches squared. But remember, that is for 1, and we have not only 1, but 2 circles. So we're going to do 12 and 0.56 times 2. That's 12. That's 10 plus 1 is 11. 2 times 2 is 4 plus 1 is 5. 2 times 1 is 2. 2 numbers after the decimal. We get 25 and 12 hundredths inches squared. That is a terrible squared. And remember, that is both circles. So we're going to hold on to this for right now. For the rectangle, also important to remember, we know it's length times width. So we know it's going to be 8 times something. Actually, let's color code since we have it. We know we're going to have 8 times whatever this green number is. That is also equal to the circumference, which is pi d, which is 3.14 times your diameter. So if we do 3.14 times 4, I'm going to tell you, be smart. You actually already did that in the other problem. You already found 3.14 times 4. So your actual length is going to be 12.56 inches. Now remember, that just gives you the length. And in this case, it was literally just a coincidence. Don't think that that's going to happen every single time. It's just when we use small numbers, sometimes they do cross over. So we're just going to solve it. Let's do 12.56 times 8. 8 times 6 is 48. 8 times 5 is 40, plus 4 is 44. 8 times 2 is 16, plus 4 is 20. 8 times 1 is 8, plus 2 is 10. 2 numbers after the decimal, 2 numbers after the decimal, and the area of the rectangle is 100.48 inches squared. Now remember, we're not done because we need the final total area where we have to add. I'm just going to put the number with the more digits on top, 104.48 plus 25 and 12 hundredths. So that's 0, 6, decimal point 521. So our final answer is 125.6, because that 0 can be canceled out, inches squared for the area. All right, so it did take us a few steps. Hopefully you understood where these numbers came from. All right, it is your turn to go practice surface area, to see what you understand, see what you know, to go forth and give it your best shot. You got this, and I can't wait to see you again soon. Hey everybody, so great to see you. Brian here at Nurse Hub. No, you don't have to adjust your sound because today we'll be covering volume. Hey everybody, it's me, Brian. Welcome to another lesson where we are going to go over volume on the TEAS math course. So let's jump in. I know this is something that might be a little bit tricky for some of us, so let's use pictures and other things to help us out today. All right, what are our goals? We will be able to find the volume of various three-dimensional shapes. That's our goal, and we're going to be working through a few different shapes today. So make sure that you understand where some of these formulas come from. Memorizing formulas is great, but if you can actually understand why formulas are the way that they are, you are more likely to remember it for long-term gain. So the more you can understand why these numbers are the way that they are, the better you will be today. All right, key vocabulary. So volume is how much space a three-dimensional object takes up. So one way that I always think about volume is that if you had water and you were going to fill the inside of this shape, how much water would be inside? So we're looking for the inside of a shape. If it's a cup, if it's a box, we're looking for how much space would be on the inside of that shape. We're going to talk about the word base, and that's going to be the bottom part of the shape. So one confusing thing about 3D shapes is what we look like when we try to put a 3D shape on a two-dimensional piece of paper like this. So understanding where the base or the bottom is. So in this case, the base is what's indicated by the white part. So if this is the bottom, we know that it's going up towards the top. Same thing here, that if this was the base, the bottom, everything is coming up from there. Some of our formulas do include the word base, so I do want you to get a good understanding of where the base is, what it looks like, how that can work for you. We also have the height. So if you hear the word height, that is the length of a straight vertical line from the base of a shape to the highest point of the shape. This is going to also be important when we go over, if you've not been there yet, when you do area of triangles. What is the actual height? So it goes from the base to the highest point of the shape. That is the height, and it is going to be a straight line. Again, no wiggles, because if you go to the doctor and they try to figure out your height, the height is always going to be a straight vertical line, because if the doctor asks you how tall you are, you're not going to, slant or lie down. Doesn't make any sense. So same thing here with the height. It's always a vertical line up and down. Key points. So number one, the units are always going to be units cubed. So why is that? You're working with three different dimensions, length, width, and height. That's just letting us know that it is cubed. As in squared would be just length and width or something like that. That's two different dimensions, so it is squared. Also, the way that they why they call it cubed is that if you took 1 by 1 cubes, so say we have our cube here. I know, be surprised at how good that drawing is. Teaching elementary school for a really long time, children would make fun of things that I did not get correctly. So I have come a long way in my drawings. So when you say cubed, it's honestly really asking how many 1 by 1 by 1 cubes can fit inside a shape. If it helps you think that's why it's cubed, because you're filling something with cubes, then that's great. But make sure that whatever you do, your units are always cubed. Otherwise, your answer is going to be incorrect. We have a rectangular prism here. When you see rectangular, it's because the base is a rectangle. So I also want you to know that rectangular prisms include cubes, because a square base is considered a rectangular shape. Squares are rectangles. So when we have this, we have length times width times the height. You see that this is also color-coded to match. We have our width over here, our height, and our length. You may also see that once we get rid of this just for a little bit of space, that if we combined these two pieces, length times width, it may also be called base. So this whole bottom piece is the base. But in order for you to find the base, or the area of the base, you would need length times width anyway. So know that you may see different formulas, but base really means the bottom. Because it's a rectangle, we know that we find the area of a bottom piece, which is length times width, multiplied by the height would be that bottom all the way to the top. That gives you your formula for volume. 2, 3D means 3 dimensions. So we're still sticking with that rectangular prism. So 3 numbers are going to be multiplied together because you have your length, your width, your height. All of those are your 3 dimensions. So we want to be multiplying 3 numbers together. Even if you do base times height, the base still requires you to multiply 2 numbers together to get the base. Then you find out your height. For a cylinder, our volume formula is pi r squared times height. Again, knowing where these formulas come from is more important than understanding the formula themselves. Because if you just memorize the formula and you have no idea where it comes from and you can't visualize the shape, what happens is anything can throw you off. You start to panic. You say, oh my gosh, I don't remember this. Is it this number? Is it that? Because you're so focused on remembering the formula and not the actual shape and where it comes from that it's much easier to confuse yourself. So if we look, pi r squared right here is just the base. And what is the base? It's a circle. And the circle, that area, so you're really looking for area of a circle times the height of that shape. So if we were going to find this red area right here, we know that's pi r squared. That continues, this circle continues 1 unit all the way up till you reach the very top. So that's why you have to multiply it by the height. It's the base of this cylinder over and over and over again till you get to the top or the height. Why? Again, this is the most important part. I cannot reiterate that enough. Since the base is a circle, we use pi r squared since that is the area of a circle. If you've noticed, the base is always going to be a 2-dimensional shape. So if you're confused about finding these areas, then go back to the area video. That's going to help you find the area of our basic shapes to help you build on that to get to volume. So we find the area of a circle. That area is repeated for the entire height. Because what we assume that base is, because the base, we don't use height to find the area, we assume that it is 1. So if this is 1 unit, we're seeing how many of those 1 units reach the top. You may see pi or 3.14 instead, depending on the problem's instructions. So we know that pi goes on forever. Some questions may allow you, like you may see answer choices that say something like, our answer is 7 pi, 11 pi, where they actually didn't multiply out pi. It may say, use 3.14 for pi, and then that's the number that you would use. You may also see 22 sevenths, also equal to pi. So really just pay attention, is the answer in a fractional form? Is it in a decimal form? But most of the time, those problems will tell you use 3.14, use 22 sevenths. So this may be something you don't necessarily have to remember. We come to a sphere, and this may be the one that is just the hardest to remember. The explanation as to why this is 4/3 pi r cubed is much more confusing than actually just memorizing this formula. I know that goes against everything I've told you before, but in teaching this specific shape for the last 11 years, every time the explanation does not make as much sense as it does to memorize this formula. It's honestly about cutting up shapes and moving things around, so visually it's not as easy as just memorizing this formula this time. This will be, though, the only one that I will tell you to just specifically memorize, which is 4/3 pi r cubed for a sphere. All right. Again, just like we had with our cylinder, with the sphere, we may use pi or 3.14 instead, depending on problem instructions. You may also see 22/7, which is likely because if we have 4/3 pi r cubed, this is a fraction, 22/7 is a fraction, so it is more likely that you may see that as well. So knowing your options, being ready for any of those parts are going to be great for you. Why do we do this? So finding volume is essential. So in the form of medication would be given in volume. If you have an implant and you're taking amounts of something out of someone, filling containers, there's an infinite amount of solutions where volume comes into play. So you have to be able to find out what the volume is of some of these shapes. Again, we do have our models here, remembering that we do have our base, knowing that that is our base, multiplied by our height. And in this case, our base may be a little bit different here. It's all about how you visually see the shapes. But if your shapes get turned around, and say you accidentally, in quotes, choose the wrong base, as long as everything else is set up correctly, whereas your height might be different than before, like where you have a length, a width, and a height, you're totally fine. So if this rectangular prism was turned up, turned sideways, you're still going to end up with the same volume. So you have your base, in this case, here, and your height would be this yellow line to the top. So making sure that at any point you have a length, a width, and a height. It is our time to go into some sample questions. We are going to practice with and without formulas being given. So make sure that you do understand first how to use the formulas to solve, and then in other cases, making sure that you are seeing if you can remember them on your own. All right, so sample question number 1. A tennis ball has a diameter of 3 inches. What is the volume of the tennis ball? In this case, we have our formula given to us, which is 4/3 pi r cubed. So we first have to put in, what I like to do is I write the formula. So I have 4/3 pi r cubed. If you would also like to write this as 4/3 times pi times r times r times r, that also is something that works. So in this case, I see that we're not given the radius, what we're looking for, we're actually given the diameter. So if you remember, the diameter is equal to 2 of the radii. Why? Because the diameter goes fully through, whereas a radius just goes from the center to the outside. So we cut our diameter of 3 inches in half. So what I'm going to use here, we know that it equals 1.5. Some of you may know this as 1.5, which can equal 3 halves. So for this case, because I have 4/3 here, I'm going to use 3 halves. So I'm going to have 4/3 times, and I'm going to use, in this case, even though it didn't tell me, everything here is fractions. So I'm going to use 22/7 times 3/2 times 3/2 times 3/2. So here we can also get into some cross simplification. So I know that I can have, I'm going to change this 4 and this 2. 4 divided by 2 is 2. 2 divided by 2 is 1. If you need to see cross simplification, please check out some of our multiplying fractions videos to make sure you understand this concept. Again, I'm going to do the same thing. I'm going to cross out this 2 and this 2, and I know that 2 divided by 2 is 1, so this becomes 1 as well. Why do we do this? It's easier to work with smaller numbers. One more time, here, here. That gives me 1. Let me just adjust these, and this gives me 11, because 22 divided by 2 is 11. One final thing that I can do I know 3 and 3, those cancel out, so 3 divided by 3 is 1, 3 divided by 3 is 1 as well. So I have 1 times, so let's do our top first. So our main focus is going to be up top. So we have, if we'd like to rewrite it, and I'll rewrite it for you down here, 1 times 11 times 1 times 3 times 3. These are all of our numerators. So this is 1 times 11 is 11, times 1 is 11, times 3 is 33, times 3 is equal to 99. For the bottom pieces, down here we have 1 times 7 times 1 times 1 times 1. Notice so many of those numbers below canceled out. This equals 7. Notice how this multiplication was much easier than doing 4 times 22, then times 3, then times 3, then times 3. We end up with much larger numbers. So let's keep things a little bit smaller if we can. We have 99 sevenths. Two different things from here. So I'm going to say 99 sevenths units cubed. But what happens if you don't see 99 sevenths? You may see a decimal answer. So if you did 99 divided by 7, 9 divided by 7 is 1. 1 times 7 is 7, minus 2. All right, bring down our 9, that is 4. 7 times 4 is 28. Subtract, we get 1. It may have pieces of a decimal. So we have 10 divided by 7 is 1. 1 times 7 is 7. Subtract, we get 3. And we can do one more. 30. 30 divided by 7 is 4. Is 28. We get 2, and this may keep on going. So this would be a decimal version of your answer, or 99 sevenths. You may see it as a mixed number too, all different options. In this case, pay attention to what your answer choices are going to be. Sample question number 2. A large cylinder used for storing grain. I almost said strong. For storing grain, oh my gosh. For storing grain has a radius of 9 feet and a height of 22 feet. What is the volume of the cylinder? And we're going to use 3.14 for pi. In this case, you notice that it did not give us the formula for finding volume of a cylinder. So our first step, if we draw our cylinder, please go with me. We know that is not a perfect cylinder, but in this case, it is going to do what we need it to do. So we see that it has a radius of 9 feet. So radius involves a circle. So I know that I'm going to check the bottom circle. Radius is going to be 9 and a height of 22 feet. Okay, so I have 22 right here. And we want to find the volume. And in this case, it tells us to use 3.14 for pi. So I'm really thinking I have to find the area of the circle at the bottom. And that continues all the way up to the top. So that's the area of the circle at the bottom times the height of the cylinder. I remember the area of my circle is pi r squared times height. Now I can fill in what is here. So I have pi is 3.14 and r squared is 9 times 9. So I have 3.14 times 9 times 9 times my height, which is 22. So if we look r squared, because that is an exponent, we can do that first. That is 81. So we have 3.14 times 81. And actually, let me change this as we get more complicated to what I told you before. And then we have times 22 to finish. Okay, so now we just have a straight up multiplication problem. So let's take this in pieces. So we have 3.14 times 81. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Placeholder 0. 8 times 4 is 32. Drop the 2, carry the 3. 8 times 1 is 8. Plus 3 is 11. Drop the 1, carry the 1. 8 times 3 is 24. Plus 1 is 25. So we add these together. And I'm going to put this just over here because we're going to use this. So 4 plus 0 is 4. 1 plus 2 is 3. 3 plus 1 is 4. 5, 2. Now remember, our decimal rule. There are two numbers after the decimal here No numbers after the decimal in 81, so we go once, twice, and our decimal point is here. So we have 254 and 34 hundredths as this part of our answer. So the one thing we have left is to multiply by 22. So we have 254 and 34 hundredths times 22. That's going to give us our final answer. So we might have a little bit more space here. 2 times 4 is 8. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Drop the 0, carry the 1. 2 times 2 is 4, plus 1 is 5. Cross this out. Placeholder 0. Again, 2 times 4 is 8. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Drop the 0, carry the 1. And then we add our 5 here. Add everything together. That is 8, 14, 15, 9, 5. Ooh, that's a terrible 5. Sorry. 9, 5, 5. So if we bring this up here, we have 5, 5, 9, 5, 4, 8. Remember, we are not finished yet. So we have our 2 numbers after the decimal in the top number, none on the bottom. So our decimal point does go right here, but we have to make sure we finish something. We need our units. So our units were feet. So it's 5,595 and 48 hundredths feet cubed. Remembering to use our units. All right, so sample question number 3, we do have a planter is 45 centimeters long, that's what the cm is for, 8 centimeters high and 9 centimeters wide. How much dirt would fill the entire planter? Our formula is length times width times height. Now, in this case, we do have our formula and we do have our wording, so we may not necessarily have to draw this one out. Again, do what makes sense. Save yourself some time if you can. If you're ever confused, always draw it out. And here's where I want to show you why this time you may not have to. If you notice, it said 45 meters long. That's our length. 8 centimeters high. That's our height. We also then have 9 centimeters wide. That's our width. So it already gave us those 3 pieces. So therefore, we don't necessarily have to draw it to figure anything out on our own. So in this case, we will have 45 times 9 times our height, which is 8. Now, we do have all multiplication, and I know we have order of operations, and we do things first left to right, and that's totally fine. But I also want us to remember that when it's all multiplication, or all addition, the order doesn't matter. But in this case, to follow what we've been talking about, let's start off with 45 times 9. So 45 times 9, that's 9 times 5 is 45. Drop the 5, carry the 4. 9 times 4 is 36, plus 4 is 40. So we have 405 in this case. So we have 405 times 8. So we know that that is going to be our last part. So let's actually do 405 times 8. So we can do that over here. 405 times 8. 8 times 5 is 40. Drop the 0, carry the 4. 8 times 0 is 0, plus 4 is 4. 8 times 4 is 32. So in this case, we get 3,240. There was no decimals in this answer. So we have 3,240. We have our units. In this case, if we were looking for our units, what we can see is that our units are going to be centimeters, centimeters, centimeters. When you check, the reason I check to make sure all 3 are the same is to make sure that we didn't, or we're not supposed to, change any of our measurement. So for example, if this had meters anywhere, but the rest were centimeters, that would have told us that we should have made them all the same units before we multiplied them together. So we have 3,240 centimeters, and in this case, because its volume is cubed. Sample question number 4. One marble has a diameter of 6 centimeters. If there are 20 marbles in a bag, what is the volume of all the marbles? So what we're going to think about, what shape do we have when we have a marble? So I'm going to draw out my marble. At first, I'm going to use just a circle. And if I just move this over here, this marble just looks like a black hole. So excuse that. But we know that it's going to be a sphere. So you immediately know that you're trying to find the volume of a sphere. How do you know it's volume? Because it asks you for volume. So when you think of volume of a sphere, it's 4/3 pi r cubed. So we start to fill in. It doesn't tell us what to use for pi. So in this case, we can use 3.14. So we can do that. Or we can use 22/7. Totally fine. So let's see. Let's start to just fill in first. So we have 4/3 times pi times r times r times r. So if we actually set this out, that's 4/3 times pi times r times r times r, which in this case is, I noticed though, make sure I didn't put 6 because it said diameter was 6. We know the diameter is equal to 2r. So if the diameter is 6, that must mean that the radius is equal to, in this case, you got it, 3. So we have 4/3 times pi times 3 times 3 times 3. So all different ways that this can work. In this case, because we're dealing with fractions and I do not have a calculator with me, I'm going to use 22/7. I think it's easier when you have fractions to also use this, because if you actually put 4/3 into your calculator, it is 1.3 repeating. I think it's easier to do this, to do that part at the end when you have a repeating decimal than it is to chop it off. Because if you do that, what happens is sometimes your answers are off by a little bit, and we don't want anything to throw us off because some of us then start to second guess our answers if they're not exactly right. So we can save that part to the end. So I'm going to do 4/3 times 22/7 times 3/1 times 3/1 times 3/1. Remember, these are whole numbers, so the 3's are all whole numbers, which means we can add a denominator of 1 and not change the value. Now we can cross out, or cross simplify if we need to. So we're just going to cross out one of these 3's, make it 1, 1. So in this case, it does not work out as lovely for us to cancel anything out. That 7 really makes it impossible for that to happen. So if we look at the bottom, and I always think sometimes let's start with the easier numbers, we have 1 times 7 times 1 times 1 times 1. That's going to give us, oh, you got it, a 7. Up top, I'm going to work our way through. So we have 4 times 22, which is 88. And 88 times 3, so let's do 88 times 3. 8 times 3 is 24. Same thing, 24, 264. So 8 times 3, we've just done this one. Now we have 88 times, not 88, 264 times 3, that final 3 that's there. 3 times 4 is 12, drop the 2, carry the 1. 3 times 2 is 18, plus 1 is 19. 3 times 2 is 6, plus 1 is 7. So we've multiplied by all the numbers we needed to, so we have 792 sevenths. What is this also? 792 sevenths. What are our units? Centimeters cubed. But are we done? What did we just find? If we're not sure, let's look at the sentence again. One marble has a diameter of 6 centimeters. So this is the volume of one marble. But we don't have just one marble. It says there are 20 marbles in a bag. What is the volume of all of the marbles? So we do our next piece, and this may be a little cramped, so I'm going to clear some space. If you need to see this, or where any numbers came from, please feel free to pause your video. But in this case, I'm going to erase just a few things so that we do have some more space and we don't feel too crazy crowded and cramped. All right, so we know that 792 is the volume of one of our marbles, but we have 20. So we're going to do 792 over 7 times 20 over 1. We cannot cross simplify anything just because no factors of 7 go into 20. So we are going to have to do 792 times 20. 0, 0, 0. Placeholder 0. 2 times 2 is 4. 2 times 9 is 18. Carry the 1. 2 times 7 is 14 plus 1 is 15. So we have 15,840 over 7 centimeters cubed. Now from here, you may see an actual answer. So let's go through how to find that actual answer. So I'm going to delete this here. And then let's quickly walk through our long division. So 15,840 divided by 7. So it's 0, 2. 2 times 7 is 14. Drop the 1, carry the 8. Drop down the 8. 18 divided by 7 is, again, 2. 14. That's 4. 44. That is 6. Because 6 times 7 is 42. 2. Bring down a 0. That is going to be 2 again. It's 14. Subtract. I'm going to get a 6. This will be our last one, just in case. Add our 0 at the end. Decimal point. Decimal point. 60. 60 divided by 7 is 8. And then that's 56. And we could keep going if we needed to, but I would check to see if you see any answers that are along this part. Again, making sure that it is, if you do have this, 2,262 and 8/10 centimeters cubed. So either of these are going to be our correct answers. Sample question number 5. A fish tank is 14 inches long, 8 inches wide, and 10 inches high. How much water would fill the fish tank? So again, it's not asking you, didn't say volume, but we look at how much water would fill the fish tank. So we're trying to fill up this shape. We know that volume talks about the inside area of, or the inside of how much something takes up of a three-dimensional shape. I also see some keywords of long, so that lets me remember that that's length, wide, width, high, height. So if I remember, my formula is length times width times height. So now I would just be able to fill it in. 14 inches long, 14, times our width is 8, times our height of 10. So let's start off with our first part. So 14 times 8. 8 times 4 is 32. Drop the 2, carry the 3. 8 times 1 is 8, plus 3 is 11. So I have a 112. And I then do 112 times 10. Some of you may notice when you multiply by 10, you end up just adding a 0 at the end of the number above. But we can walk through it. That's 0. 0 times 1 is 0. 0 times 1 is 0. Placeholder 0. 1 times 2 is 2. Times 1 is 1. Times 1 is 1. Add it together, 1,120. But we cannot forget 1,120 what? All of these problems say inches, all of these pieces. So it's going to be inches, and then we put in our units, finish them off with cubed. So 1,120 inches cubed. And our final sample question for this lesson. Kim buys a can of paint from the local hardware store. The diameter of the can is 7 inches and the can is 11 inches tall. What is the volume of the paint inside? Please use 3.144 pi. So, if we have this problem here, I was just trying to move that up for us. But since we cannot, if we look here, we have a can of paint. So I know that our can of paint most likely is a cylinder. How do I know that it's a cylinder? So we buy a can of paint because it mentions diameter, and diameter is only involved in circles. So I know the diameter of the can is 7 inches. Let's fix that 7. There we go. And the can is 11 inches tall. Cool. Got it. What is the volume of the paint inside? Use 3.14 for pi. So I know that this is a volume problem. So again, I'm thinking the area of the circle at the bottom times our height. How do we find area of a circle? That's pi r squared, then times our height. In this case, it does tell us to use 3.14 for pi, so let's put everything in. That's 3.14 times our radius. Again, this problem gave us diameter, which was 7. So we should be experts of also saying that r equals whatever the diameter is divided by 2. I'm going to use the 7 divided by 2 is going to be 3.5. And that number is squared. I'm going to keep it a decimal because 3.14 was a decimal. It's easier just to use numbers that are in the same format. Times 11. We do have a number that is squared, so that is going to be our first stop. So I'm going to take this to the side and do 3.5 times 3.5. 5 times 5 is 25. Drop the 5, carry the 2, that's 15. 17. Placeholder 0. 3 times 5 again is 15. 3 times 3 is 9, plus 1 is 10. So it's 5, 12. Okay, so 2 numbers after the decimal, 2 numbers after the decimal. So I now have 3.14 times 12.25 times 11. So we're going to get very multiplication heavy here. So if you need to see any of these, I am going to just erase what our multiplication problems were on the side so we have space to do those here. If you need to go back to see where our numbers came from, by all means. So right here we have 3.14 times 12 and 25 hundredths, or 12.25. I'm going to put 12.25 on top only because it has more numbers in it. It just so happens as a coincidence that our decimals line up, but remember, we do not have to do that. So let's go through. 4 times 5 is 20. Drop the 0, carry the 2. 4 times 2 is 8, plus 2 is 10. Carry the 1. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. Placeholder 0. 1 times 5 is 5. 1 times 2 is 2. 1 times 2 is 2. 1 times 1 is 1. Great. Now we're on the 3, so we need 2 placeholder zeros here. 3 times 5 is 15. Drop the 5, carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 2 is 6 again. 3 times 1 is 3. Add our numbers together. That's 0, 5. 9 plus 2 is 11, plus 5 is 16. Carry the 1. 1 plus 4 is 5, plus 2 is 7, plus 7 is 14. 1 plus 1 is 2, plus 6 is 8. Bring down our 3. Now, here we check. We have 1, 2, 3, 4 numbers after the decimal. So we go 1, 2, 3, 4 numbers after the decimal. We have 38.465. 0. So notice at this point, to make things easier, we're going to cancel out this 0. It has no value, so we have 3, or 38, and 465 thousandths times 11. That becomes our final step. So if you need to see this, pause this video because I am going to erase that multiplication to do our final piece. All right, so let's erase. I told you this one was going to be multiplication heavy. Sometimes this happens, and if we don't have a calculator, there is no other way to get this done. So 38, and let's actually just do this in white again. 38 and 465 thousandths times 11. So this shouldn't be too bad because we are just multiplying by ones. So 1 times 5, 6, 4, 8, 3. Placeholder 0, and then it all happens again. 5, 6, 4, 8, 3. Add them together. 5, 11, that's 10, that's 11, 12, that's 13, that's 12, and we get 4. So we get 423,115. Again, 3 numbers after the decimal in your problem. So 1, 2, 3 numbers after the decimal in our answer. So our final answer is 23 and 115 thousandths. What units do we have? Do not forget that part, inches. Both are inches, that's just our double check, so we know it's going to be inches cubed. All right, we've come to the end of our volume lesson. I hope this was helpful. Really try to memorize those formulas and where they come from. Aside from the sphere one, I know there's no other easy way. If you get curious, you are more than welcome to go look up why the volume of a sphere is 4/3 pi r cubed, but by no means is that going to be the most essential thing that you work with. So it's your turn. Go try these out with and without the formulas. I would say if you need to work your way up, go for it. To really check your knowledge, try to use them without your formula. But good luck, and I can't wait to work with y'all soon. All right, y'all. Welcome to another lesson with your host, me, Brian. Today, we're going to be covering scaling. Hey everybody, this is Brian here at Nurse Hub. Welcome to our next video on scaling on the TEAS math course. Let's jump right into what we're going to work on today. All right, our goals for this lesson is that we will be able to solve problems involving scaling. Let's look at what that means, how you're going to see it, and what you need to know. All right, our key vocabulary number 1. What is scaling? That is the ratio of the length of a drawing to the length of the real thing. So we see scales with maps, blueprints, floor plan, where it might say, if you're looking at the floor plan for an apartment or for a house, it might say 1 inch is equal to 3 feet. That there is a scale that compares a drawing to what the real thing looks like. When we do this, we are going to be using ratios, and that is what compares 2 or more things. You're going to see these in your questions. When we do ratios, though, remember we can do 3 different things. We can compare part to part, part to whole, or whole to part. This is what makes ratios different than fractions, right? Fractions need part over whole. Ratios allow us to compare different pieces. So depending on what we need in this problem, we'll choose from these here. 3, proportions. We're also going to be using proportions, which just mean equivalent ratios. So we know that 1/2 is equal to 6/12. If we were going to prove it, that's because 1 times 6 is equal to 6. And we know that 2 times 6 is equal to 12. Now, we can also solve it other ways as well, but we will get into that next. All right, now, if we're going to solve for something like distance, we're going to set up our scale. So if our scale says we have 1 inch is equal to 10 feet, this is something very similar to what we did with percentage, where we matched what was equal to something. So what I mean by that is we see that we have 1 inch is equal to 10 feet. So we set that those two things are equal to one another. They are in what we call the same plane, right? We don't have 1 and 10 not equal to one another. That's not going to work. So we have to make sure that what is equivalent gets set up that way. Next, we're going to set up a proportion to find which pieces are missing. So we have the top part of the proportion, but we are now given additional information. We're trying to figure out what is 14 inches are equal to. If I notice, the left side has inches, the right side has feet. We were given inches, so I'm going to put 14 inches on the same side. We also notice that we're looking for how many feet, so down here would get the x. And then from here, we are going to use cross multiplication to solve. We've used cross multiplication in our percentage videos, so this is not a new idea. If you want to get a refresher too on cross multiplication, go check those out. All right, so one thing I like to do is multiply the variable first. So if we have that here, we're going to call this x and then inches, because 1 times x is just x. And I'm going to show you that if we bring down this here, if we brought down our units, I just want to show you what that looks like. Okay, then we cross over here. We have 14 times 10, which is equal to 140. And I'm just going to bring down both words here because in case you're not sure what units to use, I want to show you. We had inches, we had feet, we can put them right next to each other. Now, we want to solve for x, so we're going to divide both by 1 inch because this is actually 1x. Divide this by 1 inch. The inches cancel out, so you're left with x is equal to, the inches cancel out here, so you're left with 140 feet. That is in case you are ever unsure about what the units are, they can cancel out. But if you set up a proportion, since the 10 was in feet, the x should also be in feet on the same side. That's also one way to keep track of your information. One important thing is that some of these TEAS questions will talk about area scaling. So if you're increasing length and width by a percentage, you must increase the lengths and widths before multiplying to find the area. They will tell you that the length and width have both, say, been increased by 25%. That doesn't mean that you do 12 times 8, get 96, and then multiply it by 25% and add that on. Not the case. It says both. So what it means is that we take, say, 8 inches. And if we did, we increased it. That's 8 times 125%, because we're adding on 25%, is going to give us 10. So the new length is 10 inches, or the new width, whichever one you want to call it. Here, we have 12 inches. We have 12 times 1.25. That means that my new width, or new length, actually because it is the longest side, is 15 inches. So now my area would be 15 times 10 is 150 inches squared. If you also noticed, in case you needed to see it, 25% of 8 was equal to 2, so you could have added 2 on. 25% of 12 was equal to 3, so you were going to be able to add that on as well. Especially with geometry, number 2 is super important. When in doubt, draw out your shapes. Remember to include any numbers that you need. Don't keep things in your head. If you're able to draw it out on your test, on scratch paper, on the computer, draw it out. Why do we do this? So again, we've been using maps, diagrams, floor plans, and other pictures to show us what something looks like using a smaller version because the larger version takes up too much space. Imagine trying to look at an entire floor plan of a building. If it was actual size, that would be gigantic amounts of paper. It would be so hard to see anything. So we use scaling to visualize or use smaller amounts to figure out what things are like in reality or vice versa. So if we looked at this, if we're going to look at distance versus area scaling, if we were looking at the distance, so say in the first part on the left, it talks about the distance is increased by 50%. So if the original was 16 meters, let's just move this up just a little bit. Depending on how you want to solve this, you could do two things. You could do 16 times 0.5, which is equal to 8. Add on your original amount, and that gives you 24. Or what you realize is that you are adding 50%. So if 16 meters is equal to 100%, you're really adding 50%, so that's 150%. So you could do 16 times 150% as a decimal is 1.5, is also going to equal 24. And in this case, good not to remember our, not to forget our units, 24 meters. All right, so that's just distance. Notice how we didn't find the area and our units were just meters. Nothing was squared. If we were going to take it over to the other side, the length and width is increased by 50%. So that means that half of these, it's going to get larger, if you can see that here. So if we took our units to the side, we're going to do 10 times 1.5, and that's going to give me 15. Why 1.5? Because this represents 150%, because we were adding 50%. We also do the same as 6. 6 times 1.5 is going to equal 9. So now to find the area, it would be 15 times 9. So 15 times 9 is actually equal to 9 times 10 is 90, 9 times 5 is 45. So that's actually 135. Now what I want you to also realize is that this was originally 60 meters squared. Our new answer is 135 meters squared. If you did the area first, notice that 50% of 60 is only 30, which meant that if you did the area, then added 50%, you would have gotten 90 meters squared. Not the correct answer. So make sure that notice we had to adjust these first for it to work. All right, we are going to jump into our sample questions. You've seen the different ways that this is going to be presented. If you're confused, go back, go through those explanations, and see if it works a second time. Sometimes we do have to see things more than once. If you feel ready, look at the question, see if you can do it on your own, then hit play to see if you got it right. All right, let's go. In looking at a map, 1 inch is equal to 40 miles. If two cities are 5.7 inches apart on the map, how many miles apart are the cities in reality? Bunch of word problems, but there's something that we should always look for. You should always look for your scale. So that's something we should always be on the lookout for. What is our scale? So in looking at a map, nope, not our scale. That doesn't help. 1 inch is equal to 40 miles. Oh, that's my scale. So I immediately am going to write 1 inch is equal to 40 miles. This over here. All right, what we've noticed next, because we're going to set up our proportion, it says if two cities are 5.7 inches apart, I notice I have 5.7 inches. Because it says inches, I'm going to keep it on the inches side. I'm going to put 5.7 inches, and we're looking for how many miles. So that means the number underneath in miles should be missing. So that gets the X. From here, we are then going to cross multiply. Again, I like to use the variable and keep it on the left side. So 1 times x is x. Obviously, if you did that second, you could totally do that. I just like to put the left first and go left to right. That's going to equal, we have 5.7 times 40. I'm just going to take this to the side. 40 times 5.7, that's 0, 28. Placeholder 0, 5 times 0 is 0, 5 times 4 is 20. Add them together, 0, 8, 2, 2. There was one number after the decimal in the problem, one number after the decimal in the answer. So x is equal to 228. Now we need our units. Remember, the question asked for miles, so we make sure that we put miles. So the cities are apart by 228 miles in reality. Sample question number 2. An architect is drawing a floor plan of an apartment. If the scale is 1 to 8, how long would the drawing of the actual room be if the actual length was 98 inches? So if we look at the apartment, so let's see. An architect is drawing a floor plan of an apartment. If the scale is 1 to 8, that lets me know that 1 to 8. So whatever 1 is going to be 8 times larger in reality. So when I think about this, I know that we're looking for the actual length. So it says actual length. Is that going to be the drawing? Or is that going to be in reality? Well, it says actual. And if the scale is 1 to 8, we have to figure out which one of these, 1 or 8, is going to be the drawing or the reality. Well, I know that the drawing is smaller, so I know that the drawing is probably going to be the 1, and the 8 is going to be the reality because it's 8 times larger. And we know that the actual length was 98 inches. So I'm thinking, where does this 98 go? It must go down here. How else do I know? Well, because it also said, how long would the drawing of the actual room be? It's looking for the length of the drawing, which means that that part is missing. This was a little confusing to set up, but that's why we had to work through the information we were given. I used labels to help us figure out which ones go where and how to set it up. So now we can cross multiply. 8 times x is 8x. Notice how this one is different. We didn't just end up with x. And we get 1 times 98, which is 98. We are going to solve for x. So we are going to divide both sides by 8. So I'm not going to do this in my head because I'd like to get the right answer. So 98 divided by 8. 9 divided by 8 is 1 times 8. That gives me 1. 18. That's 2. 2 times 8 is 16. And let's see how this goes. It didn't tell me what I needed. I didn't get to see answer choices, but generally the rule of thumb is you try to go 2 decimal places to 2 places after the decimal just to see. So bring it down. That's 0. That's 2. 2 times 8 is 16. 4. Oh, I'm so excited because I know this is going to end. 40 divided by 8 is 5. 40, 0. So we know that it is 12.25. So x is equal to 12.25. But 12.25 what? Notice that the only thing that was mentioned in the entire problem were inches. So it is safe to assume that it's going to be in inches. All right, sample question number 3. The Quinns' living room is currently 12 feet by 8 feet. If the Quinns want to increase each dimension of their living room by 40%, what will be the area of the new living room? Now remember, I told you, let's draw this out. So let's look at the original. And then I know we're going to have one that's a little bit bigger. And we can call this the new one. So let's label it old versus new. So if we look, the old, it says 12 feet by 8 feet. And we're looking for the new one, which we know is each of these are 40% larger. So if we're going to find the new dimensions, what we're really doing is we're taking 100% of the original and we're adding 40%, which means that the new lengths and widths are 140% of the original. Why do we do this? Because it actually helps you do everything in one step. If you want to find 40% and add it on, that is great. But this is one of those that is the one-stop shop, one step to get it done. So I'm going to do 12 times 1.4 because that 1.4 is 140%. So 4 times 2 is 8. 4 times 1 is 4. Drop the 0. 1 times 2 is 2. 1 times 1 is 1. We add them. 8, 6, 1. And we have one number after the decimal. One number after the decimal. Our new length is 16.8 feet. Wonderful. That's step 1. So let's look at the new dimensions for 8 feet. I'm going to flip it around. Remember, with multiplication, you can change the order. Totally fine. And we're going to do 1.4 times 8. I just personally like to see the number with the least amount of digits on the bottom. This way I don't have to worry about placeholders. So 8 times 4 is 32. Drop the 2, carry the 3. 8 times 1 is 8. plus 3 is equal to 11. One number after the decimal, one number after the decimal. So our new length is, or our new width is 11.2 feet. Are we done? We are not. Nope, you got it. So I'm glad you heard that. We're not done because now we're looking for the area of the new living room. We know area is going to be length times width. So we're going to take our length, 16.8, and we're going to multiply it by 11.2. So let's get it done. 2 times 8 is 16. 2 times 6 is 12, plus 1 is 13. 2 times 1 is 2, plus 1 is 3. Close those out. Placeholder 0. 1 times 8, 8. 6, 1. That was easy enough. 2 placeholder zeros. Oh, even easier again. 8, 6, 1. Add them together. 6, that's 11. 4, 10, that's 18. 8, 1. Here's the fun part. We have 2 numbers after the decimal in the problem. So we'll have 2 numbers after the decimal in our answer. And the area is equal to 188 and 1600ths. What was our unit? Feet squared. Awesome. All right, let's get into sample question number 4. The dimensions of a small park are 40 feet by 60 feet. If the larger park has dimensions that are 60% larger than each of the smaller park's dimensions, what is the area of the larger park? Lot to take in here, so take it step by step. It says the dimensions of a small park are 40 feet by 60 feet. Cool, let's do it. So we know that this is the small park. So let's just label that in. So let's write small park, and we know it is, say, 60 feet, and we have 40 feet. Cool. Okay. If the larger park, I guess there's a larger park, so that's exactly what we are going to put in. So let's draw the larger park. Let's put it down here, and we know that it's 60% larger. So if we put this in here and we say that the park is 60% larger dimensions, that just helps us set up what comes next in our problem. So if we're looking for our dimensions, we are looking at 160% of each of the original. So let's slide this over. So we're looking for 160% of each. So we know 160% is equal to 1.6. So let's take 60 and multiply it by 1.6. So 6 times 0 is 0. 6 times 6 is 36. 0, 1 times 0 is 0. 1 times 6 is 6. We add it, 0, 6, 9. One number after the decimal. So it's just 96. So the new dimensions, which I'm going to put in red, 96 feet. All right, so that's going to be our new length. Now let's check out our new width. If you're wondering why we're multiplying by 160%, the original was 100%. We had 60% larger dimensions. So that's 100% plus an additional 60% is equal to 160%. Then you see down here, that equals 1.6 as a decimal. So let's look at 60. Not 60, because now we're at 40. Same excitement for that number. 1 times 1.6, 6 times 0 is 0. 6 times 4, 24. Drop your 0. 1 times 0 is 0. 1 times 4 is 4. Add it together. 0, 4, 6. One number after the decimal. Boom. So it's now 64 feet is our new width. We have our new lengths and widths. Let's now find the area. So we've done all of this part. We found the new dimensions. And now we find the area. We take our length times our width. 96 times 64. 6 times 4, 24. Drop the 4, carry the 2. 4 times 9 is 36, plus 2 is 38. Cross it out, we used it. Placeholder 0. 6 times 6 is 36. Drop the 6, carry the 3. 6 times 9 is 54, plus 3 is 57. Add it together, 4. 14, that's 10, that's 11. 6. We have no decimals, so our answer is 6,144. What was it? Feet squared. All right, there you go. Hopefully you got it. All right, y'all, we've come to the end of our scaling lesson. I really hope this was helpful. Hope you got to understand how to interpret these questions, how to draw things out, how to use evidence to prove what is going on. It is your chance to go onto Nurse Hub to check the rest of these questions, to really practice it. So go forth. Best of luck, and I can't wait to see you again. Hey y'all, Brian here at Nurse Hub, and what we're going to cover today is everybody's favorite, metric to metric conversions. Hey everybody, welcome to metric conversions on the T6 math course with me, Brian. So let's jump right into this and get started on something that we know concerns a lot of us out there. Our goal is that we will be able to convert between different units of metric measurement. I got a little too excited. So metric measurement, that is the goal of this lesson. All right, when we deal with metric, that is a system of measurement using base 10 conversion. So what does that mean? It means that in order to go from one measurement to the next level, everything is going to be in powers of 10. So for example, we would have 10 millimeters is going to be equal to 1 centimeter. They're all going to be powers of 10. So for example, 100 centimeters then is equal to 1 meter. So all of these are going to be powers of 10. You're really not going to see numbers like 9.714 to go from one to the other unless you're dealing with something like I have 3.5 millimeters. It takes 10 millimeters, 1 centimeter for every, and you'll see more of this later on. All right, when we have unit measure, you're going to see the word unit in there. We actually use it for how we describe how to know the order of the prefixes. When we talk about unit, our units are meters, liters, or grams. The prefixes stay the same, but the units that we're measuring in become a little bit different. So everything's still in base 10, but we use the word unit because it's not always going to be meters, always liters, or always grams. When we talk about converting, remember that means to change from one unit to another without changing the value of something. So we're just changing how it looks without changing the actual value. So if I said to you that 30 milliliters is equal to 3 centiliters, we didn't change the actual measurements, we just changed how we were presenting them. All right, key vocabulary number 4, we have the word prefix. That's a word placed in front of one of the metric unit measurements to denote the size. So I like to write mine with smallest going to largest. This way I write it the same way that I would write a number line, where the smallest stuff would be towards the left, and the further you go right, the larger that you get. I prefer to write it this way. Some of you may write it other ways, but this is the way you're going to see it here today. So we have milli, centi, deci, unit, deca, hecto, and then kilo. So milli is the smallest, kilo is the largest. So all of these are going to be powers of 10. So every time you move from one to another, there will be a power of 10 in play. If you move twice, in this case would be dividing by 10, dividing by 10. It's really going to be then dividing by 100 because it is powers of 10. So, like key point number 1 says, for each step you move to the right, you divide by a power of 10. So, what I'm really also meaning by this is when you go from a smaller unit to a larger unit, we get so caught up on just the idea of right or left that I want you to realize in this case, we're going from milli to deci. So you're going over. which is like dividing by 10 twice, which is the same thing as dividing by 100. Now, the opposite is going to be true. So for each time you move to the left, you multiply by a power of 10. What that means is going from a larger unit to a smaller unit. So in this case, we're going from kilo to deca, which means we're ending up having to move 2 spaces, multiplying by 10 for each of those, which is the same thing as multiplying by 100. As long as you can remember how the order of the prefixes, and you know that this is base 10, metric conversions can be fairly easy. If you are going from a larger unit to a smaller unit, you multiply by powers of 10. Again, that's something I've said. So instead of really focusing on do I move left or do I move right, really figure out, are you going from a larger unit to a smaller unit? Because you're going from a larger unit to a smaller unit, you multiply by powers of 10. So you think about it is, if I was going from units and I wanted to go all the way to milli, that's multiply by 10, multiply by 10, multiplying by 10 for each step, which then becomes the same thing as 10 times 10 times 10, which is the same thing as multiplying by 1,000. The opposite is also true. If you're going from a smaller unit to a larger unit, you're going to divide by powers of 10. So, for example, if I was going to be starting at centi and moving to basic units, that means I'm dividing by 10 for each step that I take, which is then the same as dividing by 100. Again, the most important part is knowing if you're starting at a smaller unit and going to a larger unit, or are you going from a larger unit to a smaller unit. So to multiply or divide, we're going to move the decimal the same number of places we moved between prefixes. So I'm going from kilometers to meters here. So let's look. I know that I'm starting at kilometers, and I'm going from a larger unit because kilo is the largest, milli is the smallest. I'm going from a larger to a smaller unit, and I made 3 steps. So that means I'm actually multiplying by 10 each time, so my number should be larger. So if I took my 3.2 and I moved my decimal point once, twice, 3 times, I filled in zeros for blank spots. That leaves me with 3,200 meters. We are going to use the prefixes to help us. Now, the most used are going to be milli, centi, or kilo. One I'm going to add in here, because it doesn't have a prefix, is you're also going to use the units the most. We rarely use deci, deca, or hecto. But we still need to know where they lie in the order, because if we don't include them, then we're not going to be jumping the right number of steps. So one thing that we use is this to remember the prefix order. My cousin Daniel uncovered delightfully happy kangaroos, using the first letter of each of these to help you remember the prefix that you're going to come across. Now, the only repeat here is going to be the D's. One way that I remember the D's is anything that is smaller than the unit ends in an I, and anything that's larger ends in an A or an O. So I know that deci comes with centi because they both end in I. So that's some way that I remember it. You might also have heard King Henry died unexpectedly drinking chocolate milk, and that's as if you started with kilo and went down. So that is also an option for you to use. If you do that, I would just write it as King Henry died unexpectedly drinking chocolate milk. This way you just know that still milli is the smallest and kilo is the largest. I just think it helps for you to know which is the smallest, which is the largest, so that you can understand where to go. Now, why do we do this? The majority of countries around the world use the metric system to measure liquids, mass, and distances. So many items in the medical community are measured using the metric system as it measures smaller amounts more accurately. It is essential to know how to convert between different measures of the metric system. So we do need to know these measurements, so let's get to our conversions. When we get to our sample questions, you always have your options to do it with me, to try it on your own, then check your answer, or do it on your own. Or a mix of all of them. All right, so sample question number 1, we're going to go from 62 millimeters to centimeters. Now, what I highly suggest is every time you write out your letters for your prefixes, just so you can see. Ours will be here, but this is something that will not be on your exam that you should be ready to do on your own. So here's what we look at. We can see we are going from milli to centi. I know that I'm going from a smaller unit to a larger unit because milli is the smallest, and I'm making one step, which means I'm going to be dividing by 10. And when I divide by 10, I move my decimal point one spot to make my number smaller. So I know that my decimal point is at the end of this number. If it's not there, I'm going to divide by 10, which means I move it one spot to the left because that makes my number smaller. And that gives us 6.2. So we get 6.2 centimeters. Now the units here don't matter whether it's meters, liters, or grams. It's still going to be the exact same thing. Okay, we are going from 412 centimeters to how many decimeters? So we are going from centimeters to decimeters. If I look in this order, since I know that milli is smallest and kilo is largest, I know that I'm going from a smaller unit to a larger unit. So I'm going to be dividing by 10. So I'm going to take 412, put my decimal point at the end, and when I divide by 10, I move my decimal point one spot to the left. If you would also like to put into your calculator, that is totally fine if you need to, but we get 41.2. So it's 41.2 decimeters. Sample question number 3, 84 meters is equal to how many kilometers? So again, let's label. We have our smallest unit is milli, our largest unit is kilo, and we are going from our units, because it's meters, and it has no prefix, so we're at unit, and we're going to kilo. So again, I'm going from a smaller unit to a larger unit, which means every time I jump, I'm going to write in I'm dividing by 10. So that means I'm going to take 84. I'm going to add my decimal point. Let's move this over a little bit. And I know that I'm going to move 3 spaces to make my number smaller. So that's 1, 2, 3, and put my decimal point. I put a 0 in this space. And so that we don't confuse this with 84, you always put a 0 to the left of a decimal point if there's no whole number here. This way, it's easier to prove accuracy. So this would be 84 thousandths kilometers. Sample question number 4, we are going from 3.6 kilometers to how many meters? So let's do the labeling. Milli is the smallest, kilo is the largest. Where are we going from? Okay, we're starting at kilometers, and we're going to meters, which is our unit. Meters has no prefix, so that must be our unit. Remember, meter, liter, gram. Those 3 go where the units are. So we're making 1, 2, 3 spots, going from a larger unit to a smaller unit, which means each one is multiplying by 10. So if I took 3.6, I have my decimal point there. I want my number to get larger, so I'm going to move it to the right. That's once, twice, 3 times. Add 2 zeros in. Decimal point goes here, but I do not need it for my final answer, so it'd be 3,600. If you included it, it's fine. If you didn't include it, also fine. But as long as your answer reads 3,600 meters. Sample question number 5. We're going from 436 centimeters is equal to how many millimeters? Okay. Millis are smallest, kilos are largest, and we're going from centimeters to millimeters. So that tells me I'm going from a larger unit to a smaller unit by 1 step. So I'm going to multiply by just 10. So if I take 436, I put my decimal point at the end, and I want the number to be larger, so I'm going to move it 1 step over to the right, put an empty 0 in that spot for a placeholder, and my answer is going to be 4,360 millimeters. Final sample question, we are going from 83.7 meters is equal to how many centimeters? Again, we get our labeling in. Milli is our smallest, kilo is our largest. Where are we going from? Meters, which is our units, to centimeters. So that means I'm going to move once, twice. Now I'm going from a larger unit towards a smaller unit. So I'm going to multiply by 10 each time. So that means I'm going to move my decimal point twice. So I have 83.7. I'm going to move it once, twice, put a placeholder 0 in, and that's going to then equal 8,370 centimeters. All right, that was it for metric conversions. It is your time to go practice. Best of luck. Let's make conversions feel a little bit better for each of us, and I can't wait to see you soon.
Hey y'all, Brian here at Nurse Hub. Welcome to another lesson where today we're going to be covering standard to standard conversions dealing with liquid.
Hey everybody, welcome to standard conversions that are liquid on the T6 math course with me, Brian. So I know conversions are something we are always concerned about, so let's jump right into today's lesson. Our goal for today is that we will be able to convert between different units of standard liquid measurement. So our first key vocabulary word is to convert, which means to change from one unit to another without changing the value of something. So for example, if we had 1 cup, we could also say that we had 8 ounces. Both are worth the exact same amount, even though they look different. It all depends on how you're measuring your liquids. All right, key point number 1. When we go from a smaller unit versus a larger unit, so using these are going to determine how you are moving. We compare the size of one of each. That will determine which is the smaller or larger unit. So if we had cups versus ounces, cups take up more space. So 1 cup takes up more space than 1 ounce. So a cup is a larger unit and an ounce would be the smaller unit. Best way to think about if it's a larger or smaller unit. If you are going from a smaller unit to a larger unit, you are going to divide. As you see here, we have the 5 standard ways that we measure liquid: ounces, cups, pints, quarts, and gallons. We have ounces is the smallest and gallons are the largest. Now, when we did metric conversions, it was base 10. Standard is not the same way. So you can see what you'd have to divide by to go from one to the other. To go from ounces to cups, we divide by 8 since there's 8 ounces in a cup. Cups to pint, we divide by 2 since there's 2 cups in a pint. Pints to quarts, divide by 2 again because there's 2 pints in a quart. And to go from quarts to gallons, we divide by 4 because there are 4 quarts in a gallon. Now, one way to also think about quarts, quart, quarter, there's 4 quarters in a dollar, so there must be 4 quarts in a gallon. Step 3, if you are going from a larger unit to a smaller unit, you're going to multiply. You can see that this looks just like the exact opposite of the slide before. Gallons to quarts, we multiply by 4 since there's 4 quarts in a gallon, and all the way down the line. As you see, ounces is the smallest unit, gallons is the largest unit, so we are going from larger units to smaller units. For if you get to conversions, write these out ASAP as they are fresh in your memory. So if you're taking your assessment and you come across conversion questions, even it helps in the beginning to immediately sit down, and as you'll see, if you sat down immediately and just started to put down the conversions that you know. I always do this too small where I can never fit cups in here. So I'm just going to do that in different colors so you understand. There's 2 C's in each of these. But if you sat down and wrote out the gallon man or the gallon person, then you'd be able to have that there so you wouldn't have to worry about remembering it later on. If you know the direct conversion, use it. If not, go step by step. So let's say we had an example and we were trying to take 96 ounces equals how many pints? If you knew that there are 16 ounces equals 1 pint, you could do 96 divided by 16, and that would give us, let's see. So 96 divided by 16 would be 6 pints. But say that that didn't necessarily work for you. We could have also done 96 ounces divided by 8 ounces per cup equals 12 cups. And since we have 12 cups divided by 2 cups in a pint would then equal 6 pints. So in case you cannot remember it right away to go one step, you can absolutely do multiple step. And in fact, the multiple step method is probably the one that you're going to see the most. All right, we have the gallon man here, or the gallon person, whatever you want to call it. We have the conversions here. So you have the large G, you have, which stands for gallon. You see there are 4 Q's, so which meaning 4 quarts. We have 2 large P's inside each of the Q's, which means 2 pints inside of a quart, and then 2 cups inside of each pint. So if you looked at this, you could also see something like if we looked at how many cups are in a pint, we see that or how many cups are in a quart. We see that there are 4 yellow C's inside of each Q, so that means there are 4 cups in a quart. If we looked at pints in a gallon, you could see that there are 8 green P's inside the large G. So it does help you figure out your conversion. So this might be something you want to write down, or this might be what you want to study so that when you start your test and conversions definitely pop up, you have these here. Why do we use these? So different units of measure are used to measure amounts of liquid. So from cups to gallons to ounces, we have to be able to convert back and forth between these amounts as different situations will call for different types of measurement. So we have our sample questions here. As always, you can do these with us or with me. You can do them on your own or a mix of both. I would also suggest maybe you try some with the big G at first and then try to put it to the side and see if you've memorized it the best that you can. All right, what you also are going to notice as we see 56 ounces equals how many cups, I personally like to have these underneath just so I remember the order, and then I can think of the big G to think of how many is in each. All right, so the first thing that we're going to look at is we know that ounces is our smallest unit and gallons is our largest, and we're going from ounces to cups. And I know ounces is not in our gallon man, so this is something that you may have to memorize on your own. When I go from ounces to cups, I'm going from a smaller unit to a larger unit. And I know there are 8 ounces in a cup, so I'm going to divide by 8. So if I think 56 ounces divided by 8 ounces in a cup, my units of ounces are going to cancel out. 56 divided by 8 is 7, and we bring over our unit of 7 cups. So our answer is 7 cups. Sample question number 2, 48 cups is equal to how many gallons? So I'm just going to slide this down a little bit, give us some more space. Because if you've noticed, not only do we have our smallest and largest units, but we are going from cups, pints, quarts, gallons. We're making 3 jumps. So this is something that may take up a little bit more space. So if we're going to go from cups to pints, I know that this is divided by 2. Remember, smaller unit to larger, we divide. Pint in a quart, there's 2 pints in each quart, so I would divide by 2. Quarts to gallons, I would be dividing by 4, since there's 4 quarts in a gallon. Now, if you multiplied 2 times 2, which is 4, times 4, which is 16, we could divide in one step. But that might be confusing for some of us. So I'm going to walk through how we would do this without that. So let's look at step 1. We would take 48 cups divided by 2 cups in a pint, and that's going to give us 24 pints. Now we've done our first jump. So let's look at jump number 2. We have 24 pints, and if we divided that by 2 pints, and I'm going to use the abbreviation of quarts, and that's going to equal 12 quarts. Now we've come to our final one as we go from quarts to gallons, so that's step 3. So we have 12 quarts divided by 4 quarts in a gallon. That's going to give me 3 gallons. So my final answer would be 3 gallons. Sample question number 3, 20 cups is equal to how many quarts? So let's again label, we have our smallest unit to our largest, and we're going to look how we're moving. So we're going from cups to quarts, so that's once, twice. I am going from a smaller unit to a larger unit, so I know I'm dividing. Cups to pints is divided by 2. Pints to quarts is divided by 2. Got it. So that's where I'm going, from cups to quarts. So now I can do my step 1 and my step 2. So if we look at step 1, we have 20 cups divided by 2 cups in a pint, and that's going to give me 10 pints. So then if I look at step 2, I take what I just found, 10 pints, divided by 2 pints in a quart. That's going to give me 5 quarts. So I know my final answer is going to be 5 quarts. We're going from 3 gallons is equal to how many ounces? So again, let's look. We are starting from gallons, which we know is going to be our largest unit, and ounces is our smallest. So we're going from gallons to ounces. So we're going to make that once, twice, 3. We're going to have to do 4 separate things. So to go from gallons to quarts, I also know I'm going largest to smallest, so all 4 of these will be multiplication. There are 4 quarts in a gallon, so I'd multiply by 4. Quarts to pints, 2 pints in a quart, 2 cups in a pint, 8 ounces in a cup. Now, if you were going to put these all together, to do this in one step, you could do 8 times 2 times 2 times 4. So 8 times 2 times 2 times 4 is equal to 128, which means there are 128 ounces is equal to 1 gallon. So you could do all the multiplication in the beginning as if it was 1 gallon, and we could do the same thing for 3 gallons. So we could do that. Actually, let's solve this one like that so you actually see it. If you weren't sure, we've done a lot of proportions already. So you could say 128 ounces is equal to 1 gallon. We now have 3 gallons is equal to X ounces. And we cross multiplied. X times 1 is X. 128 times 3 is going to give us 384. Now, if you like this method, awesome. If not, you've seen how we go from one step to the next step to the next step to the next step. Just want to show you some different ideas, since not every single method works for every single person perfectly. All right, sample question number 5. We are going from 8 cups to ounces. We know gallons is the largest unit, ounces is the smallest, and we're going from cups to ounces. So we are going from a larger unit to a smaller unit. So we're going to multiply, And since there are 8 ounces in a cup, we multiply by 8. So we have 8 cups times 8 ounces per cup. So 8 times 8 is 64. Our units of cups are going to cancel out. We'll be left with ounces. So 8 cups equals 64 ounces. Here is our final sample question. We are going from 9 quarts is equal to how many cups? One more time, we have gallons is the largest, ounces is the smallest, and we're going from quarts to cups. So I know I'm going from a larger unit to a smaller, so both of these will be multiplication. And there are 2 pints in a quart, 2 cups in a pint. So I'm going to have 2 steps to this. So step 1 is our first step, and then step 2. So 1, we're taking 9 quarts times 2 pints in a quart, and that's going to give me 18 pints. 9 times 2 is 18. Our quarts cancel out, so we're left with pints. 2, we have 18 pints times 2 cups per pint. So 18 times 2 is going to give me 36. Pints cancel out, we're left with cups. So our final answer is 36 cups. All right, we've come to the end of standard conversions of liquid measurement, so it is your time to go try these out. You have the conversions, see if you can memorize the big G and everything inside of it, and I cannot wait to work with you soon. Good luck.
Hey everybody, Brian here. So wonderful to see you. In today's lesson, we're going to be covering standard to standard conversions with distance.
Hey everybody, welcome to standard conversions of distance on the TEAS with me, Brian. And let's get right to it. Our goals for this lesson is that we will be able to convert between different standard units of distance. Our key vocabulary for this, when we talk about standard units, those are the official standard units that we use in the United States. So for distance, we use inches, feet, yards, and miles. When we convert, we're going to change between different size units of measure without actually changing the distance. We're just changing what we've decided to measure it by, but the distance itself does not, in fact, change. Key points. When we are converting from a smaller size unit to a larger size unit, we are going to divide. So for example, in this case, our smallest units are inches. Our largest units are miles. So if we're going from a larger unit, so for example, if you ask yourself, what is larger, a inch or a foot? Inches are smaller, feet are larger, so therefore inch is the smaller unit. We're actually going to divide. From inches to feet, we divide by 12, since there's 12 inches in a foot. From feet to yards, we divide by 3, since there's 3 feet in a yard. And to go from feet to miles, we divide by 5,280, since there are 5,280 feet in a mile. 2, when converting from a larger size unit to a smaller size unit, we are going to multiply. Again, if we look at miles, that is our largest unit, all the way down to inches, which is our smallest unit. So if we ask ourselves, what is larger, say a yard or a foot? By smaller unit, we say foot because 1 foot is smaller than 1 yard. In this case, if we're going from a larger size to a smaller size, we are going to multiply. From miles to feet, we multiply it by 5,280. Since there are 5,280 feet in a mile, yards to feet, we multiply by 3, since there are 3 feet in a yard. And we multiply feet by 12 to go to inches, since there's 12 inches in a foot. When we have these conversions, we'll just have to memorize them. So we have 12 inches in a foot, 1 yard is equal to 3 feet, and 1 mile is equal to 5,280 feet. We generally don't talk about miles in terms of yards or inches, and we don't really talk about yards in terms of inches either, although it is possible to get there. Why do we do this? So oftentimes measurements we need are not given in the correct format or the units that we really need. So we do need to convert between different units of measure. Conversion methods are the same for standard and metric units, so we can internalize how to change between these different measures. We are going to jump into our sample questions here and use these conversions to help us solve our questions. All right, sample question number 1, we have 72 inches is equal to how many feet? Now, one way to think about this, we are going from inches to feet, so we are going from a smaller unit to a larger unit, which means we are going to divide. So we can do this 2 ways, but I'm also going to show you the ways of using a proportion to solve. So we are going from inches to feet, and we know that 12 inches are equal to 1 foot. So if we have 72 inches, is that going to equal how many feet? If you do know the answer, that is wonderful without setting up the proportion, but we are going to walk through how we do it should we set one up. So we can cross multiply. 12 times x, that's 12x, is equal to 72 times 1, which is 72. If we divide both sides by 12, we're going to end up with x equals 6 feet. So 72 inches is equal to 6 feet. Sample question number 2, we have 144 inches are also equal to how many feet? In this problem, we see that we are still working with inches and feet. So we are going from inches to feet, again, from a smaller unit to a larger unit, so we are going to divide. In this case, we think about our conversion rate. We have 12 inches equal to 1 foot, and in this case, we have 144 inches equal to x number of feet. So we are going to cross multiply. 12 times x is 12x equals 144 times 1 equals 144. Divide both sides by 12, and we get x equals, in this case, 12 feet. So 144 inches are equal to 12 feet. All right, sample question number 3, we are going to see 6.2 miles is equal to how many feet? So in this case, if we look, we are going from miles to feet, which in this case, we're going from a larger unit to a smaller unit, so we are going to multiply. So let's think about our conversion rate. We have 1 mile is equal to 5,280 feet, and we would like to see 6.2 miles equal to how many feet? So we can cross multiply to solve. 1 times x just gives me x, and then we have 6.2 times 5,280. So if we did that math, 6.2 times 5,280, we are going to get 32,736 feet. And there is our answer. 6.2 miles equals 32,736 feet. Sample question number 4. We have 5 feet 8 inches is equal to how many inches? So we already have 8 inches here, so I'm going to hold that off to the end to remember that I'm going to add 8 inches since that's what I have. Now I'm trying to convert feet into inches. So if I think of my conversion rate, I know that 1 foot is equal to 12 inches. In this case, I have 5 feet, and I'm looking for how many inches that is. Again, cross multiply. So 1 times x equals x. 5 times 12 gives me 60. So right now, 5 feet is equal to 60 inches. But I cannot forget to add my 8 inches that we already had in addition to the 5 feet. So that gives me 68 inches. So my final answer is 68 inches. right, let's look at sample question number 5. A square has an area of 81 square feet. What is the area in square yards? All right, so let's actually draw this square out and see what information we can get. So I have my square here, and I know that according to this, it is 81 square feet. In a square, I know all 4 sides are equal. And to find the area of a square, I have to do side times side, which means I had to multiply the same number by itself to get to 81. So what number times itself gets you 81? Oh, that must mean 9 times 9. So I know each side length is 9 feet. But now we want to go for square yards. So I'm going to convert feet into yards. So I know that 1 yard is equal to 3 feet. And I have 9 feet, and I'm looking for how many yards this is. So I'm going to cross multiply. X times 3, that's 3x. 1 times 9 equals 9. Divide by 3, divide by 3. X equals 3 yards. So now if I redo this square, and instead of labeling it with feet, I label it in yards. So this is 3 yards, and this is 3 yards. If I did side times side, that's 3 times 3, which equals 9 yards squared. So my answer is 9 yards squared. Now the most important thing to learn from this problem, some of us might have jumped the gun and did 81 divided by 3 because there are 3 feet in a yard. But both sides were yards. So both sides that we used ended up having to be divided by 3, which is like dividing the whole number by 9. So we had to redraw our square using our new measurements that we converted to then find the area. This is the best way to make sure you do not make the mistake of only dividing once. Hope you got this one. This one was tricky. All right, it is your turn to go try these practice problems, to really work them out, to see what you can do. And I can't wait to continue working with you. Good luck. Hey y'all, welcome to another lesson with me, Brian. And today we're going to be covering standard to standard conversions with weight and mass. Hey everybody, welcome to Standard Conversions of Weight on the TEAS with me, Brian. Let's go right to the beginning. All right, our goals for this lesson is we will be able to convert between different units of weight measurement in standard form. Key vocabulary, when we talk about standard units, those are the official units that we use in the United States. When we talk about our standard units for weight, know that we do have pounds and ounces, and we also have tons. So what I want to make sure is that you do know the abbreviations that we use. Pounds, you're going to see LBS. For pounds, ounces will be OZ, and we don't really use an abbreviation for tons. So know that if you do see LBS, that does mean pounds. OZ does mean ounces. So in this case, when we convert, we are going to change between differently sized units of measure without changing the actual weight itself. We're not changing how much something weighs, just how we display how it's been measured. When converting from a smaller size unit to a larger size unit, we are going to divide. So in this case, if we look, we have ounces are our smallest unit and tons are our largest unit. So if we're going to go from ounces to pounds, we divide by 16, since there are 16 ounces in a pound. And if we're going to go from pounds to tons, we divide by 2,000 since there are 2,000 pounds in 1 ton. 2. When converting from a larger size unit to a smaller size unit, we are going to multiply. In this case, again, we're starting with tons, which is our largest unit, and we're going to ounces, which is our smallest unit, meaning 1 ounce is smaller than 1 ton. We think about that in terms of how much one of each of these is worth. To go from tons to pounds, we'd multiply by 2,000 since there are 2,000 pounds in 1 ton. To go from pounds to ounces, we would multiply by 16 since there are 16 ounces in 1 pound. All right, key point number 3. These conversions are just going to be ones that we have to memorize. There's only 2 for measurement of weight in the standard form. 16 ounces is equal to 1 pound. 2,000 pounds is equal to 1 ton. Now, the only thing to be careful of is that pound ounces and liquid measurement ounces, we do use the same word. So do know the difference that 16 ounces deals with weight. 8 ounces deals with liquid measurement, and we're only dealing with weight measurement here. Why do we do this? So oftentimes measurements are not given in the correct format or units that we need. So we need to convert between different units of measure. Conversion methods are the same for standard and for metric units, so we can internalize how to change between different units of measurement. When in doubt, also, we can always set up a proportion if you need to. We're going to jump into our sample questions. We did go over the 2 conversions. See if you can remember those conversions while you're working through here and try them on your own. If you do need to walk through, of course, you can walk through all of these with me as well. Totally up to you. Sample question number 1. 38 ounces is equal to how many pounds? So here are one of the things that we start to think about. We know that we are going from ounces to pounds, and there are 16 ounces in a pound. We're going from the smallest unit to the largest unit, so we're going to divide. One way that we can also write this, we know that 1 pound, lb, is equal to 16 ounces. And we are looking for the x number of pounds is equal to 38 ounces. Now, let's go through how we solve this. So we do cross multiplication. We get 16x is equal to 38. So if we divide this, we get 38 divided by 16, and we get x is equal to 2.375. Now, this is 2.375 pounds. Now, here is the biggest mistake that you are going to make. It happens a lot, so make sure that you know to avoid this mistake. Someone is going to tell you that it's 2 pounds, 3.75, or 375 ounces here, or something like that. What you have to remember is that it is 0.375 pounds, and there are 16 ounces in a pound. So if we take 16 ounces and we multiply it by 0.375, that'll tell us how many ounces are left. Remember, decimals are out of powers of 10, but pounds are made up of 16 ounces. So we cannot just say 3.75 or round up to just say 4 ounces. That's not how that works. So if we did 16 times 0.375, that is equal to 6. What does that mean? 6 ounces. So if you see this, it's really 2 pounds and 6 ounces. Another way to think about this is if you took 38 and divided it by 16. 16 goes into 38 twice. That gives me 32, subtract, and we have 6 left over. That really means 2 pounds with 6 ounces left over. Be very careful, understand exactly what you found, and do not make that silly mistake. Sample question number 2. We have 6,500 pounds is equal to how many tons? Now, this one might be a little different. We think that we're going from pounds to tons. So we are going from a smaller unit to a larger unit. We're going to divide. And we know that there's 2,000 pounds in a ton. So I'm going to take, I have 2,000 pounds is equal to 1 ton. I have 6,500 pounds. And that's going to be equal to how many tons? If we cross multiply, we get 2,000 x is equal to 6,500. Divide both sides by 2,000. And we are going to get x equals 3.25 tons. Now, this is where it's more acceptable that where you would see a decimal. So 6,500 divided by 2,000 does give us 3.25. This is where you'd see 3.25 tons and not 3 tons and 500 pounds. Why? I couldn't really tell you. It's just how we have started to talk about weight, or how we've decided to talk about weight. So know that this would be more likely that you would see a decimal answer in this form, but you're more likely to see pounds with the actual ounces themselves when you do pounds to ounces or ounces to pounds. We have 4.5 pounds equals how many ounces? So we're going from pounds to ounces. We're actually going from a larger unit to a smaller unit, so if it helps you, that is going to be multiplication. But if you're not sure, you can still use your proportions. So I know that 1 pound is equal to 16 ounces, and we have 4.5 pounds, and that's going to be x ounces. So if I cross multiply and solve, 1 times x is equal to x, and then I have 4.5 times 16, and that gives me x is equal to 72 ounces. Now, if you knew this, you could have jumped right in to the 4.5 times 16, and that would have been fine as well. But setting up a proportion is going to be helpful for when you do metric to standard as well, so it is good practice. All right, sample question number 4. We have 3.75 tons are equal to how many pounds? Again, we are going from tons to pounds, larger unit to smaller, so we are going to end up multiplying. But let's use our conversion rates. So we know that 1 ton is equal to 2,000 pounds. And we have 3.75 tons is equal to how many pounds? So let's multiply. 1 times x is equal to x. 3.75 times 2,000, 2,000 times 3.75 is going to give me 7,500 pounds. So x is going to be equal to 7,500 pounds. All right, we have our final question here. A newborn baby weighs 8 pounds, 9 ounces. What is the weight of the baby in ounces? So if we look here, we have 9 ounces, and we need this in ounces. So 9 ounces is already there. So we know whatever happens, we have to make sure we add 9 ounces at the end, because we don't have to convert ounces into ounces since it's already in ounces. But we do have to convert this 8 pounds into ounces. So notice we are going from pounds to ounces, so we are going to multiply. But if we're not sure how to do that, let's set it up as a proportion. So we know 1 pound is equal to 16 ounces, and we have 8 pounds and x ounces. So we can cross multiply. 1 times x is equal to x. 8 times 16 gives me 128 ounces. But notice we're not done yet. That was just the 8 pounds. We do have to add on the 9 ounces that were already ounces. So that was the additional. 8 plus 9 is 17. 1 plus 2 is 3. 137. So the final answer is 137 ounces. All right, there you go. You have it. We did our standard to standard conversion of weight. It is your turn to go practice these. Best of luck, and I look forward to working with you real soon.
Hey everybody, welcome back. So wonderful to have you. Today we're going to be doing metric to standard conversions, dealing with distance.
Hey everybody, this is Brian here at Nurse Hub, and we are going to be going over metric to standard conversions on distance. So let's get it started. Our goals for this lesson is we will be able to convert between standard and metric units of distance measurement. Our key vocabulary, remember the first one is conversion, which is to change from one unit of measure to another without changing the actual distance. So number 2, we have meter, and that's going to be the basic unit of distance measurement. So if we looked again at King Henry died unexpectedly drinking chocolate milk, we are focusing on our units today, which are meter, liter, gram, and in this lesson, we're focusing on meter only. Key points. You can only convert across like forms of measure. So in this case, we are dealing with distance. So we're only going to be converting from metric distance to standard distance, not between any of the others. Again, remember when we are converting from a smaller size unit to a larger unit, we are going to divide. So as you see here, we are going from milli to deci, milli being the smallest unit, kilo being the largest. For every step that we take to the right, we divide by 10. Since we would be taking 2 steps to the right, dividing by 10 twice, that is the same thing as dividing by 100. Now, if we were going to look at our standard units, if we were going to go from inches to feet, we would divide by 12 because there are 12 inches in a foot. If we were going from feet to yards, we would divide by 3 since there are 3 feet in a yard. And if we were going to go from feet to miles, we would divide by 5,280 since that is how many feet there are in 1 mile. On the opposite end, when we're converting from a larger size unit to a smaller unit, we are going to multiply. So if we look at metric, if we're going from kilo to our unit, which in this case is meters, we can see that we have to take 1 jump, 2, 3. Since we're going from the largest unit or a larger unit to a smaller unit, we are going to multiply. Since we move 3 steps to the left, multiplying by 10 each time, it is the same thing as multiplying by 1,000. If we were going to look at standard units, if we're going to go from miles to feet, that is multiplying by 5,280 because there are 5,280 feet in a mile. Yards to feet, we multiply by 3 since there are 3 feet in a yard. And if we're going from feet to inches, we multiply by 12 since there are 12 inches in 1 foot. 4, if you forget some of the conversions, see if you can remember one and use that conversion to get to the one you need. So for example, we're going to go from 2 feet to centimeters, but I only remember that 1 inch is equal to 52.54 centimeters. So let's look what we could do. Notice that this is the conversion rate that I remember. I already have centimeters here, but that means that I need to get feet into inches. So if I remember, if I'm looking for 2 feet is equal to how many inches, but I remember that 1 foot is equal to 12 inches. If I cross multiplied, I would get x equals 24. So right now, I have 24 inches. 2 feet are equal to 24 inches. I can now use my conversion rate. If I remember, like 1 inch is equal to 2.54 centimeters, and I have 24 inches equals x centimeters, I can cross multiply. X is equal to 24 times 2.54. And that gives me 60.96 centimeters. Notice how I was able to use a conversion I knew to help me with a conversion I didn't know. All right, if we look here, these are our basic conversion rates. No specific easy way to remember them, but it may help to remember one and convert down the road as necessary. So if you need to pause this to create your own flashcards or something, do that now. Refer to this, come back to it if you need to. Key point number 6. You can also set up proportions and use cross multiplication to solve. We did get into this before, but remember the one thing that you do need to remember, if you have inches and you have centimeters, you could be remembering that conversion rate. So if you have your conversion rate, which we know is 1 inch is equal to 2.54 centimeters, I then put inches also underneath to create my proportion is equal to x centimeters. I can then cross multiply to check. So 1 times x is just equal to x. 14 times 2.54. That is equal to 35.56 centimeters. So we can use cross multiplication to solve. It is a fail-safe way that will work regardless of the conversion that you are working through. Why do we do this? Again, the U.S. is one of those few countries that measures using our standard form of mass, weight, and measure. Things like inches, feet, yards, and miles. Therefore, many measurements are going to come in using the metric system. So the ability to convert back and forth between these different units of measure is going to be essential to ensure patient safety and precision. We're going to jump into our sample questions. See if you can do these with the conversions that you've tried to memorize. If you do need to work through practicing how to set up proportions, you can also do these with me as well. It is your time, totally up to you how you handle these sample questions. All right, sample question number 1. We are going from 5 kilometers to how many miles? For these questions, we are going to use the appropriate conversions. So you get to see how those work in real time. As we look here, we know that we are going from kilometers to miles, so we're going to use the conversion rate that involves kilometers and miles. In this case, I know that 1 mile is equal to 1.6093 kilometers. The problem above, I see that I'm missing miles, so I have x miles is equal to, and I know I have 5 kilometers. So now I can cross multiply and solve. Again, I like to keep the variable on the left, so I have 1.6093 miles, or actually we're going to leave that off for right now, is equal to 1 times 5 is just 5. Our x is not forgotten here. That is my fault for missing it. And then we divide to solve. So we're going to divide both sides by 1.6093. And we're going to get x is equal to 5 divided by 1.6093. And that gives us 3.1069. It continues, so let's round off to our second digit. That's the 0. We see the 6. 6 tells the 0 to round up 1. So we get x is equal to 3.11 miles is our answer for number 1. All right, sample question number 2. 17 centimeters is equal to how many inches? So we know that we're going to go from centimeters to inches. So our conversion rate here is going to be 1 inch is equal to 2.54 centimeters. In this case, we do have 17 centimeters, and I'm missing x for inches for how many centimeters that is equal to. So here we're going to cross multiply again to solve. I like to do variable first, so that's 2.54x equals 1 times 17 is equal to 17. To solve for x, we divide both sides by 2.54. That leaves us with x is equal to 17 divided by 2.54, 6.692. I only use 3. You'll see that there's digits that go on a while, but we're just going to round it off to the second place value after the decimal. So 9, we see a 2, tells the 9 to stay the same. So it equals 6.69 inches. Sample question number 3. 25 meters is equal to how many feet? So again, we see meters and we see feet. So that's the conversion rate that we're going to need to use. So we have meters. I have 1 foot is equal to 0.3048 meters. I have my conversion rate, and now I look at the problem I have above. So I have 25 meters, and I'm looking for X amount of feet. So I can cross multiply to solve. Variable first, just to make it easier, 0.3048 equals 1 times 25, which is 25. The x is here. I keep doing that. So we're going to divide both sides by 0.3048. And we are left with x is equal to 25 divided by 0.3048 is 82.020. Remember, second place value, we do see a 0, so it's just going to stay the same, 82.02 feet. Sample question number 4. 86 millimeters is equal to how many inches? Now, if you notice, I have millimeters to inches, but that's not one of my conversions that I have memorized. So I can do a few things. But I do have a centimeter to inch conversion. So if I want to use this conversion rate, where I have 1 inch is equal to 2.54 centimeters, I know I'm missing X amount of inches. That means I have to have centimeters on the bottom. So I have to go from millimeters to centimeters. And if I think about King Henry died unexpectedly drinking chocolate milk, I'm going from millimeters, the smallest unit, to centimeters. So I have to divide 86 by 10. 86 divided by 10 is just going to be equal to 8.6, and that's centimeters. So we had 86 millimeters divided by 10, since we made one jump, is 8.6 centimeters. So I'm going to put that here. Now I can cross multiply to solve. X times 2.54 is 2.54x equals 1 times 8.6 centimeters. Divide both sides by 2.54. And we get x is equal to 3.385. Let's take the second place value after the decimal. We have an 8, we see a 5. Tells that 8 to turn into a 9. Everything to the left stays the same. So we have 3.39 inches. Awesome. That one was a little tricky, so I hope you got it. Sample question number 5. During a triathlon, a participant must swim 1.5 kilometers, bike 40 kilometers, and run 10 kilometers. What is the total distance traveled in miles? So if we have a participant that must swim 1.5 kilometers, 40 kilometers, and 10 kilometers, we're looking for that total distance traveled in miles. But first, we have to find the total distance in kilometers. And we do that, we have to add 1.5 plus 40 plus 10. So if we did 40 plus 10, that gives us 50, plus 1.5 gives us a total of 51.5 kilometers. But the problem didn't stop us there. It wanted the distance in miles. So we have to think of our conversion rate. Our conversion rate is we're going from 1 mile is equal to 1.6093 kilometers. Now we're looking for X miles out of 51.5 kilometers. I now have my proportions set up so I can cross multiply. X times 1.6093, that's 1.6093x, is equal to 1 times 51.5 is 51.5. I'm going to divide by 1.6093, divide by 6093, and x is going to be equal to 51.5 divided by 1.6093, and that gives me 32.001. So we're actually just going to round that to 32.00 for miles, which could also just be 32 miles. All right, sample question number 6. Children are required to run the 50-meter dash. Unfortunately, the gym teacher only has a standard tape measure. How many inches are in 50 meters? So we can do a few things. So we know that we have 50 meters, and we want to turn those into inches. But if we look at our conversion rate, we don't really have that. But what I do have in this case is I do have the conversion rate that 1 foot is equal to 0.3048 meters. So what if I found out how many feet are in meters? Because I can convert feet to inches fairly easily because there are 12 inches in a foot. So let's see how many feet then are in 50 meters. So let's cross multiply to solve. So I get 0.3048. X is equal to 1 times 50 is 50. Solve for x. So we divide both sides by 0.3048. And x is equal to 50 divided by 0.3048 gives us 164.041. If we rounded that off, 164.04 feet. But our question did not ask for feet. It asked for inches. So if we do want to set up another conversion, we have our conversion rate where we know that 1 foot is equal to 12 inches. In this case, we have 164.04 feet, and we're looking for x inches. So let's cross multiply once more. X times 1 equal to x. 12 times 164.04 is going to give us 1,968.48 inches. So that is sad for that gym teacher who has a very, very, very long tape measure and does not have 50 meters. So unfortunately, that's going to be a very long time for that gym teacher to measure everything out. All right, you have come to the end of another conversions lesson. So good luck. Go try these out. Do the best you can to remember your conversions, and I cannot wait to see you soon. Hey everybody, so good to see you. It's me, Brian, and today we're going to be working on metric to standard conversions of liquid measurement. Hey everybody, welcome to metric to standard conversions of liquid on the TEAS with me, Brian. So we are going to jump into one of the lessons that people request the most to learn about. Our goals, we will be able to convert between standard and metric units of liquid measure. So this whole video is going to just be about liquid measurements. First key vocabulary word is the word conversion, and that means we're going to change from one unit of measure to another, but we're not going to change the actual amount of liquid being measured. Just how we say how much we have. That's the only difference that we are making, is by saying how much we have. 2 is liter. That is going to be the basic metric unit of liquid measurement. So what that means is where that shows up. If you've talked about King Henry died unexpectedly drinking chocolate milk, we talk about our units. Our units are always liter, meter, or gram. And for this lesson, we are going to be focusing on liter since that is the liquid measurement form. Key points. You can only convert across like forms of measure, so distance to distance, liquid to liquid, mass and weight to mass and weight. So make sure that whatever you're converting between, they are measuring the same types of things. 2, when converting from a smaller unit to a larger unit, you divide. Now, if you remember what I just talked about with King Henry died unexpectedly drinking chocolate milk, we do have a largest unit, which is kilo, to our smallest unit, which is milli. I like to put it this way because I like to read it left to right, smallest getting larger, just like a number line. It has smaller numbers to the left, larger numbers to the right. So when you're converting from a smaller unit to a larger unit, you divide. In this case, you can see we're going from milli to deci, which takes 2 steps, which means we're dividing by 10 each step. Same thing as dividing by 100. If we looked at the standard, we do have our smallest unit is ounces to our largest unit, which is gallons. To go from ounces to cups, we divide by 8, since there's 8 ounces in a cup. There's 2 cups in a pint, so we would divide by 2. 2 pints in a quart, so we divide by 2. 4 quarts in a gallon, so we would divide by 4. On the opposite end, if we're going from a larger size unit to a smaller unit, we're going to multiply. We talked about how kilo is the largest and milli is the smallest. In this case, you can see we're going from kilo to our units, which requires 1, 2, 3 jumps, multiplying by 10 each time, which is the same thing as multiplying by 1,000. If we did that in our standard units, if we were going from gallons to ounces, we could multiply times 4 to get to quarts, times 2 to get to pints, another times 2 to get to cups, and another times 8 to get to ounces. So if we're going from a larger unit to a smaller unit, we will multiply. Key point number 4. So these are the following conversions that are going to be used in converting from standard and metric units of liquid measurement. So we see 1 ounce is going to be equal to 30 milliliters. If you put this into Google and you looked at how many ounces or how many milliliters equal 1 ounce, you're going to get something like 29.7 something, and it continues. For nursing and the nursing industry and healthcare, it will be 1 ounce is equal to 30 milliliters. That's why all of these other conversions are also rounded off as well. So there's 8 ounces in a cup. That's why 8 times 30 is 240. That's why there's 240 milliliters in 1 cup, and working its way up here. So these are the correct conversions to use. 5, if you blank on a conversion, you can use another to help. So how many milliliters are in 2 pints? If all I remember is 1 ounce equals 30 milliliters, and I don't remember how many milliliters are in 2 pints, I can use whatever conversion I do remember to help. So in this case, if I remember 1 ounce is equal to 30 milliliters, all I have to do is turn 2 pints times 2 cups per pint. That tells me that's 4 cups times 8 ounces in a cup. Tells me that 2 pints is equal to 32 ounces. Now that I've made everything into ounces, I can use the conversion I know. So know that you don't have to remember every single conversion, but if you do remember one between metric and standard, and you know your gallon man and you know your standard conversions for liquid, then you're totally good to go. Number 6, you can set up proportions to solve, but make sure you use the appropriate conversions. So how many liters are in 4 gallons? And we have the 1 gallon is equal to 3.84 liters here. So if we were going to do this, remember, we're going to set up 1 gallon. We're going to set up our conversion rate, 3.84 liters. Now, when we do a proportion, we're putting the same thing across an equal sign. And by same thing, up top has to be gallons. We have to match our units, and liters on the bottom. If you put liters on top, just make sure it's on top for both. It's still going to be the same idea. Then we fill in what we have from the problem is 4, and I would put 4 right here. This would allow me to then solve for x. X liters is what we're looking for. Then I could cross multiply and solve. 1 times x is x, and that's equal to 3.84 times 4, which would give us 15.36 liters. All right, making sure you include those units. Proportions are going to be incredibly helpful. Now, why do we need to know this? So the United States is one of the few countries using our standard form of liquid measurement. Therefore, many measurements are going to come in using the metric system. So the ability to convert back and forth between different units of measure is going to be essential to ensure patient safety and precision. And in fact, in nursing school, you're going to have an entire math for meds, and this conversion rate are going to be very important for that course and for when you're actually a nurse and need to do this with medications. So we're going to jump into the sample questions. For these, we are going to use the standard conversions that were given, the standard to metric conversions that were given earlier. If you need to memorize those, go back and check. If you can only memorize one and your answer is off by a little bit, just check to see what you followed and make sure that you have the correct conversions. All right, so sample question number 1, we have 5 gallons is equal to what amount of liters? So first, we're going to look up our CR, or our conversion rate. What I notice is I have gallons and I have liters. We have 1 gallon is equal to 3.8 liters. And in this case, I just match up what we have. In this problem, we have 5 gallons and we're missing liters. So now I have my proportion set up. I can cross multiply and solve. 1 times x is x. 5 times 3.8 gives us 19 liters. So 5 gallons is equal to 19 liters. Sample question number 2. How many cups of water are in 1,185 milliliters? So what we're getting here is we're trying to go from milliliters to cups, which tells us that there has to be some sort of conversion rate. Now we can do this a few different ways. One way is if I remember that 1 ounce is equal to 30 milliliters. This question is dealing with cups, so I can create my own conversion in case I don't remember it. I know that there's 8 ounces in a cup, so if I do 1 times 8, I can do 30 times 8, which tells me that 1 cup is equal to 240 milliliters. So if I'm looking for how many cups of water are in 1,185 milliliters, we can do it this way. I know that 1 cup is equal to 240 milliliters, and we're looking for x cups out of 1,185 milliliters. My signs, so my units match across, milliliters on the bottom, cups on the top. I set up my proportion and solve. Now, if some of you knew to immediately go to division, that's great. Proportions really help if you ever get stuck on, am I multiplying or am I dividing? The proportion will set that up for you and you don't even have to think. So we can cross multiply. 240 times x gives us 240x is equal to 1 times 1,185, 1,185. Now you see here this would have been a division problem. It is a division problem. So we didn't even have to think about it. The problem told us what to do. That's why I suggest proportions. So we solve this and we get 1,185 divided by 240 is going to give us 4.938. Now, this question did not ask us to round, and it did end up nicely after the thousands place. So without rounding, I would suggest that this would be something we could answer or something you would see. But as always, since each question can ask you to round to a different place, just pay attention to what the question may ask you when you're taking your test. Sample question number 3. A barrel of wine holds 60 gallons. How many liters is that? Now, in this case, we can do a whole bunch of things. But what we're looking for is going from liters to gallons or gallons to liters, right? That's what we're working between. That's what we need a conversion for. So let's see what we can solve here. Now, what we can do is we can write our own chain of conversions if we want. So for example, I don't have this conversion memorized, but I know 1 ounce is equal to 30 milliliters. We did this before, but I know that I can get myself to 1 cup is equal to 240 milliliters. So there's 8 ounces in a cup, so multiply both by 8. That's going to get me there. So the next one is going to be pints. So if I'm going to work my way to pints, there's 2 cups in a pint, so I'm going to multiply this by 2. So I know 1 pint is equal to, let's keep this color-coded, 480 milliliters. I then remember there's 2 pints in a quart. So I'm going to multiply both by 2, and that's going to tell me that 1 quart is equal to 960 milliliters. So notice that by just remembering 1 ounce equals 30 milliliters and knowing my standard units, I could build my way up to get to whatever conversion I need. So final is I know that there's 4 quarts in a gallon. So I know that 1 gallon is equal to times 4. We get 960 times 4 is 3,840 milliliters. So let's look here. We have one that's 60 gallons, so we can do a few things. Right now, we have 1 gallon is equal to 3,840 milliliters. The question is talking about liters. So let's turn milliliters into liters. Now, if you remember your conversion chart for metric, you know that milli is 3 spots away from units, which are liters. So if I take 3,840, divide it by 1,000, because we're going from a smaller unit to a larger, we get 3.84 liters. So we know that 1 gallon is equal to 3.84 liters. Now we can set up our proportion. If you see what to do next, amazing. But in case we're not sure, we can always use a proportion. So 1 gallon is equal to 3.84 liters, and we set that equal to, we have 60 gallons over x liters. Now we cross multiply and solve. 1 times x is just x, is equal to 3.84 times 60, which gives us 230.4 liters. So know that whatever you're given, as long as you have some way of getting to the conversion that you need, you're more than fine. We did that with just one standard to metric conversion, but we knew our standard conversions, our standard liquid from ounces to gallons. So knowing how to convert within one system is going to be very helpful for when you have to convert between both.
All right, sample question number 4. Beverly has consumed a bottle of water that contains 4 cups and 3 ounces of water. How many liters of water did Beverly consume? So here is our issue. When I look at this, I notice we have 4 cups and 3 ounces. I'm not going to make 2 separate conversions. So for my step 1, I'm going to convert everything to the smallest size unit so that this way I don't have any decimals. So I'm going to turn 4 cups and 3 ounces into just ounces. So I'm going to first do that conversion. Now I know that 1 cup is equal to
8 ounces. So if I'm looking for 4 cups, and how many ounces that is, 1 times x is x, 4 times 8 is equal to 32. So I know that 4 cups is equal to 32 ounces. Plus the additional 3 ounces, because we had 4 cups and 3 ounces, means that I have 35 ounces of water, or Beverly has 35 ounces of water that was consumed. Now we want to know, how many liters is that? So first, I don't have an ounce to liter conversion rate memorized, but I do have my ounces to milliliters. So I'm going to go to milliliters because I don't have a conversion rate memorized. So I have 1 ounce is equal to 30 milliliters. And if I have 35 ounces, how many milliliters is that equal to? So I'm going to cross multiply. 1 times x is equal to x. 35 times 30 is equal to 1,050 milliliters. But our question didn't ask for milliliters. Our question asked for liters. So if I think about what we talked our conversion rates, so that's King Henry died unexpectedly drinking chocolate milk, I'm going from milliliters to units because it asks for liters, and liters is one of our basic units. Now I'm going from a smaller unit to a larger unit. So every jump I make, which is 1, 2, 3, I'm going to divide by 10. Remember, when we divide by 10, it's like moving our decimal point 3 times to the left. So each time that you divide by 10 is moving the decimal point once to the left to make your number smaller. And because we're doing it 3 times, we'll move our decimal point 3 times. In 1,050, our decimal point goes at the end of the number. We're going to move it once, twice, 3 times, and our decimal point now goes here. So 1,050 milliliters is going to equal 1.05 liters. We were able to get rid of this 0 because when it was here at the end of the number after the decimal, it did not provide any value, so we could get rid of it. Therefore, our answer is 1.05 liters. That's again how we can use conversion that we do know to help us solve for answers for conversions that we may not know. All right, we've come to the end of another lesson on conversions. It is your turn to go practice, to go try these out. I wish you the best of luck, and I cannot wait to see you soon.
Hey y'all, welcome to another math lesson with me, Brian, where we're going to cover metric to standard conversions dealing with weight and mass. Let's go.
Hey everybody, welcome to metric to standard conversions of weight and mass on the TEAS with me, Brian. So let's jump right in. All right, our goals for today's lesson is we will be able to convert between standard and metric units of weight or mass measurements. Our key vocabulary word, when we talk about conversions, that means we're going to change from one unit of measure to another without changing the amount of weight or mass that is measured. So we're just changing what they look like, changing the numbers that were used, but the amount itself is not changing. 2 is gram. This is going to be the basic unit of mass measurement. So if you ever heard the word units or King Henry died unexpectedly drinking chocolate milk, this is the unit, which would be in the middle. Key point number 1, you can only convert across like forms of measurement. So we can only convert between distances for standard to metric, liquid to liquid, weight and mass to weight and mass. So for example, we're not going to go from pounds to milliliters. It's just not going to work. They're not the same. Key point number 2, when you're converting from a smaller unit to a larger unit, you are going to divide. So, for example, if we were going to go from milligrams to decigrams, so you see that we started off at milligrams and we're going to decigrams, we took one step from milli to centi, and the prefixes to deci, we divided by 10 each time. Dividing by 10 each time, as you can see, is the same thing as dividing by 100. Same for standard. If we were going to start with ounces and go to tons, we would first go ounces to pounds. We would divide by 16, since there are 16 ounces in a pound. To go from pounds to tons, we would divide by 2,000, since there are 2,000 pounds in a ton. Once you remember this metric conversion, this order, totally fine. You may have heard me say King Henry died unexpectedly drinking chocolate milk. That would be going in this direction, as kilo is the largest unit and milli is the smallest. As long as you know that in that phrase, the K does stand for the largest unit to smaller, it all depends on how you decide to write it. I prefer to write the smallest on the left, largest on the right, but same rules apply. Same idea when converting from a larger size unit to a smaller size unit, we're going to multiply. So in this case, you can see that we're going from kilo to just our units, which in this case would be grams. We would take 1, 2, 3 steps, which requires us to multiply by 10 3 times, or if you'd like to do it in one step, 10 times 10 times 10 is the same as multiplying by 1,000. Same thing with standard. If we were going to tons to pounds, we'd be multiplying by 2,000, since there are 2,000 pounds in a ton. And to go from pounds to ounces, we'd be multiplying by 16, since there are 16 ounces in a pound. 4, if you forget some of the conversions, see if you can remember one of them and use that conversion to get the one that you need. So for example, we said 4 pounds is equal to how many grams? I have no idea what that conversion is. I did not remember. But what I do know is that 1 kilogram is equal to 2.2 pounds. So if I set this up, I'm going to say, what if I put pounds into kilograms? So I want to say, how many? There's 4 pounds is equal to how many kilograms? Well, if I know that 1 kilogram is equal to 2.2 pounds, and I set up a proportion, that means how many kilograms are equal to 4 pounds. So from here, if I just slid this over, I could cross multiply. So x times 2.2 is 2.2x is equal to 4 times 1 equals 4. Divide both sides by 2.2. And I get x is equal to, let's hit the division, 4 divided by 2.2 is 1.818. And what does that mean? Kilograms. Now remember, I'm going from kilograms to grams. If I look back, kilograms to grams, if I think King Henry died unexpectedly drinking chocolate milk. If I'm starting at kilograms, that's a larger unit, and I'm going to grams, a smaller unit, that's times 10, times 10, times 10 for each. So if I did 1.818 times 1,000, I get 1,000. Ooh, that's a weird comma. 1,818 grams. Notice I could do that without remembering the pounds to grams conversion. Sometimes this is going to happen. You're going to need backup plans to help you in case you forget. Here are the conversions that you may need to memorize if you can. 1 ounce is 28.3 grams, 1 pound is 454 grams, 2.2 pounds is 1 kilogram, 35.3 ounces is equal to 1 kilogram. Now, it may be beneficial to memorize all of these, or just one just in case. The only thing I can say is that sometimes when you round off numbers, you may be a little off. So look at your answer choices, see how close you got. 6, you can set up a proportion and use cross multiplication to find missing amounts. I did start to show you that before, so let's just set this up. I know 8 kilograms is equal to how many pounds? So I use the conversion I know. I know that 1 kilogram is equal to 2.2 pounds. And I'm trying to figure out 8 kilograms is equal to X pounds. Notice here, pounds are on the same side, kilograms are on the same side. I have my conversion on the top and what I'm trying to find on the bottom. Now I can cross multiply. So I like to always multiply the X first. 1 times X is just X is equal to 8 times 2.2. So if we put that in, we get 17.6. And what we were looking for, pounds, so 17.6 pounds. We cross-multiplied, we solved. Why do we do this? So the United States is one of the few countries that measures using the standard form of weight and mass. So therefore, many measurements are going to come in using the metric system. The ability to convert back and forth between different units of measure will be essential to ensure patient safety and precision. So let's jump into our sample questions. We are going to use the appropriate conversions for each problem here, but remember, I showed you what to do in case you do not remember those conversions. I highly suggest trying each of these questions, trying to memorize the conversions that you know so far. The more practice you have trying to recall those, the better you're going to be later on if you have to recall that information. Sample question number 1, 4 kilograms is equal to how many pounds? So we are going from kilograms to pounds. So I'm going to look at my conversion rate. And I know my conversion rate is going to be 1 kilogram is equal to 2.2 pounds. And in this case, I'm looking for 4 kilograms are equal to X pounds. So I'm going to cross multiply to solve. Variable first, 1 times X is just X. And then I do 4 times 2.2, which is going to give me 8.8, and we were looking for pounds. So 4 kilograms is equal to 8.8 pounds. Sample question number 2. We have 56 grams is equal to how many ounces? So we first then look at our conversion rate that we're going to use. We are going from grams to ounces, so that's what we're going to think. Either way we put it, I know that, let's do it this way, 1 ounce is equal to 28.3 grams. That's my conversion. Notice how grams came first in the problem though. I'm still going to line it up. That was 56 grams, because notice we have the same units, and I have X ounces. Now I'm going to cross multiply and solve. X times 28.3. So I get 28.3 is equal to 1 times 56 is 56. And I forgot the X here. I went back, do not worry. And I'm going to solve for X. So I'm going to divide both sides by 28.3. which leaves me with X equals, and this number continues to go on, so I'm just going to round off to the second digit, all up to what the problem says or what your answer choices say. Usually it's the second or third, so I see this as a 7, I see an 8 behind us, which tells us to round up, so I'm going to go 1.98 ounces. Sample question number 3. 63 pounds is equal to how many kilograms? So I look, I know I'm going from pounds to kilograms. So I'm going to look at the conversion rate that I know. So if I look at my conversion rate, I have 1 kilogram is equal to 2.2 pounds. And look what I have. So I have 63 pounds. And I put pounds underneath my conversion rate where the pounds are. And I have X kilograms. Cross multiply and solve. X times 2.2. That's 2.2x is equal to 1 times 63 is 63. We divide both sides by 2.2. Put that into our calculator and we get 63 divided by 2.2. Again, we have 28.636. Let's do a third. Let's round it off. 6 tells a 3 to round up. 28.64. And in this case, kilograms. Sample question number 4. 12.5 kilograms is equal to how many ounces? In this case, we did remember that there are, in our conversion rate, which I'll just call CR, we have 35.3 ounces is equal to 1 kilogram. So now I put in what I have. I have 12.5 kilograms is equal to X ounces, cross multiply and solve. So I have X times 1 is just equal to X. And then I have 35.3 times 12.5. So it's 35.3 times 12.5. And that's going to give me 441.25 ounces. Again, very similar to ratios and proportions, because if we set up our proportions, it becomes much easier to understand what to do. Sample question number 5. Tan is at the gym and sees that each dumbbell he is carrying weighs 6.5 kilograms. What is the weight of each dumbbell in pounds? So we know that I have 6.5 kilograms and I want that in pounds. So I'm using a pounds to kilograms conversion rate. So my conversion rate is equal to, I have 1 kilogram is equal to 2.2 pounds. And in this case, I have 6.5 kilograms and I do not know the pounds. So I'm going to cross multiply. X times 1 is equal to X. Then I'm going to multiply 6.5 times 2.2. And I'm going to get 14.3. Some of you may have 14.30. Both are the same thing. Pounds. If you have a multiple choice answer, see which one is there. If it's a fill-in, both of these should also be accepted. All right, there you go. You've made it through your first or one of your many lessons where you are converting between metric and standard. It is your turn to go practice these, try them out. Remember, if you can just have one of these memorized, it'll be easy. It may take more steps, but you put way less pressure on yourself if you have that backup plan. All right, well, go forth, and I cannot wait to work with you again. Good luck. Hey everybody, welcome to another math lesson here at Nurse Hub. So wonderful to have you, and today we're going to be working on converting between Fahrenheit and Celsius. Hey everybody, welcome to Fahrenheit and Celsius conversions on the TEAS math course with me, Brian. So let's get our lesson for today started. Our goal is that we will be able to convert between Fahrenheit and Celsius units of temperature measurement. Key vocabulary for Celsius, that's a unit of measure for temperature, where it does use bases of 0 and 100 to determine 0 degrees Celsius is the freezing temperature, and 100 degrees Celsius is when water starts to boil. For Fahrenheit, that's a unit of measure to record temperature in the US. That's mainly where it's used. Where we use 32 degrees Fahrenheit is freezing, and if we're going to do a boiling temperature, it would be 212 degrees. So just wanted to show you the differences in the basic temperatures for freezing and boiling for Fahrenheit and Celsius. When we convert, we're going to change from one unit of measure to another without changing the actual temperature. So we're just showing you what one temperature would be like in the other form of measurement, but if you were outside, it would still feel the exact same. Our conversions here are they have to be memorized. So if you want to do degrees Celsius, you want to figure out degrees Celsius from Fahrenheit, it is degrees Fahrenheit minus 32 divided by 1.8. Or to go from Fahrenheit to Celsius, we take the Celsius degrees, multiply by 1.8, and add 32. So these are our two formulas. If you can only remember one, that is totally okay. So what I want you to think about is we can use our idea of algebra to help us solve. So say I want to go actually from Fahrenheit to Celsius, and this one is telling me Celsius to Fahrenheit. We can treat this like an algebra equation, where first thing I would do is subtract 32 from both sides. So I'd have Fahrenheit minus 32 is equal to Celsius times 1.8. Then I would be able to divide both sides by 1.8. That cancels out. So I'd have Fahrenheit minus 32 divided by 1.8 is equal to Celsius. So even if you only remember one of them, you can use it to help you get the other. So why do we do this? So the United States is one of the few countries that measures using Fahrenheit for temperature. Therefore, many measurements are going to come in using Celsius. So the other form of recording temperature, so being able to convert back and forth between those different units of measure is going to be essential, especially to understand if something's too hot, too cold, like where does it lie on that spectrum. So we are going to get into our sample questions, so feel free to do those with me on your own or anywhere in between. So let's take 34 degrees Celsius and we're going to go to Fahrenheit. So what I know is if I take my degrees Fahrenheit is equal to, that's degrees Celsius times 1.8 plus 32. Now, how did I know to use this one? Because I had degrees Celsius and I was solving for degrees Fahrenheit. So this formula had degrees Fahrenheit on its own. So now I'm just going to plug in. So I'm going to do 34 was my degrees Celsius times 1.8 plus 32. So if I do 34 times 1.8, I get 61.2. I add 32 to that number, and I get degrees Fahrenheit is equal to 93.2. Sample question number 2, we are going to go from degrees Fahrenheit to degrees Celsius. So, two things. We can use what we did before, or use the actual Celsius formula. I'm going to pretend like a lot of us did not remember both of them, and that's totally fine. If you have it, that's awesome. So let's use the other one before so I can show you exactly how to solve for it. And I'm just going to make that an X instead because too many decimals drives me crazy. Okay, and let's fill this in. So we know we have 87 equals degrees Celsius times 1.8 plus 32. So what we're going to do is we're going to subtract 32 from both sides. So that leaves me with 87 minus 32 is 55 is equal to degrees Celsius times 1.8. If we divide both sides by 1.8, we get degrees Celsius is equal to 30 point, and let's say this, we do 5, 6, because there's 5s continuing on forever, so we could round it off to 30.56 degrees Celsius. Notice how we were able to use one formula to help us solve. So we have 16 degrees Celsius equals how many degrees Fahrenheit? So again, we're going to use that same formula. Degrees Fahrenheit equals degrees Celsius times 1.8 divided by, plus 32. So we put in what we have. Degrees Fahrenheit is equal to 16 times 1.8 plus 32. So from here, we have 16 times 1.8. That's going to give us 28.8 plus 32. So if I add 32 to this number, I get 60.8 degrees Fahrenheit. All right, our final sample question, we have 71 degrees Fahrenheit is equal to how many degrees Celsius? Let's continue using that same formula as if we've only remembered one of them. Because if you can memorize one and know how to solve for the other, then it's less memorization that you have to do, and then you're actually even enhancing your algebra skills, which 2 birds, 1 stone. So we have 71 degrees is equal to, we don't know the degrees Celsius, so I'm just going to put this as C times 1.8 plus 32. We are going to then subtract 32 from both sides. So if I do 71 minus 32, I get 39 is equal to C times 1.8. And we're going to divide both sides by 1.8. And when I do that, I get, this cancels out, so I get my degrees Celsius is equal to 21 point, and you'll see all those 6's repeating, so we're going to write that as 21.67. We'll round off the second one, degrees Celsius. As always, pay attention to what your answer choices may be. If it's a fill-in, it may tell you to the nearest whole. Either way, you will be okay. All right, we've come to the end of our lesson here. It is your time to go forward, to go really try this out. And can't wait to see you soon. Good luck.